Hi students, welcome to Vedantu NEET English. I am Diksha Kaushal, your chemistry master teacher. And students, today we are going to do class 12th of chemistry and physics and bio and zoology. There's zoology and botany, all of them, right? But already Sher sir and Gopika ma'am has taken their class, right? I know from 9 a.m. you are working hard. I'm really proud of you, right? You already know that when you had your class 11th full, chemistry, physics, bio, I was there with you till midnight, right? So today also I'll be there with you, but what you have to do is don't lose the patience. And as now with full power, you have completed your physics and zoology class. After this, I'm going to start the chemistry section, solution, electrochemistry, be it chemical kinetics and also redox reaction that we skipped while we were doing class 11, electrochemistry, everything we are going to do today. But for that, I want to see your energy in the chat box. Yes, students? Where is your energy? Everyone, have you shared this on your Telegram channel? Have you shared this on your WhatsApp status, on your Instagram ID? You can also tag me over there, Diksha__Kaushal, right? So that I can also know that you guys appreciate the efforts that we put into, right? So energy is high. Everybody, energy is high. Definitely more than that you can expect. Just give me a second. Shall I start with the physical chemistry? Right, already you had your break, right? That's why I started a little bit late here. I was watching Gopika ma'am at 6 p.m. directly. She ended the class. At that time, I was thinking that starting just within 2-3 minutes, they will get exhausted. So that's why I was like, okay, let's give them 10 minutes break. At least within 10 minutes, they will be a little bit fresh and will be like little bit like, okay, now I have the time to get out of zoology and then jump into chemistry. Right? Okay, let's go. Let's start. Okay, let's start the session starting with the first part, that is the solution chapters here. Right? In solution chapters, two topics are very important. One is colligative property, then there is ideal, non-ideal solution. So one by one, we are going to see that. First is your Henry's law. What is Henry's law? So if you see, Henry's law state that solubility is directly proportional to pressure, right? As the pressure increases, solubility will increase. As the pressure decreases, solubility will decrease. That is why when, let's say, you go to mountains, so have you ever seen your packet of Lay's and Kurkure, right? What happens there? It will have more fluffiness in the packet, right? It will get spread out. Why? The reason is because as you go up, right, in the atmosphere, what will happen? The pressure is going to decrease. As the pressure decreases, solubility also decreases. That is why some people, not in fact, if you are not very, not a healthy person, then what will happen? In the mountains, you will find it very difficult to take, to breathe in the mountains, right? So suffocation, sometimes people suffer from that, right? Now, let us see. This was the usual representation of Henry's law, but Dalton modified that. Solubility, we can express that in mole fraction, and that's how you get the new law, that is your Henry's law, can be written as P is equals to KH into mole fraction, right? Mole fraction in liquid phase, very important. This mole fraction is there in the liquid phase, not in the vapor phase, right? And P is the partial pressure, KH is the Henry's constant here, right? Next is applications of Henry's constant. One is anoxia, that I have already told you. As you go up the mountains, what will happen? Pressure decreases, solubility decreases, and this leads to a suffocating kind of situation that is called anoxia, right? Next is scuba divers. Now, what is scuba divers? So, scuba divers, when they dive, right, in the sea, inside the ocean, what happens? Pressure increases. That is why solubility increases. Right? You will say, man, that's a good thing. But it's not like they will stay in the ocean only. They are humans. They will come out of the ocean. Right? So what will happen? Again, pressure will decrease, and that will lead to a condition that is called bends. Okay? In that condition, what will happen? they will have maybe this is basically related to nerves. Okay, so bends will be there, and that is a very disastrous situation to the body, right? Next is cold drinks. So now in cold drinks, what you will see, why in Coca-Cola bottles the pressure is at very high, there is very high pressure. So when you shake the bottle, you will see, and when you shake the bottle, you open that bottle, there will be a burst of Coca-Cola outside your bottle, right? Why this happens? Because the pressure, more solubility. That is why Coca-Cola is there in the bottle at a very, very high pressure, because we need to make the carbon dioxide soluble in the in that way. Okay, right? Yes. Next we have is solubility. This part we have covered. Now, next is solids in liquid, gases in liquid. Gopika ma'am is there in the class, right? She is like break. I'm saying break is given to it. It's not like, guys, you are only the one who is there, who is studying. I know you are studying from there from 9 a.m. You know, there are so many students out there who are self-studying, right? They are making day and night one, right, in achieving their dream, right? So you have to compete them. I know you can't exhaust yourself. It's just today. Tomorrow you can relax. Tomorrow you can solve any mock test. You can relax. You can solve questions. Relax for that time. But today you can't give up, right? So you have to be here. That is your dedication. And that dedication I need in my future doctors. If that dedication is not there, then how can you imagine that you will be able to beat so many other students? Lakhs and lakhs of students you have to beat. There are very less seats and so many competitors out there, right? So you can't just give up like that, right? Now, next is solubility of solids and liquids. So when you talk about solids and liquids, let's say solids and liquids is, let's say you have sugar in the water, right? In that case, there is no effect of pressure. Why there is no effect of pressure? Because solid is incompressible. That is why no effect of pressure. But when we talk about temperature, what happens? Just like Lee-Chartler principle we discussed, that when we increase the temperature, like the equilibrium constant was opposite in exothermic. In the same way, when you increase the temperature in the exothermic, solubility is going to decrease, and in the endothermic reaction, solubility is going to increase here, right? Okay. Next we have is gases and liquid. Now gases, both pressure and temperature is going to affect, right? How pressure is going to affect here? As you increase the pressure, so when you're increasing, there is gas, when you're increasing the pressure, the molecules are coming closer to each other. That means the solubility is increasing in that case. And if I say as you increase the temperature, molecules are moving away from each other. That means solubility is decreasing. And the example is, for example, fissures in cold water. So in cold water, fishes, what will happen to fishes? Fishes wants to stay in cold water, because if the temperature increases, fishes need oxygen to survive. You also need oxygen to survive. I also need oxygen to survive. Fishes also need oxygen to survive, right? Now, in the aquatic life, they will get oxygen dissolved in the water. So that means oxygen will be soluble in the water. Now, if the temperature raises, the solubility will decrease, and that effect we can see now. If you have seen in, I think, Kerala somewhere, some aquatic life, that was the world will end. Like, I don't know if that will end or not, but what is the reason behind that? But logic says that why this aquatic life is coming out of the ocean. Reason is because the temperature is increasing. That is why the oxygen solubility is less. That is why it is very difficult for the species to stay in the ocean. That is why they have to come out of the ocean. Okay, understood? Now is that clear? Now is that clear? My voice was audible to you? Yes, students? This I taught you, that when you increase the temperature, solubility decreases. That is why now we hear all the things that aquatic life is coming out, right, from the ocean. Reason is because the oxygen supply is not there in the ocean. They have to come out. It's because of global warming that we are doing. And then we are saying I think some doomsday fishes coming, right, in Japan or somewhere, and they are saying that, okay, it will lead to like world will end and all these things. I don't know if that is true or not, but this definitely is true. The logic behind that is this thing, right? Okay. Now, next topic is Raoult's law. Now, Raoult's law states that first is this is your partial pressure. It states that partial pressure is equals to pure vapor pressure multiplied by mole fraction. Right? When you add these two things, you will get the total pressure. You can write the total pressure because we know that mole fraction of A and mole fraction of B is equals to 1. That is a mole fraction of all the components is going to be 1. Right? So that is why if you replace this mole fraction of, if you write only this in terms of mole fraction of A, that means you replace mole fraction of B is equals to 1 minus mole fraction of A. This is the answer you will get. If you replace this with 1 minus mole fraction of B, this is the answer that you will get. Okay, so according to that, if you want to get your answer in mole fraction of B or A, that totally depends. But original Raoult's law is this is your Raoult's law, right? Now, based on Raoult's law, you have ideal and non-ideal solutions. If let's say your solution follows Raoult's law, we say it is ideal solution, right? If it does not follow Raoult's law, it is non-ideal solution. Okay. Now, ideal solution delta V mix and delta H mix is always 0. There is no change. But when we talk about non-ideal solution, we say that, okay, here you have, it does not follow Raoult's law, that is non-ideal, and it is of two types. One is positive deviation, other is negative deviation. In positive deviation, delta H mixing and delta V mixing is greater than 0. In negative deviation, delta H mixing and delta V mixing is less than 0. Right? Ma'am, what about this delta S and delta G? Always delta S mixing is always positive. Doesn't matter it's ideal, non-ideal, positive, negative deviation, doesn't matter. Always delta G mixing is less than 0. Doesn't matter which kind of solution it is. Right? This always remember this thing. Right? Next is, ma'am, in positive deviation, what are the interactions? Okay, how you will remember that? So in positive deviation, things will be opposite. That means interactions of AB will not be that much good. AB interactions will be weak. So if let's say Chintu and Purani, right, they are not talking to each other, they are not chit-chatting with each other, they are rather focusing here on the screen. That means they have positive deviation. Their interactions are less, their result will be positive. If you're, rather than answering Diksha ma'am, you are chit-chatting with each other, this and that, okay, did you eat dinner, this and that, you're chit-chatting with each other, you have negative deviation. Why? Because you are like, okay, I will prefer chatting with the other person, just 20 days away ma'am, doesn't matter ma'am, I'll chit-chat, right? So what will happen? You will fall in the region of negative deviation because your interactions are strong, right? This is how you can remember this, right? So that is your ideal and non-ideal equation solutions. And here you have your examples of ideal, non-ideal solutions. Okay, this I have written this over here. You can see any of the example. Let's say ethanol and CCl4. Here exactly what happened. Initially you had ethanol had hydrogen bonding, but after adding CCl4, the hydrogen bonds will break. That is why AB interactions are less, and that is the reason it is positive deviation. Here water had hydrogen bonding. When you add CHCl3, hydrogen bonds will break, and hence it is a positive deviation. Right? Similarly, here what you will have, here H2O already had hydrogen bonds. When you add HCl, again you will have more hydrogen bonds because this H is also electropositive, right? Even here the same thing will happen, here interactions are going to increase, right? That is the reason they will show negative deviation, right? Examples, that's why chart I have shown you, you have to learn all the examples. Direct question can be there, which of the following is an example of positive deviation, which of the following is an example of negative deviation, right? Next we have is colligative properties. Now one more thing, let's say benzene and toluene, those which are analogous, which are homologous of each other, or which have only difference of one atom, let's say chlorobenzene or bromobenzene, they are ideal solutions. Okay, now next we have is colligative properties. So basically we have four kind of colligative properties. right? First is relative lowering in vapor pressure. This means that P naught minus P divided by P naught is equals to mole fraction of solute. 2 always, 2 means we are talking about solute, right? And 1 means I am talking about solvent. Okay. Now, what is this I? I is Van't-Hoff factor. Okay, I is Van't-Hoff factor that you should put here, right? Van't-Hoff factor, whenever you have a electrolyte which is undergoing association or dissociation, then you have to put the value of Van't-Hoff factor here. Otherwise, for non-electrolytes like urea, glucose, Van't-Hoff factor is going to be 1, right? Now, how we will calculate the value of this Van't-Hoff factor? Van't-Hoff factor is number of particles after association, dissociation by number of particles before, or normal molar mass by observed molar mass. But these two formulas are usually not in use, right? This formula is in use, right? They will give you that this is the degree of dissociation, this is the degree of association. If you have dissociation, then this is the degree of dissociation, this is I, you will calculate the Van't-Hoff factor. N is the number of particles that it is giving after dissociation. Okay, one molecule, how many particles it is giving. Then I for dissociation is always, Van't-Hoff factor is always greater than 1. For association, Van't-Hoff factor, wait a minute, this will not be this. Okay, this will be less than 1 and this will be greater than 1. So you can just write it, yes. So now here, if you see, alpha is equals to I minus 1, 1 by n. N is the number of, for example, it is dimerizes, it trimerizes, that is the value of n, right? I is a Van't-Hoff factor, alpha is the degree of association in this case, right? And next is Van't-Hoff factor, this we have done. Now here it is, what is delta T, what is first colligative property was relative lowering in vapor pressure. Second is relative elevation in boiling point. So that is delta TB, which is equals to TB minus TB naught, bigger minus smaller, okay, because there is elevation. I into KB, KB is the libuscopic constant, M is the molality here, right? In this case, you have delta TF is equals to TF naught minus TF. Here, this is the larger value because there is depression in the freezing point, okay? And here you have I into Kf. Kf is the cryoscopic constant. M is the molality here. Next, students, we have is the value of C here. C is what? What is molarity? And here last colligative properties, osmotic pressure, that is equals to ICRT. I is the Van't-Hoff factor, C is the molarity, R is the gas constant, and T is the temperature. One thing to remember here is molarity is equals to number of moles of solute, number of moles of solute, number of moles of solute multiplied by weight of solvent multiplied by 1000, if all of them in gram. Molarity or C is equals to number of moles of solute divided by volume. If it is in milliliters, this will be multiplied by 1000. These two things you should know, right? Okay, understood? Next, let us do some questions based on this. First question is elevation in the boiling point for 1 molar solution. Now they are saying elevation in the boiling point for 1 molar solution. That is going to be 1 molar solution. That means molarity is given to be 1. Elevation on boiling point of this is 2K. The depression in the freezing point of 2 molar solution, molality is given to be 2. Of glucose is the same solvent is 2K. That means, can we say that delta TB is equals to delta TF? And here we are talking about glucose, that means Van't-Hoff factor is 1. So here I can write Kb multiplied by molality, and this is Kf multiplied by molality, right? Molarity for this solution is 1. This is Kb. Molality for the solution which is undergoing depression in freezing point is 2. This is Kf. It will be cancelled, not cancelled. They are asking you the relation between Kb and Kf, right? So Kb is equals to 2 into Kf, right? Kb is equals to 2 into Kf. So answer is going to be D is your correct answer here. So answer will be, wait a minute. Wait a minute. Is it given to be 2? Both are given to be 2, right? So 1 molar solution of glucose is this. This is given to be 1. That is given to be 2. Wait a minute. With the option, the marking of the option is wrong here. Right answer will be D only. Right answer is D only. Right answer is D here. Okay, answer is D here. Right, KB is 2KF. Next question is a solution containing 4 gram of polyvinyl chloride. 4 gram of polyvinyl chloride the solution has. Right, 4 gram of polyvinyl in 1 liter of dioxane was found to have an osmotic pressure of this. Osmotic pressure is represented by pi. Pi is equals to CRT. This is the formula, right? Now they have given you W2, that is they have given you the weight of the solute. They have given you the volume in liters, right? Was found to have an osmotic pressure this much. What is the molecular mass of the polymer? Molecular mass they are asking you for the polymer, right? Now here what you will use? Directly it is a polyvinyl chloride. I is equals to 1 here. So it will be pi is equals to CRT. What is C? C is the molarity here. Molarity is, you can see, weight divided by molar mass multiplied by volume in liters multiplied by R and T. Now here you have molar mass you have to calculate. W2 is given to you, liter is given to you, R you already know. Temperature is also given to you. Pi is also given to you. So directly you can calculate the value of M here by using this formula, right? Okay, you just have to put this formula. I would say take the value of R as 1 by 12 rather than 0.0821. Okay, reason being because in fractions it will be easy for you to do the calculations rather than putting the value as 0.0821. Right? So directly you will put this value as 1 by 12 here and you will get your answer. Is that clear to everybody or not? Is that clear to everybody or not? That is clear. Now, next is chemical kinetics. Okay, second chapter is chemical kinetics for you. Here, majorly from 2 topics, the questions they ask you. 3, 4 small topics we have, 2 major topics we have. So I'll discuss all the topics here, right? First topic that you will have here is based on your reactions, right? That is a small topic. That is, they will ask you from simple question like rate of reaction and rate of appearance and disappearance they can ask you. So for that, what you need to know is, for that you should know one thing, that whenever you are calculating the rate of reaction, okay students, whenever you are calculating the rate of the reaction in terms of whether reactants or products, always it will be divided by the stoichiometry here. So when I calculate the rate of reaction, I am dividing it with the stoichiometry. When I am calculating the rate of reaction, I am dividing it with the stoichiometry. When you are calculating it in terms of reactants, because reactants are getting disappeared, there will be minus sign. When you are calculating it in terms of products, products are getting appeared, so there will be a positive sign. Okay. Now, same thing is applied in rate of appearance and disappearance of a specific reactant. But when you are calculating for a specific reactant or specific product, in that case, you will not divide it with the stoichiometry. So let's say the rate of reaction of this particular reaction is, in case of reactant it is minus, in case of reactant it should be minus. Wait a minute students, let me just clear that thing here, right? Let me just write that thing here. Wait a minute. Uh-oh. Uh-oh. Tell me what is the wrong part here, what I am asking you. Chalo. Here it should be minus and here it should be plus. Okay. Why? Because it is getting disappeared. It is getting appeared. So rate of reaction is negative and it is divided by stoichiometry. It is not. It is also divided by stoichiometry. But when I calculate the rate of appearance of product, then I am not dividing it by the stoichiometry. Here it is 1 by B dB by dt. Here it is simple dB by dt. When I am calculating the rate of disappearance, I am not dividing it with A. I am simply writing dA by dt. Okay, that is the first concept of this chemical kinetics, which you have to divide, which you don't have to divide. Second concept is regarding the order of the reaction and to know the direct formulas of units of rate constant and T half in terms of order of the reaction. Okay, so directly if I take R naught as the initial concentration, so what I'll have here, right? So now the second main concept is what you should remember here is, if you have, let's say, any reaction in equilibrium, we used to say product raised to power stoichiometry divided by reactants raised to power stoichiometry. But in this case, we will not write that. Rather, what we will say, you should know the rate of the rate law equation. In rate law equation, the powers, when you add all the powers, then you will get your order of the reaction. Okay, so when you add x plus y, that will be the order of the reaction. So in terms of order of reaction, the units of K is mole per liter 1 minus 1 per second. Let's say you have 0 order reaction, N will be 0. First order reaction, N will be 1. Second order reaction, N will be 2. Beyond this, they will not ask you, right? T half is directly proportional to initial concentration raised to power 1 minus N. And based on this particular simple relation, lot of questions you can ask based on T half, based on the, let's say for 2 initial concentration, 2 T halves are given to you. Directly you can answer this from this formula. Very, very important. Very, very important. Right? Okay. Now, third concept I'll do in the end. Firstly, let us see this order of reaction. 3 formulas you have here. First is 0 order reaction, then first order reaction, then you have second order reaction. For 0 order reaction, this is the formula of K. Rate constant is equals to initial minus final divided by T. T half, that is when concentration is half, right? This is initial by 2K, right? First order reaction is extremely important. See, mainly 2 formulas are important. Most probably 99% if they ask you a question based on the orders of reaction, they will ask you first order reaction. Then if they don't ask you first order, chances are they will ask you 0 order. Very rarely they will ask you second order reaction. Very rarely, right? Okay, but still to be safe, I have given you all the formulas here. But most important formula is K is equals to 2.303 log of initial by final, T half is equals to 0.693 by K. Here the important thing is, sometimes in calculating the first order reaction or either any of the reaction, sometimes they don't give you the initial or the final concentration. Rather what they say, that the percentage they will give you, right? That 60% is left, 60% is consumed. So you'll always take, when it is given in percentage, you will take initial as 100%, right? And final, let's say if they are saying that this much is left, then this is the amount that is left behind. If they have given you 60% is left behind, so that will be 60 in the final concentration. Directly you can write 60, right? So you'll take initial as this, and if they say you have 60% is left behind, you will say 60. Let's say if they say 60% is consumed, that will be 100 minus 60. So that depends on the language of the question, okay? Next is, let's say ma'am, they have given this in the terms of fraction. If they have given it like this, that you have 1 by 4th is left, 3 by 4th is left, 1 by 4th is consumed. In fraction, what you will say, that R naught you will take it as 1. This will make your calculations very simple. Let's say they are saying in the question that you have 1 by 4th amount is left behind. That means RT will be 1 by 4. Right? Let's say they are saying 1 by 4th amount is consumed here. Then I'll say it is 1 minus 1 by 4. That is 3 by 4. Got it? That is how you're going to solve the numerical question based on the order of the reaction. Okay, if that is given in, let's say they have given it in percentage or the fraction. Now, next important part is regarding the order of the reaction. So sometimes what they give you, first important concept is regarding the, if they say rate is dash times, okay, and concentration is X times. Now, what you will see, you will have to put one formula you should remember, that new rate, this is the new rate, is equals to x raised to power n of old rate. I'll give you one example. Example is, they will ask you these two things I am writing for to calculate the order of the reaction. This is very useful thing. They will say that rate has increased 4 times. Rate has increased 4 times. That means R dash is equals to 4 into R. And they will say concentration is doubled. Concentration is doubled. Now you tell us what is the order of this reaction. Now you need to tell us what is the order of this reaction. So anybody in the chat box? Anybody? So what you have to be, otherwise you will see this and that, and you will get confused also here. But now easy method is, this is R dash is 4R. Ma'am, R dash, this X is the times the concentration has increased. So it is 2 times. So this means they have given you X is equals to 2. So this will be 2 raised to power n into R. That means you have to equate two things, that is 4 is equals to 2 raised to power n. It means n should be equals to 2. Only then 2 raised to power 2, that is equals to 4. So answer will be, it is a second order reaction. Okay. That is how you are going to solve a question like this. Right. Either directly they will give you this kind of question, that this concentration is double, triple, rate is 4 times, 8 times, whatever. From this you can solve. Or what they can give you is, they can give you some table. Okay. Or they will give you some table. In that table, what they will do? In that table, you must have seen these kind of questions. Okay. You must have seen these kind of questions. In that table, usually students write it, ma'am, firstly I'll solve this for first case, second case, I'll take ma'am 5 minutes to solve this. No. Okay, let's say they have given you A here, they have given you B here, and they are asking you that what is the dependency of A and B, what is the full order of this reaction, that you have to tell. Let's say with respect to A it is X time, with respect to, basically they are asking you the order of reaction with respect to A and B. Rate they have given you here. Now they will give you experimental data. I am taking very simple values here because I just want to tell you the steps here. Right? Let's say concentration is 2, concentration is 2, concentration is 4. Here rate is 2, rate is 4, rate is, wait a minute, rate is 2, rate is 8. Right? Okay, I'll just write 1 here. Rate is 1, rate is 3. Okay. Here concentration is, let's say 2, or I'll write 1. Concentration is 2. Let's say concentration is 4. So I'll write it as 2 only, and here also it is 2. And here the rate is 2. Now whatever values they give you, what you have to do from the table, you have to select. First, you will select that thing where concentration is constant. Here, you will ignore A because here concentration of A is constant. In first two parts, you will see what is the dependency of B. In first case, what you will see that, ma'am, here what is happening? R rate is getting doubled. Rate is 2 times. But here concentration is also getting doubled. That means R dash is equals to 2 raised to power n of R. That means n should be equals to 1. That means with respect to B, order of the reaction is 1. Is that clear? In the same way, now you have to make this constant. If this is constant, this is changing. This is getting 2 times. So this will be R dash is equals to 2 times of R. But here rate is getting how much times? This is ajeeb times. So I'll rather write it as, because there should be some, they will give you some good values only. Okay. So this is getting 2 times, and here this is getting how many times? 3 times. Okay. This is getting 3 times. I'll write it as 4 times only. Right. Because they will not give you some weird values here. 2, 3, 4, these kind of values only they will give you. Right. So this is getting 4 times. So that means R dash is equals to rate is getting 4 times. Wait a minute. Rate is getting 4 times and concentration is getting how much times? 2 times. This is 2 raised to power n of x. Concentration raised to power n of x. So that means n will be equals to 2 here. So that means the rate of the reaction is k, a raised to power 2, b raised to power 1. That is the total concentration. Is that clear to everybody? That is the total concentration. If that is clear to you, then let me know in the chat box. These are the two kind of questions that they can ask you. Right? Okay? Understood? Now, one more type of question, that is based on Arrhenius equation. So, Arrhenius equation is k is equals to a e raised to power ea by rt, where a is the Arrhenius factor, ea is the activation energy. Either directly a graphical question based on this, then I'll just do one graphical question in front of you, or a numerical question based on this particular formula, that is log of K2 by K1 is equals to EA 2.03 R T2 minus T1 divided by T1 into T2. That is the formula that you will use, right? One more thing that they can ask you here. Anybody? Wait a minute. One more thing that they can ask you is, let's say your rate, I'm saying that you are increasing the temperature by 10 degrees Celsius. So whenever you increase the temperature by 10 degrees Celsius, rate is going to get doubled. Okay. So here what we will do, let's say they have given you some, you can just remember this thing that they're asking you the rate of the reaction, like how many times the rate will increase or decrease, right? What will be the rate? So what you have to remember here is rate is doubled when you increase temperature. Temperature is increased by 10 degrees Celsius. 10 degrees Celsius. Okay, that is the point here. Understood? That you should remember here, right? Now let us see the questions based on these chemical kinetics. That is, if a reaction follows Arrhenius equation, the plot of natural log of K versus 1 by RT gives straight line with a gradient of minus y unit. The energy required to activate the reaction is going to be this. So simple as you have to draw this graph. We know that K is equals to A is equals to minus EA by RT, right? That means natural log of K is equals to natural log of A minus EA by RT, right? That is the value here, right? That is the value here. Now what you will see, this is y is equals to, if you want to plot a graph between y and x is your this is your x, 1 by RT. So this is y is equals to, this is mx and this is c. So can I say that c is equals to natural log of A and EA is equals to minus of, or you can say slope is equals to, because graph is between 1 by RT. So slope is equals to minus EA, right? Slope is equals to minus EA, and they have given you with a gradient of minus y unit, means they have given you the slope here. If slope is equals to minus y, that means minus y is equals to minus EA. So answer of the reaction is EA is equals to y. So answer will be y is the correct answer. Okay, y is the correct answer. Right? Gradient means they are giving you the slope here. Right? From that you can answer the graphical questions based on this. Right? Okay. Next is the half-life of a reaction is inversely proportional. Now they are saying that the half-life of a reaction is inversely proportional to the square of initial concentration. Now what you have to do here? They are saying half-life is inversely proportional to square of initial concentration. That means, can I write it as R naught raised to power minus 2? And I also know the general formula that T half is directly proportional to R naught 1 minus N. That means, can I say 1 minus N is equals to minus 2? That means if I take N here, N is going to be 3. So answer means they are talking about a third order reaction. So just from this simple formula that you know, simple relation you are able to calculate this, right? Okay, so very nice questions they will ask you from chemical kinetics. It's a very, very scoring chapter, very scoring chapter. Okay, don't miss the questions from chemical kinetics at all, right? Next is, for a reaction of H2 with I2, the rate constant is this at some temperature, and this is at this temperature. So basically T1 is given to you, T2 is given to you. But if something is given in T1, T2, right, and rate constant K1, K2 is given to you, one thing should click in your head, that this is log of K2 by K1 EA 2.303 R T2 minus T1 divided by T1 into T2. This is the formula that you are going to use here. Everything is given to you. K1, K2, T1, T2. They are asking you to solve the value of EA. Now you tell me what is the value of R you will put here. When we were doing solutions chapter, I asked you to put the value of R as 0.0821, right? That is 1 by, see, R has two values, okay? R has two values. One is 0.0821, other is 8.314, third one is 2. This is when, this you can write it as 1 by 12 also, this you can write it as 25 by 3 also, this is simple too. This you will solve when things are given in joules. This you will do when things are given in atmospheric liter. This you will do when things are given in calorie. Okay, this is how you will get an idea what is the value of R that you should use here, right? So that is, you will use 1 by 12 here. Very good, very good. Not 1 by 12. Here you will use 25 by 3 because you are talking about energies. You are solving activation energy. So you will use 8.314. Okay, so you will use 8.314. That is, wait a minute, let's see here. 8.314 they have used. I'll use 25 by 3 to make the calculations easy, right? Okay, that's how you're going to do it, right? 8.314 not atmospheric, right? Okay, wait a minute. I have written opposite here. I think I have written opposite here. I'm so sorry. By mistake, I have written there. This you will use when things are given in atmospheric liter. This you will use when things are given in joules. So here things are given in joules. So that's why you will use 25 by 3. By mistake, I have written the opposite. In my head, this was going on, right? So 25 by 3, that is 8.314 when you're talking about energies in joules, kilojoules, right? Okay, that's why this is what you will answer here. Next is electrochemistry. Next is, students, electrochemistry, right? Okay, very good. Things are in joules, 8.314. Things are in calories, 2. Things are in liter or atmospheric, 0.0821, that is 1 by 12. Okay. Now, next is electrochemistry. Now, let us talk about electrochemistry. It's a big chapter. Let me be very frank with you, right? Firstly, do you want to complete redox or electrochemistry? Let me know in the chat box. I will suggest you, let's firstly do electrochemistry, because in redox reactions, see, simply two things I am going to focus on. One is the balancing of reactions that we will do in the end. Okay, because that is eventually not a very, very important topic. Okay, so I am focusing on very, very important topics. Right, earlier they used to ask questions based on this. Right now, so it's not that many questions are asked. Okay. Don't worry, that will be uploaded. Okay, don't worry. YouTube takes its time to upload when the streams are different. No, so YouTube will take time to fetch those two streams together, and that's how you will get your physics stream as well as Gopika ma'am lecture and Shreyas lecture both together. Don't worry about that. Right? Now let us talk about electrochemical cell. So in electrochemical cell, you have two kind of things. One is electrochemical cell, other is electrolytic cell. So this is a big chapter. So full concentration for next 20 minutes should be on this screen, right? Full concentration. And I want you guys to write it down. Whatever you know about this lecture, write it down in the chat box. That, ma'am, this I know, write it down. Right? Two things, electrochemical and electrolytic. Electrolytic we will do afterwards, but first is electrochemical. That is chemical to electrical energy. So here you have LON. Learn LON. Loss of electron, oxidation, anode, and anode is a negative electrode, right? Next is anode is negative, cathode is positive here. But in case of electrolytic cell, things are opposite, right? Here, loss of electron, there is oxidation, that is at anode, but anode is a positive electrode, okay? Anode is a positive electrode here, right? That is the difference, very important thing, right? Next, let us see electrochemical cell. One kind of electrochemical cell is Daniell cell, where you use zinc and copper. Okay, so this is the diagram, right, that I have drawn in front of you. And here you have Daniell cell. So here what you will see, firstly let us understand what we are going to do here, right? First thing is the one which has more reduction potential in the electrochemical series will be at the cathode. That will gain the electron. So what we will see here, that copper has more reduction potential of 0.34, right? That is, copper has positive reduction potential. That's why copper will tend to be on the cathode side. It will gain the electron, it will get reduced, right? That's why it will gain the electron, it will get reduced to Cu, right? Anode, you will have zinc, that will lose the electrons, and that is why this is causing oxidation, right? Two things. Next is, what exactly is happening here? Always remember AC, right? I have switched on the AC. So here also you should remember AC. AC means here you will have anode side and here you will have cathode side. Okay? Anode side, cathode side. At anode, what will happen? There will be loss of electrons, right? So there was zinc sitting in the solution, right? So here you had zinc electrode. Here you had Zn SO4 electron. Okay, this was the Zn SO4 electron, right? I'll just it should be less now, this much, and this was your copper electrode. Okay, so now what you observed here, what you will observe here, that Zn SO4, right? Because here zinc is losing the electrons. So this Zn this Zn is from which thing? This Zn is from the electrode, from the anode part. Zinc from the anode part will start losing the electron and its anode will tend to decrease, right? Anode will decrease. And what will happen on the cathode side? Copper 2 positive ions in the solution will gain the electron and they will start increasing. So hence what you will see, that there is more mass, more copper on this electron. So what will happen here? Thickness of anode will decrease, thickness of cathode will increase, right? Next is to balance this charge here. So why balancing of charge was required? Because here you have which thing? Here you have, let's say, electrons are getting, there are more cations in the solution. So because of more cations in the solution, tell me what will happen. This will acquire a positive charge. Here you will have more negative ions because of SO4 2 negative, that will be left behind. That is why it will be negative. That is why we will need salt bridge, right, to balance it. So salt bridge is a U-shaped tube which is having agar-agar solution. And in this case, the condition is the mobility of cation and anion should be same. If the mobility of cation and anion is same, in that case, we can say that yes, this can act as a salt bridge electrolyte, like you have KNO3, KCl, they can act as an electrolyte, right? So here, anionic part, that means the negative part of the electrolyte, let's say from KCl, the anionic part will move towards anode and the cationic part will move towards cathode. Because negative part, because this overall will be positive, this overall will be negative. So it needs a negative charge, it needs a positive charge to get neutralized. That is why here negative part, here you will have positive part, right? Next is the flow of electrons. If you see the flow of electrons, so what you will see, flow of electron, as you can see, zinc is losing the electrons. So from anode to cathode, it is catching those electrons. So flow of electron is from anode to cathode, right? So electron, wait a minute, anode to cathode means zinc to copper. So you can also write it as anode to cathode. And the flow of current, if you have seen physics, right, flow of current is opposite to that of flow of electron, that is from cathode to anode. Right? Now, this diagram is given in your NCERT. that let's say you are applying some external potential here. So if you apply some external potential, because the potential of this cell is 1.1, if that is greater than 1.1, then cell will get reversed. That means what will happen? Electrons will start flowing from copper to zinc and current will from zinc to copper, right? Reverse will happen. If external is equals to the same, that is 1.1, cell will stop. If external is less than 1.1, then nothing will happen. Same thing, same situation will go, right? Okay. Next is the electrode potential. So when you talk about standard electrode potential, now we are moving towards the numerical based question. Till now, I was doing the theoretical question of this chapter. Now we are moving towards numerical based questions, that is E naught value, that is E naught cathode reduction potential minus E naught anode reduction potential. Remember, always there will be reduction potential. Reduction potential means always you will see gain of electron or you will see oxidation number will decrease. This is from redox reaction. That's why I told you there is no use of doing redox reaction separately. I'll teach you redox reaction in between here only. Redox reaction means that I'm writing the things here, right? From redox reaction, what is useful? For oxidation, everybody write it. For oxidation, oxidation number should increase. For reduction, oxidation number should decrease. Okay, this is what you will know from there. Reduction potential means you will see always, whenever you see the potential here, this will be A positive to A. Now tell me, is this reduction potential or oxidation potential? From +1 to 0, that means the oxidation number is decreasing here. That means this is reduction potential. If let's say it is E naught of -2 to 0, then it will be oxidation potential because oxidation number is increasing here, right? That's how you will judge whether it's reduction potential or oxidation potential, right? Always it is Ca, that is E naught of cathode minus E naught of anode. But in the representation, it is written as AC. See, simple thing is when you draw the diagram, it is AC. So in the representation also it is AC, right? But when you're writing E naught cell, there is some reason behind that. When you do the derivation, you will get to know. But now we don't have time for derivation, right? So directly learn E naught cathode minus E naught anode, both reduction potential. In representation, you have anode and cathode. In anode, oxidation number is increasing. In cathode, oxidation number is decreasing. And this double two lines, this is representing the salt bridge. And this single line is representing the phase change, because this is solid, this is aqueous, so phase change is there. If there is no phase change, you will draw comma, but rarely you will see comma over there, right? Now, very, very important theoretical based question based on this, that is, first thing is students learn reduction potential. So, do you need to learn the values of reduction potential? No, you don't need to learn the values of reduction potential. That will be given in the question. They don't expect you to be a big crammer. You have to cram everything that is written in the book, right? No. But what you should know is the relation. If something has very high reduction potential, they would want to get reduced and they would want to oxidize someone else. That means they have a very high oxidizing power. So reduction potential high means oxidizing power is very high, right? I want to get reduced. So I want to oxidize someone, my oxidizing power is very high. If oxidizing power is high, reducing power is opposite to that. If reduction potential is high, oxidation potential is opposite to that. Usually what they ask you, they will give you reduction potential, they will ask you oxidizing power, that is directly proportional to each other. But here I have given you all the things because I don't want to take any risk here, right? Okay. Next is numerical from this page, either from this section or from this section or from this section, you will see one question in the exam, either this or this or this. Very, very, very important. So now what is that, ma'am? First thing is Nernst equation. Nernst equation, E cell is equals to E naught cell. This you will see from E naught cathode minus E naught anode, right? N is the number of electrons gained or lost, that is the N factor, right? log of oxidation by potential, or you can say log of product by reactant. You can write this thing or that thing, totally your choice. Oxidation by reduction or product by reactant raised to power the stoichiometry. Okay, raised to power the stoichiometry. Now, these are the three formulas, three relations. Either they will ask you question based on Nernst equation. It's not like they will ask you this also, this also, this also. Any of this, any one they will choose, right? So here is delta G and E naught cell, the relation. Delta G is minus NF E naught cell. F is Faraday, that is 96500. N is N factor, number of electrons. Delta G and equilibrium constant, because at equilibrium, this E value, right? What you will see, wait a minute, from this formula, basically, we have got this. At equilibrium, E cell is 0. That is why E naught cell is equals to 0.059 divided by N log of Kc. Because this is nothing but this is Qc. Right? So at equilibrium, Qc is equals to Kc. That is why this formula you will have here. Right? Now, when you equate these two things, you will get this. That is delta G is equals to minus 2.303 RT log of Kc. This we have done yesterday also. I have also done one numerical based on this question. Okay, yes, in class 11, because in equilibrium also you have this formula. This I think we have done in class 11 physical chemistry also. Spontaneous is delta G is negative. If delta G is negative, let's say this is negative, this will be positive, right? If delta G is negative, then this will be greater than 1, right? So if this is positive, let's say this is positive, this will be negative, right? If this is positive, log Kc will be positive, right? Sorry, log Kc will be negative. Log Kc negative means Kc is less than 1, right? Okay, at equilibrium, both the things are equals to 0, right? Okay. One thing I forgot, that is conservation of energy. Very important question. Right now, usually I'll tell you, basically, firstly, they used to ask question from here. Then they shifted to this place. Now they have shifted to this place, right? So that's why I feel that either they will, this has rare chances because it's a very old trend. I think if they want to make a good paper, they will ask from this part. If they want to make like easy calculation, they want to make tough, then they will ask from this part, right? Okay. So conservation of energy is if you have A to A positive to A2 positive. These are the things that you have. Here, this is the electrode potential. Number of electron exchanges N1, number of electron exchange N2, number of electron exchanges N3. Then we know that E naught, electrode potential is not conserved, but delta G is conserved. So delta G3 is equals to delta G1 plus delta G2. Right? So now you will put the value minus NFE minus NFE minus NFE. NF minus will get cancelled, Faraday will get cancelled, and you will have this as your solution. And here they can even ask you E3 naught, they can ask you E1 naught, they can ask you E2 naught, depending upon different things. For example, you have Fp, Fp to Fp2 positive, Fp to Fp3 positive, right? So here Fp to Fe2 positive, you have 2 electrons. Fe2 to Fe3, you have 1 electron. Fe to Fe3 positive, you have 3 electrons, right? And you have written E naught, they will give you maybe for this or this one. They will ask you for Fe2 positive to Fe3 positive, what is the value of E naught? Directly you can answer. Okay? Understood? Yes, students, that is clear or not? Everybody, is that clear? Next part is, see, I told you this chapter is lengthy, okay? So that's why it is equal to 2 to 3 chapters. Electrochemistry is a big chapter, okay? Now, 2 things we have completed till now. This is a different category where we are talking about the conductance conductivities, okay? So for this, you need to know that there are 2. First thing is, from here also now they are asking you question from this equation. That is molar conductivity at concentration C is equals to molar conductivity at infinite dilution minus of A under root C. So when you draw a graph between under root C and molar conductivity, intercept is this molar conductivity at infinite dilution, and here slope is minus A. That means you got an intercept. That means you can get For strong electrolytes, you can get the infinite dilution molar conductivity. But for this weak electrolyte, there is no intercept, right? It is going parallel to y-axis. That is why we have Corlosh law. That is why we have Corlosh law. That states that if you want to calculate the molar conductivity at infinite dilution of a weak electrolyte, then that is equals to the individual ions, molar conductivity of the individual ions that you have, right? Okay. Let's say for BaCl2, right? Molar conductivity, this is Ba2 positive, this is 2Cl negative, right? So that will be equals to molar conductivity of Ba2 positive plus 2 into molar conductivity of Cl negative. Okay. So that also depends upon how many number, what is the stoichiometry, that also you will multiply. Right? Okay. Now, next is, this is very important, that if you talk about size and molar conductivity, they are directly proportional to each other. So from this, ma'am, have they asked question? So has anybody of you seen the JEE Mains paper? Have anybody of you seen the paper, JEE Mains paper or not? If you have seen this paper, because the conducting agency is same, that is your NTA. And it's not a difficult question that they have asked from here. They have asked a question from this part also. Yes, they have asked it, right? So, except for hydrogen, hydrogen is the exception here, right? Hydrogen has very less size, even though it has very high molar conductivity. But what you do is, as size increases, molar conductivity also increases, right? So that is why this is sodium, this is lithium. So here what you will see, sodium has more size. That is why the molar conductivity of sodium is more as compared to lithium. Very, very important. Okay, right? It is inversely proportional to the size of the hydrated ion. Because see, if the size of the ion is small, size of hydrated ion will be large. If the size of hydrated ion is large, the size of ion will be small. Okay. Now, if you have calculated, see, other thing is, this I'll come to this part also, but before that you should know this thing, right? Okay. That is, resistance is R, conductance is G, resistivity is rho, conductivity is kappa, K, right? Now, G star is the cell constant. Cell constant is equals to length by area, and that is why this formula is very important. That is, G into G star is equals to K. That is, conductance into cell constant is equals to kappa. Very important formula, right? Next, this formula is not so important. R is equals to rho L by, not very important. This formula is very important, right? Then G star, as I have told you, that is cell constant. Now K. Now, mostly you will use this formula only. But what if they have done something weird in the exam? They were like, okay, and I'll take the revenge, right? They will give you per ohm meter. Now, if they give you per ohm meter in the exam, then you will say molar conductivity is equals to kappa divided by molarity into 1000. This is if they give you per ohm meter. But if they give you per ohm centimeter, then you will use this formula, kappa into 1000 by molarity, and for equivalent conductivity, it is kappa into 1000 by normality, that is N, right? Now here, you have calculated the concentration, the molar conductivity at C concentration. And here you have calculated the molar conductivity at infinite dilution from Corlosh law. So when you divide these two, you will get the value of alpha, that is degree of dissociation. And for a weak monoprotic acid, the formula of dissociation constant is Ka is equals to C alpha square. And from there, easily, directly, you can calculate the value of dissociation constant also. Okay, understood? Right, everybody? Is that clear? Last part of this thing is, that is Faraday's first law, Faraday's second law. So Faraday's first law is W is equals to ZIT, right? That means W is the weight deposited is equals to ZIT. What is that? Z is equals to equivalent weight by Faraday. What is equivalent weight? That is molar weight by N factor. So answer will be W is equals to MIT by NS. F is Faraday, N is number of electron, M is molar mass, I is the current, not want of factor. Okay, I is the current. Okay, I is the current, T is the time. T is the time here. Okay. Faraday's second law is weight of a metal. If you have two electrolytic cells in the series, then the weight of these two metals deposited is equal to equivalent weight, the ratio of the equivalent weight. The ratio of the weight of these two metals that are connected in series, right, is equal to equivalent weight of these two metals. Okay, that is Faraday's second law. Now there is product of electrolysis, right? So this, if you want to see, very important, one theoretical based question they can ask you from here. Otherwise, I will give you a direct chart from where you should know that if you have this kind of solution, what will be deposited at cathode, what will be deposited at anode, right? So here, if you see selectivity, we'll see that at cathode, the one that has maximum reduction potential, that will be selected. At anode, the one that has maximum oxidation potential or that has minimum reduction potential will be selected, right? Because you will have always two choices, right? Let's say you have Na aqueous, so NaCl aqueous, so it will be NaCl negative, then you will have OH, H positive and OH negative, right? Now you have to select between these two, you have to select between these two. That is called selectivity, right? That is why I told you this is the principle from where you select. Now, you don't need to do this for each reaction because that is very time consuming for the time that you are left with, right? But to be risk free, what if they ask you some direct question? What you should know is that inert electrode do not participate, active electrode participate. Next is water if it is under reduction, because aqueous means water. Water under oxidation will give O2, water under reduction will give you H2, right? So at O2, it will give you some minus 1.23 oxidation potential. With reduction, it will give you minus 0.83 reduction potential. This value they can ask you directly in the exam, right? If they want to make paper very good level of paper, some surprising question they want to ask you, then these two things they can ask you directly. Then why you have added minus 0.3 here? This is called over voltage, right? Okay. But if you're like, ma'am, this is going over my head, right? Those students for whom this is going over your head, you can skip this. You can skip this part, right? You can skip this if you find it very difficult, because this at this point, if you start something new, you are making, I would say, at this point, if you start something new, you will be like, okay, ma'am, I am starting something new, but I am forgetting everything that I did before. So there is no point in doing that, right? So what you will do, if you have never gone through this part, you can skip this. But this I expect, even if you have never gone through this part, you can at least do this part, right? That is NaCl, at anode will give you Cl2, at cathode will give you H2. NaSO4 at cathode will give you H2, at anode will give you O2. H2SO4 cathode is H2 and anode is O2. CuSO4 aqueous, cathode is copper, anode is O2. CuSO4 aqueous, but with the active electrode, that is copper electrode. In that case, it will be used in purification of cathode, that is purification of copper, that is cathode is copper, anode is copper 2 positive. You will purify the cathode here, copper here. AgNO3 in aqueous, cathode is Ag, anode is O2. AgNO3 in aqueous, but with Ag electrode itself, it will again do purification of Ag. That is, at cathode you have Ag, at anode you have Ag positive. This you can do and learn this directly. That will be very beneficial for you, because I feel that they can ask you directly one question out of this, right? Directly they will ask you at a node which will be formed. So directly they can ask you that kind of question. Okay. Now let us do questions based on this. Everybody, let us do questions based on this. I think I need to breathe now, and I need to take water, right? Chalo, let us try to solve this question here. Let us try to solve this. A galvanic cell is set for from electrode A and electrode B, right? So there is electrode A and electrode B. Reduction potentials are given for both of them. Which of the following statement is false? Standard EMF of the cell is 0.56. See, which will be taking part as cathode? The one that has more reduction potential. So this will take part as cathode, and this will be your anode, right? So it A will act as cathode, that is right, and have positive polarity. Wait a minute. It has positive polarity. Cathode will have positive, anode is, that is right. Okay, cathode is positive in electrochemical cell, right? So current will flow from cathode A to cathode, electrode A to electrode B, because current always, electrons flow from anode to cathode, current from cathode to anode, that we have seen. So this is also correct. Standard EMF of the cell is 1.33 minus 0.77, that is nothing but 0.56, right? Is the standard EMF of the cell. Reduction potential of cathode minus anode. That should be there. What is the value? 1.77 minus 0.77, 13 minus 7. Okay, so answer is coming out to be all are correct. Okay, none of these is the correct answer, because all of them are coming out to be correct only. This is also correct, this is also correct, this is also correct. So many things they have asked in this question, right? Next is oxidizing power of the species will increase in the order. Now, they have given you some reduction potentials here, right? They are asking you the oxidizing power. So as I told you, reduction potential is directly proportional to oxidizing power. Oxidizing power. So can you see that this has maximum reduction potential, that means maximum oxidizing power? Cobalt. Then you have Pb, then you have Ce, then you have Bi. So answer will be B is the correct answer. Is that clear to everybody? Is that clear to everybody? What you were not able to understand? False statement, na? They have asked false statement. None of them is false. All of them is correct, na? So this is coming out to be 0.56, right? 0.56, na? This is coming out to be, right? So none of them is false. This is also true. Current will flow from which thing? Here we know that electrons will flow from anode to cathode. Current will flow from cathode to anode. That means A to B. And they have given A to B only, right? A will act as cathode. Yes, A is acting as cathode and has a positive polarity. All of them are right. So that is why none of them is false. Okay. Next is, let us see this question here. That is, given the equilibrium constant. So here they have given you Kc and they are asking you the value of E0. So directly you will put this value. I think this we did yesterday also. E0 you will put the value of Kc here, right? E0 directly you can get here, right? So direct formula based question, right? Okay, students, done. Everybody. Done. A undergoes oxidation. Oh, let me see. A undergoes oxidation. Where is A? A undergoes oxidation. No, A will undergo reduction. A will undergo reduction. Because this has more reduction potential, then A will undergo reduction. No, beta. The one which has more reduction potential, that will undergo reduction. The one which has less reduction potential will undergo oxidation. That is why this is a node, right? Okay, done. Okay, very good. Now we have coordination chemistry. Let us see coordination chemistry. Okay, let us see coordination chemistry, everybody, right? Let us see that. Now, coordination chemistry is also a big chapter. Okay, let me be very clear on that. This is a big chapter. It will take us half an hour to complete all the things here, right? So, firstly, we will start with two important theories here. Firstly, two most important topics is VBT and you have CFT. Okay, let us do VBT. from where most probably they will ask you questions from VBT and CFT. Then rare chances are isomerism, but that also I'll teach you. Okay, right? Now, first is VBT. For this, these are the exceptional points that you should know. Right? Directly though you know, ma'am, we know that, ma'am, oxidation number calculation, then ma'am put the values. Ma'am, what's the big deal in VBT? Exceptions are the big deal in VBT. Exceptions you should know. If you know the exceptions, they will ask you questions from the exceptions only. So exception is if cobalt 3 positive. See, water we know that that is a weak field ligand. Oxalato we know that that is a weak field ligand. But if they are bonded to cobalt 3 positive, they will act as strong field ligand. Okay, first point. Copper 2 positive. Now we know that water is a weak field ligand, but with copper 2 positive also, it will act as a strong field ligand. So with water, cobalt 3 positive and copper 2 positive, if you have any of this, it will act as a strong field ligand, it will cause the pairing, right? Next you have nickel 4 positive. Now we know that fluoride ion is a weak field ligand. It never causes pairing. But with nickel 4 positive, it will cause pairing. It will act as a strong field ligand. This is very important. Take a screenshot here, right? Fe2 positive and Mn2 positive are bonded with NH3. If they are bonded with NH3, then ligand act as weak field ligand, right? We know that NH3 usually cause pairing, right? But here in this case, it will not cause pairing, right? Okay. Next is 3D series elements in +2 oxidation state from outer orbital. This is a general thing up to NH3. This you can ignore also. Okay. This I would not advise you. This you can ignore also. So I'll just erase this part. Right? What you need to know is that part. I think if you're able to learn those 4 points and recall those 4 points in the exam, that is enough. Right? Now we will see, ma'am, how to solve VBT. Okay, now we will see, ma'am, how to do questions of VBT. Right? Okay, yes. Now let us do the questions of VBT. Here is a table also given to you. Students, see, first thing is with 2 coordination number, rarely you will see, but still, if you see the type of hybridization, this is linear and these are the compounds of when you have 2 oxidation. Why I have given you this table is, sometimes there are NTA will like, okay, I am in the revenge mode, I will ask you difficult questions, then you should also know these things, the examples, right? So if you have coordination number 2, these are the examples which has linear shape, right? Then for coordination number 3, this is the example which has trigonal shape. Coordination number 4, usually they ask you. Coordination number 6, usually they ask you. Right? For coordination number 5, this is not there in your syllabus, but still I have given you examples here. Like what if they ask you FeCO5, that is trigonal bipyramidal. CuCl5, that is trigonal bipyramidal. SbF5, it is square pyramidal. That is not there in your syllabus. But sometimes they're like, okay, I'll ask you questions, some different questions. Then you should go through this table. Minimum you do this, right? You don't have to see all the reactions of questions of coordination number 5, 2, 1, nothing, right? But focus on coordination number 4 and coordination number 6. If coordination number 4 is given to you, either it can be sp3 or dsp2. If it is sp3, it is tetrahedral. If it is dsp2, it is square planar. For coordination number 6, it can be d2sp3 or sp3d2. d2sp3 is inner orbital octahedral. sp3d2 is outer orbital octahedral, right? Now, I'll take any of the example here. I'll take the example of this, okay? CrNH3 6,3 positive. This I'll take, okay? Cr wait a minute. I'll take this example, okay? Because that is the exceptional example here, right? So I'll just solve this with the help of one example here, right? Okay. So I'll just take one extra page here, right? And let's solve one question. I'll solve with you, right? Okay. So the question is nickel NH3 6, nickel NH3 6, and this is what? This is 2 positive. Okay, this is 2 positive. Now, students, let us try to solve this question. Step by step, I'll tell you what you have to do. So everyone write down your first step. First step is calculate the oxidation number. So oxidation number is x plus 0 is equals to plus 2. So x will come out to be plus 2. So now here nickel, which electronic configuration is 4s2 3d8. Right? You should know the electronic configuration of a 3D series. Saktiv, Karman, Fikunikojan, very important. Right? Okay. If you don't know the electronic configuration, I'll just write it here. Okay, I'll just write the electronic configuration here. Now, nickel 2 positive it is. It is nickel 2 positive. This is not exceptional. This is 3d8. Okay. So 3d8 you have which thing? 6. This is, wait a minute, 0 plus is plus 2. So you have 3d8. So here what you will do? This is 3d. 1, 2, 3, 4, 5. This is 1. This is 3. So NH3 you have here. That is why it is going to cause you the pairing here. Right? So that is why what you will have here. This is 1, 2, 3, 4, 5, 6, 7, 8. And hence you are left with which thing? sp3 d2. Right? sp3 and this is d2, that is outer octahedral complex you will have here. Right? Let us solve one more question here. Let us solve one question based on FeCN6 3 negative. Let us solve that. FeCN6 3 negative. Chalo, let us solve question of FeCN6 3 negative. FeCN6 3 negative. Now you will calculate this along with me. This is x minus 6 is equals to minus 3. X is equals to plus 3. Right? Fe plus 3. We know that Fe is 4s2 3d6. So it will be 4. 3d5 is going to be the correct answer here. Now, here what we are going to do? 1, 2, 3, 4, 5. This is S. This is P. This is again D. Okay. Now, what you will do? You will fill the electrons here. That is 5 electrons. Now, if you see this here, Cn is a strong field ligand. Okay. Cn is a strong field ligand. So, it is 1, 2, 3, 4, 5. That is how it is going to have D2sp3. Na? Yes. It should have D2sp3. So, answer will be D2sp3. Right, so based on that, based on pairing or non-pairing, it is going to give you the answer. So it is going to be D2sp3. That is going to be your correct answer. Okay. Based on that, you can also do some other examples here. Let me know if you want me to do any other example here. This we have done. This we have done. Okay. This also, if you see this chromium, this will be chromium 3 positive, right? With chromium 3 positive, you have NH3, right? If you can see this over here, chromium 3 positive with NH3, NH3 is your, it is going to cause pairing in this case. So answer will be D2sp. Okay? So that will be your answer. Now, here the important part is Saktiv, Karman, Fikunikojan. Okay, so how you are going to write it? This is 4s2 3d1, 4s2 3d2. This is 4s2 3d3. This is 4s1 3d5. This is the exception. This is 4s2 3d5. This is 4s2 3d6. 4s2 3d7. Nickel is 28. 4s2 3d8. Copper is again exception, that is 4s1 3d10 and this is 4s2 3d10. So this electronic configuration should be on your tips. Okay, right? Okay, so this should be on your tips. If you know this thing, only then you will be able to answer the questions of 12th inorganic chemistry. Without this, DNF block, coordination chemistry is of no use. You can skip, right? If you don't know this thing, right? Okay. Now, next is these are the other examples here, right? Inner orbital complexes, this beta I have already told you, right? Okay. Next we have is Magnetic. So when you talk about the magnetic properties, what you should remember, diamagnetic is where you have no unpaired electron. No unpaired electron. Paramagnetic is when you have one paired electron, right? Okay, this is the formula of mu, that is a magnetic moment. And if you want to have a trick here, ma'am, can you please tell us the easy way out here? Okay, so the easy way out of this thing is, wait a minute, let me just draw the easy way out for you, right? Easy way out of this thing is very simple. That is, if they have given you that these are the unpaired electrons, right? Let's say these are the unpaired electrons, this is the magnetic moment. So directly what you can write here is that if your unpaired electron, let's say the unpaired electrons are 1, it is 2, it is 3, it is 4, it is 5. So this will be 1.7, this is 2.8, this is 3.8, this is 4.9, this is 5.9. Right? So that is going to be the value of mu. You don't need to use this formula. You don't need to use this formula, but you should know this formula. You don't need to use this, but you should know this formula. Okay? Understood? Next topic is CFT, that is crystal field splitting. Okay? So in this, they considered the interactions of ligand and metal, because we know that ligand is donor, electron donor, metal is electron acceptor. So here what we expected that, okay, here what will happen? We expected that this interaction is electrostatic interaction. So what exactly happens? You have 5 orbitals, right? When the ligand will come, the energy will increase, and after that, that will split into 2 parts. Okay. Now, what you always forget in the exam is, ma'am, in octahedral there was, ma'am, 3 orbitals above and 2 orbitals below. Ma'am, I forgot that in the exam. So this you should remember, 1, 2, 1, 2, 3. Okay. This is Eg, this is T2G. Okay. This is the important part that you should remember in the exam, right? And here, if let's say you have a strong field ligand energy, the gap in energy will be very high. That is why there will be pairing, right? So that is why what you should remember, if CFSC is very high, then it is a strong field ligand. Strong field ligand. That means it is going to cause pairing. It is going to cause pairing. That means it will be a low spin complex. That means it is going to be a low spin complex. That means delta O is greater than the pairing energy, right? So that is why it will prefer pairing. So you will prefer that thing which has less money. So that is why it will prefer, you will prefer, if for example you got a seat in government and private college both, you will prefer private or government. You will prefer government na, because less money is involved. So it will have government and private college both. So it will prefer that one which has less money. Less money is there in pairing. So that is why it will prefer pairing, right? So this is a very important thing, right? Next we have is, let's say you have tetrahedral complexes, right? In tetrahedral, this is 2 and then you have 3. Now what you should remember is that here one important thing is this gerade, G is not there. This is regarded as E and this is regarded as T2, right? And in this case, mostly you will have weak field ligand only. Tetrahedral complexes, they are usually high spin only. Okay, usually they are high spin. Now, CFSC factors. Okay, I'm just writing the factors here, right? So what you will see, as the oxidation number increases, CFSC also increases. I'll just write directly delta O increases. Second part is, as down the group, right? You can write down the group 3D, then 4D, then 5D. Okay, down the group also CFSC increases. Okay, that you should remember, right? Then one more thing is delta O is greater. That is why delta T is equals to 4 by 9 of delta O. That is approximately half of delta O. Okay, delta T is approximately half of delta O. Right? Okay, students, understood or not? Yes. I think the questions based on that is there. Sure. Now let us do some questions based on this part here, CFT and apna CFT and BBT. Okay, let us do some questions based on this here. Among the ligands NH3, EN, CN, CO, the correct order of their increasing field strength. So this is from directly from the spectrochemical series that I have written here. So you should also remember the order of the spectrochemical series. Very, very important. Direct question can be there based on the spectrochemical series. Okay. Next is the crystal field splitting. Now they are saying energy for octahedral and tetrahedral is given is related as. So we know that tetrahedral is approximately 4 by 9 of delta O. So answer will be B is the correct answer here. Right? Direct question. Next we have is both NiCO4 and NiCN4 negative are diamagnetic. Hybridizations they are asking you here. Right? So directly let us solve these questions. So if you see NiCO4, right, and this is NiCN4, okay. So in this case, what you have to see, first is oxidation number. Here oxidation number is 0. So nickel is in 4s2 3d8 state. Here oxidation number is plus 2. It is 4 minus 2, that is plus 2. So it is in 3d8 only, right. Here what you will see, as you fill the electrons, this is 1, 2, 3, 4, 5, this is S, this is P. Similarly, here it is 1, 2, 3, 4, 5, and this is S and this is P. Okay. Now, when you fill the electrons here, what you will see here? CO, right? Carbonyl, CO you have here, and here you have Cn. Firstly, we know that Cn is obviously going to cause pairing here, right? And this is also going to cause pairing. So now what you will see here, when pairing will happen, here you will have 8, 9, 10 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is how you will have sp3 hybridization. Here you will have pairing 1, 2, 3, 4, 5, 6, 7, 8. And here you will have dsp2. That is square planar. This is tetrahedral. So answer will be B is the correct answer. Okay, answer is going to be B is the correct answer. This is tetrahedral, this is square planar geometry. Is that clear to everybody or not? Is that clear? Next is crystal field stabilization energy for high spin D for octahedral complexes. Now, they are asking you octahedral complexes. So, octahedral complexes means 1, 2, 3 and 1, 2. They have 4 electrons here. High spin means, as I told you, if you see this here, I have written it here also, that if you have low spin, you will cause pairing. High spin will be opposite. That means there is no pairing, you will have weak field ligand here. That means in high spin, what you are going to do, there will be no pairing. So hence what you are going to do here, this is going to be, wait a minute. So this is going to be 1, 2, 3 and this is 4. That is why here, if you see, this is minus 0.4 energy from berry center. This is 0.6, positive of 0.6. So, delta O is going to be number of electrons into 0.4 minus of 0.4 plus 1 electron into 0.6. So, answer will be 1.2 minus plus 0.6. So, answer will be minus of 0.6 is delta O. That means D is going to be the correct answer here. Understood everybody? That is how you will answer. D is the correct. Thank you, thank you, thank you. Now let us solve the questions of bonding in metal carbonyls. Okay, let us solve the questions for bonding in metal carbonyls. Okay, let us see that. So if you see bonding in metal carbonyls, how they will ask you questions from here, right? First thing is, these are your NCERT diagrams. Directly you should remember them. That NiCO4 is a tetrahedral shape, FeCO4 is a trigonal bipyramidal shape, and CrCO6, if you have chromium CO carbonyl ligand 6, it is having octahedral shape. Now, two shapes that they have asked you frequently is for manganese and for cobalt. Very, very important, right? Now here manganese, right? Manganese to CO10. Now manganese Mn with Mn, it is having one Mn bond, right? And this also is an octahedral geometry. This also is an octahedral geometry in itself, right? So this is the shape of manganese with carbonyl as ligand, and with CO with carbonyl as ligand. This question is very, very important, right? Reason is they will ask you, you have how many carbonyl ligands which are bridging. So you have two bridging ligands. Two are the bridging ligands, okay? Two bridging, right? And how many terminals? 1, 2, 3, 4, 5, 6. 6 terminals you have, right? So that is why you will write 6 terminals. 6 terminal ligands. 6 terminal ligands, and you have one CO bond. Cobalt bond you have one, right? So this is a very, very important question. Very, very important question. Okay. Now let us see the bonding here. From the bonding, what they can ask you, what kind of question they can ask you from the bonding itself. Synergic bonding means back bonding. Okay, usually we know that ligand is like I want to donate, metal is like I want to accept. But what happens if metal has vacant d orbitals? Then metal is like, you are donating me, I'll also give you, right? So when you see that ligand, this is the ligand, when this ligand is donating the metal, that is a sigma bonding. That is a sigma bonding, right? But when you see, or it also can be pi bonding, right? But when you see that metal is like I want to donate, then you will see the donation will be to the pi star anti-bonding orbital of the ligand. Very, very important point. When metal is donating to ligand, then this is going to donate on the anti-bonding pi star orbital. Very important question for your NEET point of view. Very important question. Okay, understood everybody? So this question was very, very important, and that is why this is called synergic bonding, because a kind of situation they have adopted where they both are helping each other. So that is synergia. So synergic bonding, right? Last topic, important topic from coordination chemistry is isomers, right? So isomers, you should remember firstly structural isomers. Directly I will give you the definitions here. Ionization isomer means whenever you see two isomers in which counter ion and ligand has exchanged their position, that is ionization isomer. That means the ions are different here, right? Then hydrate or solvate isomerism is when inside the coordination bracket, your water ligands or the number of water ligands has changed. Like here you have 6 ligands, here you have 5 water ligands. That is hydrate or solvate isomerism. Then linkage isomerism. Linkage isomerism is when what you will have, simple thing is what you will have here is that the linkage, there will be there will be ambidentate ligands. What are ambidentate ligands? Ambidentate ligands are those ligands which has two donating sides, but at one point they will only donate from one donating side. So here they are donating from nitrogen, here they are donating from oxygen. So that is why they are ambidentate ligands, and hence the ligands, the isomerism that has ambidentate ligands is linkage isomerism. Next is coordination. In this you have two different coordination spheres. Okay, here what you will see, the ligand has exchanged in two coordination spheres, that is called coordination isomerism. Then in stereoisomerism, you have two kind of isomerism. One is geometrical, one is optical isomerism, right? So directly we will see, I know you already are very scared of it, but actually it's very simple, right? So first thing you should remember is in tetrahedral, there is no geometrical isomerism possible. It is only possible in case of square planar, and in case of octahedral. Simple thing is, if you have two same ligands opposite to each other, that is trans. If they are next to each other, that is cis. Okay, simple, right? So now if you see this here, I'll draw one by one. This is the table, okay? From this table only we will see, students. So if you talk about MA2B2, okay? So if you talk about MA2B2, this is M, this is A, this is B, this is A, this is B. Now, if you see this here, two same ligands are next to each other, two same ligands are next to each other, that is cis, right? But if you see this M, this is A, this is also A, this is B, this is also B. Now, two same ligands are opposite to each other, that means this is trans. Okay, so I'll draw one by one if you want me to draw that. So I'll draw only, okay, I'll draw this. I'll just divide this into different parts, right? Okay. First is Ma2B2. Here what you can see, this is M, this is A, this is A, this is B, this is B. This is this. If you have A, this is B, this is B, this is trans. Okay. Now I will see if you have MABCD. Okay, if you have MABCD. Now things will change here. Now things will change here. How things will change here? Anybody? This is a very different kind of isomerism, okay? It's a very different kind of isomerism. MAB, MABCD. Okay? So here what you will do, I'm going to draw this here, right? First is M, this is A, 1, 2, 3, 4, this is A, B, C, D. Okay? You will fix one of them here. I will fix this. I will fix A. Okay? Now here, what I'll do, I will shift B and C here. So here answer is going to be, this is M, A is fixed, right? I'll shift B and C. I'll replace them. So this is C and this is B and this will be D. Now I will replace D and B. Then answer is going to be M. This is 1, 2, 3, 4. This is A, this is C. B and D are replaced. So here you have D, here you have D. These are the three isomers that you have for MABCD. Right, this is a proper way of solving this, right? So if I have to, let's say I am assuming that B and C are, assume any of them equal. Assume, I'll write it here, assume B and C equal. You can take any of them equal, okay? I'll take B and C equal. Now B and C are on next to each other, so this is cis. B and C are next to each other, so this is cis. B and C are opposite to each other, so that is trans. So always you will get two cis plus one trans isomer. This is a very important question. Okay, this is a very important question of isomerism. Okay, students, very important question. How many isomers of MABCD? This question was there. This definitely is a very important question. Okay. And some of you might skip this in the exam. Ma'am, there was two cis or one cis. I forgot this in the exam. Two cis, one trans. Okay. Then you have M. Now you have coordination number 6. Right. Now I'll draw for coordination number 6 here. That is MA2B4. Right. MA2B4. If you have, let's say, MA2B4, then you can draw things like this, 1, 2, 3, 4. Wait a minute. This can be 1, 2, 3, 4, 5, 6, right? And this can be 1, 2, 3, 4, 5, 6. Now here what you can write, if they are cis, then A, B, 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 B. This is cis. If you want to draw trans, this is A, this is A. This is B, this is B. This is B, this is B. So this is trans isomer. Okay, this is your trans isomer, right? Now I'm going to draw for Ma3B3. Ma3B3 is a special case. Okay, I'll draw this in the end. Firstly, I'll draw for MLL2 and B2. LL, when you say AA, LL, that means we are talking about bidentate ligands. Okay, so here it is M, let's say LL2B2. Bidentate ligands means one ligand is going to give you two donating sites. So 1, 2, 3, 4, 5, 6. That's how 6 donating sites. So here you will again write this M1, 2, 3, 4, 5, 6. Again here it is M1, 2, 3, 4, 5, 6. Now when you draw the structure here, how you will draw? LL, I will represent this by bidentancy, that I will represent like this. Okay, when I have to draw cis, I will represent it cis. Two are sitting together. This B and B are also together. So this is cis. When I have to make trans, then these two will be opposite and this will be opposite. So this is your trans isomer. This is your trans isomer. Okay. Yes, everybody. Is that clear? I think I should draw it neatly. Otherwise, so you will get confused here. 1, 2, 3, 4, 5, 6. That's how you draw this. This is 1, 2. This is B. This is B. This is the trans isomer. Okay? Understood? Right? Now here, acha, one more thing. Now one more thing. This we have done. This, but these all we have done. Okay? This one is left. Now MA3B3 direct question will be there in the exam based on this. That is facial and meridional isomer. This is different. Okay? So facial and this is meridional. 3D I have already shown you in detail classes. There is no use of doing 3D at this point because they are not going to take your Viva, right? So that was for knowledge purpose I told you. Now see what is useful in the exam, right? So in the exam what you have to see is that in facial isomer what you have, this NO2, 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 that will be next to each other and other three will be next to each other. That means let's see, this is A, this is, let's say this is A, I'll just draw it like this. Okay? I'll draw ABCD, okay? I'll draw ABCD so that you don't get confused in the exam, right? So this is, let's say this is B, this is also B, this is also B, this is A, this is A, this is A. All are next to each other. A are next to each other, B are next to each other when you draw it in 2D, right? Not in 3D. 3D has a different structure, okay? In this case, you have 2A next to each other, then this one of them will be opposite, right? Then you will have B, that is again like that. Same thing, right? Same thing, that is B next to each other, then one will be opposite. That is your meridional isomer, that is facial isomer. Is that clear to everybody or not? Facial and meridional isomer. Is that clear to everybody or not? Right? Okay. Everybody. Yes. On the adjacent position. Very good. Very good. Very good. Right? Oh my God. For such, you are saying, ma'am, such dedication. Hannah, ma'am is not even skipping one single thing. Right? What I see. What I see is no like, no appreciation. Not even, ma'am, we will not even share this among our friends, ma'am. You cry, ma'am. You cry. You do things for us, then you cry in the corner. Right? We will do nothing for you, ma'am. Right? We are very selfish, ma'am. Right? I know that. I know that. But you know what? I can't do that. Right? It's not, my heart doesn't say that, okay, you have to pick just some topics and go in the class. That's why I'm covering every single thing in such less time. Right? It's not even 2 hours and I have already completed almost 4th chapter we have completed, right? All this, if you think now, all these things takes around 10 hours. It's not a simple game. I'm sitting from morning 10 a.m. to make these slides for you, right? So it's not a simple thing. But what I see is no like appreciation from your side. You don't even share this. You don't even like, you're like, ma'am, we are like very possessive about you or what, right? What is this? Chalo. Already those who have shared, good thing for them. Those who have not, I think you guys are very selfish, right? If I start to be selfish, you will not get this content on like totally free of cost, right? So now let's talk about optical isomers. Right? For optical isomers, remember these 3 things. From this only they will ask you question. One is, if you have, let's say, MAA2B2. We know that for MAA2B2, you have one cis and one trans. So this is cis. Trans will not show optical isomerism. If you see the trans here, this is trans. This is trans. Wait a minute. This is trans. Hey, where is trans? This is trans. Here you have trans. So this, if you see, this is the trans, this is the cis. Right? Trans, if you see, is very symmetrical. Even if you make the mirror image of the trans, that is superimposable. That is why trans is not going to show you any optical isomer, that is non-superimposable mirror image, but cis is going to show you non-superimposable mirror image. Okay, so that is why this will have cis will show you two isomer, two optically active isomer, right? Okay, then here if you see, this is MAA3 kind of. This also will show you optical isomerism. This also will show you non-superimposable mirror image. Then if you have MAA twice, B2C2, MAA B2C2, that means one you have bidentate, other are monodentate only. This also, if you see the mirror image, that is non-superimposable. So these three examples you should remember, that these three are going to show you mirror images here, right? Is that clear to everybody? These three are going to give you mirror images. In the end, what we concluded, important points, that coordination number 4, geometrical isomerism is shown not in tetrahedral. Optical isomerism is shown in tetrahedral, right? In square planar, geometrical isomerism is shown, but optical isomerism is not shown in square planar. That's why we didn't discuss that. Okay? Yes, everybody. Last is DNF block. After that, I'm going to give you break, right? Okay, just let me see this. Okay, chalo. Okay, students, now let us start with the DNF block, right? Firstly, my energy is getting low, so I want you guys to fill the chat box with green hearts and fires. Okay, yes. Let us start with DNF block, everybody. DNF block. So if you see this here, first thing is, as I told you, first thing is you should know the 3D series here, right? 3D series, Saktiv, Karman, Fikunikojan, the electronic configurations of 3D series, very important. Next is the electronic configurations, right? Some exceptional electronic configurations that you should know, especially this PD that has 5s0 here. Otherwise, in s orbital, you will get either 1 or 2, but in PD, you have 0 in s orbital. That is the exceptional case. Okay, and these are also some of the very, very important electronic configurations that I have written here, right? You can just remember them directly. Okay, very important electronic configurations. Next is melting point and boiling point. So first we will see the melting point from the graph. Basically, I have picked up some important graphs here and some important lines in DNF block, right? Because right now you don't have time to go through full NCERT, I know that, but still if you want to go through, I have already done around 7-8 hours of lecture of DNF block. You can go through that, but if you don't want to go through that, this is some risk-free points for you that will be there, like very, very important points. First is, from this graph, what kind of question they can ask you? That which has the highest melting point in 3D, 4D and 5D series. So in here you have tungsten, here you have molybdenum, and here you have chromium. These are the highest peak points in the melting point, right? Very, very important. Next is, in 3D and 4D series, they can ask you where you observed a dip. So you will observe a dip in from chromium to manganese, from molybdenum to technetium, you will see a dip. Okay, these are the two dips that you will see, but this dip is not there in 5D series. So these are the 5 important points from this particular graph. Understood? From this graph, we have 5 important points. 2 are from dip, 3 is from the highest peak point of the melting and boiling point. Next is, if you see this thing here, 2-3 questions they can ask you. First is, what you will observe is that the atomic radius, it is decreasing, decreasing, decreasing. But what happens is, iron, cobalt and nickel, it is almost similar, or you can say manganese, iron, cobalt, nickel, it is almost constant. Then again it will start increasing. That order you should remember, where it is constant, where it is increasing, where it is decreasing, right? Then next is, that 4D and 5D series have approximately same atomic 4D and 5D series, the radius will become equal to each other. Reason is the lanthanoid contraction. Reason is lanthanoid contraction. Okay, because of the poor shielding effect of 4f orbitals, these two will become equal to each other. That is why hafnium and zirconium have approximately same radii. Okay, right? That is why these two will have the same. These two will have same radii. These two will have same radii. These two will have same, 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 same. Okay, so these are the examples that they can ask you, right? Now, next is from this what they can ask you, what kind of question, right? So here what you will see that in manganese, the highest fluoride is in +4 oxidation state. But when you talk about the oxide here, in this the oxidation state is 2x minus 14 is equals to 0. That is +7 oxidation state, right? So why it is so? Why manganese has higher oxide, that is +7, and highest fluoride as +4? Reason is the ability of oxygen to stabilize these high oxidation state exceeds that of fluorine. The reason is, wait a minute, I'll just multiple bond it is, right? The ability of oxygen to form multiple bonds to metal explain its priority, right? So because it can form multiple bonds, right? That is the reason it exists in higher oxidation state in case of oxides. In case of fluorides, it does not exist, right? Then next is this we have done, this we have done, right? This is, I think, repeated, right? Next we have is, this table is very, very, very important, guys. Very important table for you, very important table. Now from this table, what you have to do is, right? So this is active Karman Ficonicogen, this is the activation and this is the atomic number. These are the electronic configurations that I have already told you. Now enthalpy of atomization is very important, right? You should know the trend here, right? If you see this, maximum enthalpy of atomization is there in vanadium, and if you see the minimum enthalpy of oxidation, enthalpy of atomization, that is there in zinc. Minimum. Zinc has minimum, this has maximum. Okay, not only minimum and maximum, I am advising you to learn the trend here. Okay, so how many of you will help me to write the trend? First is vanadium has maximum. After this you have 473, that is you have titanium. After this you will have 430, that is nickel. Then you will have cobalt. Then you will have 390. Then you will have chromium. It's a very weird trend, okay? Why I am asking you to do this? Because this question was there 2 times they have asked in JEE, this attempt. That means they are focusing on enthalpy of atomization. That's why I'm writing this trend, right? Otherwise, so it is a complicated trend only, right? Then you have chromium. Then after this you have 339, that is copper, right? Then you we skipped iron. Iron was after cobalt. After cobalt, there should be iron, right? Okay, chromium, copper, iron, chromium, then you have copper, right? Then after this, you have scandium, chromium, copper, then scandium, right? Then you have manganese, then minimum is for zinc. Okay, so this is the enthalpy of atomization trend. Okay, enthalpy of atomization trend, very, very important, right? Okay, that you should remember, right? Next is ionization enthalpy. So for ionization enthalpy, I will give you the direct trend here, right? Direct what you have to, how you have to remember. Saktiv Karman Fico Nikujan. Now here you remember one thing, that we know that along the period ionization enthalpy is increasing. So it is increasing, right? but in front of V co ni, you change the sign. So here it will be, sign will be reversed, right? V co. Here also sign will be reversed. Here also sign will be reversed. And hence you will have your trend of ionization energy. Okay, this is the trend of ionization energy. It's also a very, very important trend. This they are asking you from many years. That's why this is very important. This they have recently started asking, right? That's why I'm saying this is important, right? Got it? Now, otherwise you don't have many trends in D block here, right? Then we will jump towards some important lines from your NCRT DNF block. That is, the unique behavior of copper having positive E naught accounts for its inability to liberate H2. Now for copper, what is the E naught value? This is positive of 0.34 you have. Right? Now they can ask you the assertion reasoning questions based on this. Unique behavior of copper having positive E naught accounts for its inability to liberate H2 from acids. Right? Only oxides, acids, they can react with copper, the acid being reduced. The high energy to transform copper 2 positive is not balanced by its hydration enthalpy. That is why, see, basically, what is the reduction potential? Reduction potential is that you have to basically get it reduced, right? Its oxidation number will change. It will now. We are saying the high energy to transfer copper 2 positive is not balanced by hydration enthalpy. That is why it has positive reduction potential. That means, students, see this. Copper 2 positive to copper positive. This is oxidation here, reduction potential is needed, right? And it is positive, that is 0.34. That means it wants to get reduced to copper, right? It wants to convert from Cu2 positive to Cu, right? Reverse is difficult. Reverse is difficult. That means Cu2 positive is difficult because here you need high hydration enthalpy. That is not required because this Cu2 positive to Cu is so positive that the reverse is very difficult. This is what they are saying in this particular line. Understood? Right? They are saying that this is possible because it is positive reduction potential. It wants to get reduced. That is why the reverse, that means oxidation is very difficult here. Because for Cu2 positive, it is not balanced by the hydration enthalpy here. Right? Next is one question from this line, that is Cu. Now what you will see, many copper compounds are unstable in aqueous solution, undergo disproportionation. What you will see that copper positive is 3D10 and copper 2 positive is 3D9. Now you will say, ma'am, according to this, copper positive should be more stable as compared to copper 2 positive. Right? Because the electronic configuration of this is stable, this is not stable. That is why this question becomes important. Right? But here what you will see that copper positive is getting converted to Cu2 positive here. It is happening, it is getting disproportionated. Right? The stability, now they are saying why it is so. The stability of Cu2 positive rather than this is due to much more negative hydration that of Cu2 positive than Cu, right? This question can be there in your assertion reasoning or statement based question, that why it is so, because much more negative hydration is provided by Cu2 positive, release of energy is enough to stabilize Cu2 positive ion, right? Okay, right? That is why here also Cu2 positive is so stabilized, it does not want to get converted to Cu positive. Cu, right? Understood? Yes, everybody. Next one is this very important. I would say 99.9% they will ask you question from here, this table. Now it's wrong, ma'am. I have to remember this full table, ma'am. I'm so scared, ma'am. What to do, ma'am? I'm crying, ma'am. Crying in the corner, ma'am. What to do? So Diksha, ma'am, got your back. Don't worry. So here what you have to remember is, first is lanthanum. I'll just write the states here, okay? Lanthanum in 3 positive state, lanthanum, lutetium in 3 positive state, and gadolinium in 3 positive state. What is the, because they are the stable configurations. Lanthanum is 4s0, F0, gadolinium is F7, this is F40. Okay, this one thing. Other thing you have to remember is ytterbium, ytterbium in, wait a minute, this is in +2 state, ytterbium in +2 state, and here you have terbium. Where is terbium? Not terbium. Ytterbium in +2. There is also one more. Europium in +2 state. Europium in +2 state. This is 4. This is directly you can write F7, and here you have F40. Okay. You also should remember which is half filled, which is fully filled. The important configurations I am telling you. Third one that you should remember is terbium, that is in +4 state, right? And cerium, that is in +4 state. Here it is in F0. Terbium is in F7. In +4 state it is F7. Okay. So these are the, how many electronic? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 7 electronic configurations that you must remember. Okay. Right. 7 electronic configuration you should not skip, right? If you want to actually, I know that this full table is very difficult, right? But these you should remember because they are asking questions from oxidizing nature, reducing. For example, we know that cerium 4 positive is very stable. So they will ask you which of the following is very good oxidizing agent, reducing agent. We know that cerium 4 positive is stable. But we know that the stable electronic configuration of lanthanoids is +3. So it will try to decrease the oxidation number, right? Because it will go, you see, if you like mountains, but your family like beach, so you have to go to beach, right? You will be like, okay, my family is not like willing to go to there. You will be not like, I'll go alone, right? You want to spend family time, right? So you will go with them, right? So family likes +3. I am stable in +4, so it has to shift to +3. Right? Oxidation number is decreasing, reduction is happening. It is a very good oxidizing agent, right? So cerium 4 positive is a very good oxidizing agent. Similarly, europium question they have asked so many times. Europium, this would want to shift to europium 3 positive, right? That is why oxidation is happening. It is a very good reducing agent. So it is a very good reducing agent. Okay. Got it? Yes, everybody. So I am teaching you side by side your previous year questions also. So this I have written here. A noble gas configuration, then half filled configurations, then completely filled configurations. Right? So these are some very important things. Apart from this, if you want to remember something, you can remember samarium, you can remember neodymium. Right? So these are also some two important that I have seen in like previous year questions. So this also they can ask you. Neodymium and neodymium and samarium. But if you want to skip this, at least this so you will do, right? Okay, chal. That also we have done. Now let us see the preparations of potassium dichromate. So directly, yes, preparation is important, and some of the important oxidizing color and nature are important, right? So preparation is, firstly they will ask you what is the formula of chromitol. This is important, the formula of chromitol, right? See, if you can learn everything, you learn, right? Now I am telling you what are the important points here. Chromitol, what is the formula? Directly they can ask you, right? They can ask you the what is the oxidation state of chromium in chromitol directly, right? Then these are the steps of preparation. Chromitol is converted into potassium chromate, sodium chromate, sodium chromate to sodium dichromate to potassium dichromate, all of these things, right? Next is the properties. Properties are important. That is, if you, let's say you have dichromate ion, then when you add water, this will be converted to chromate ion, right? Okay, understood? If you have, let's say, dichromate ion, this will be converted to dichromate ion, and chromite ion exist as follows, right? In water, we know that dichromate ion is orange in color and this gives yellow color. So in water, they are interconvertible to each other. Okay. In alkaline medium, equilibrium shifts towards forward direction. That means you have chromate ion. Okay. When you have in alkaline medium, chromate ion is more balanced, more stable. In acidic medium, you have dichromate ion is more stable. This question also they have asked you so many times, that in alkaline medium, chromate ion is more stable. In acidic medium, dichromate ion is more stable. Okay. Next we have is that potassium dichromate is a very strong oxidizing agent, right? Now this is very important, that this will behave as oxidizing agent in acidic medium. Reason: in acidic medium, dichromate ion can exist. In basic medium, so it will be converted to chromate ion. So it will not exist only, right? So that is why we are saying that only in case of acidic medium, dichromate ion will exist. And in that case, it will act as an oxidizing agent. And that is the reason this is very important, that to which part it is converted to. This dichromate ion is converted to chromium 3 positive. Here its state is +6. Here its state is +7. So it is converted to +6 to +3. Itself it is getting reduced. Okay. Now, these are some of the important conversions that it is doing. Basically, oxidation it is doing. I negative is important because I negative has a weird thing when we talk about potassium permanganate. That I negative is getting converted to I2. Right? Next is potassium permanganate. Next is potassium permanganate. Everybody, let's see this. Right? Organic ma'am, yes, even I am waiting for the same. Right? Now here you have potassium permanganate ion. Right? For potassium permanganate, what we will do, very simple thing. It is prepared from pyrrolus isotope. Right? So first you should know the formula. Right? Then preparation is, first it is converted to K2MnO4, then it is converted to KMnO4, right? That is there. Electrolytic, electrochemical oxidation can be there, or basically, wait a minute. This is your manganate ion. Okay, so I'll just write it here. This is manganate ion. This is permanganate ion. Permanganate ion. Okay. So manganate to permanganate, manganate ion is green in color, permanganate ion is purple in color. Beta, I am marking everything which is important for you. Even then, if you don't do this, then that's your fault, right? So this is green in color, this is purple in color. That you have to remember. You don't want to remember the reactions, fine. Remember these things, okay? Now, remember this thing, in acidic or neutral medium, manganate ion disproportionate to give permanganate ion. These are the two ways in which manganate is getting converted to permanganate ion. Either through electrochemical oxidation or by disproportionation, your choice, what you want to do. Now, here the important thing is, in acidic medium, because it is behaving as potassium, potassium dichromate was behaving as oxidizing agent only in acidic medium. It is behaving as oxidizing agent in both the things, acidic as well as basic medium. So now in acidic medium, they can ask you, in acidic medium, KMnO4 is converted to which thing? What is the change in oxidation number? It is converted to, that's why I told you, redox reactions, they will ask you questions like this. From redox reactions, you learn basics. What is, how to calculate change in oxidation number. But they will ask you questions from here, that in your KMnO4, if it is in the acidic medium, what is the change in oxidation number? So if you have done just redox reaction, that is no use to you, right? So KMnO4 is getting converted to Mn2 positive in acidic medium, right? And in neutral or faintly alkaline medium, KMnO4 is getting converted to MnO2. Okay, here it is converted to Mn2 positive, here this is getting converted to MnO2, right? This is x minus 4 is equals to 0, so x is equals to plus 4 here, right? Beta, these are the little things that you should remember, right? What is the change in oxidation state? This is plus 7 to plus 2. This is plus 7 to plus 4, right? Next is iodine. But the rest of the things are same only. This is S2O, S2O3O negative to SO42 negative, same. But remember that in alkaline medium, I negative is getting converted to iodate ion, and in acidic medium, I negative is getting converted to I2. Okay? They will ask you questions from the exceptions. Okay? Right? Okay? So this is I negative to I2, I negative to iodate. Got it, everybody? Right? Shall I jump to the next part or not? Right? Next is our organic chemistry. But before that, I'll just finish the concept of redox reactions. Okay? I'll just finish because this to beta you have already seen. Oxidation number, I have written this here, right, just for you. So we can just do this in 5 minutes. Right? Let's do this in 5 minutes. Okay? So, first, this is oxidation number. You can go through the rules here, right? There is nothing more electronegative, -1. Hydrogen usually have +1, right? But in front of some electropositive metal, it will act as hydride, that is -1, right? Oxygen is -2. It is, if it is combined in fluorine, it will give +2 or +1, right? These are some of the general things that how you will calculate the oxidation number. You are pro in this right now. You don't even need that, right? Now let us see the balancing of the reaction. First thing is, I will advise you, rather than balancing of the reaction, try to see the stoichiometries and try to see if you can balance it like easily, right? So now let us see the balancing of the reaction with the help of one example we will do. Half reaction method is identify atoms undergoing oxidation reduction, separate them the half reaction, balance all atoms except for hydrogen and oxygen, balance oxygen by adding water, hydrogen by adding H positive, then balance the charge by adding electron, basic medium, do this. Okay, now let us see what exactly we are going to do, right? So this is your equation. Okay, firstly, I will calculate the oxidation numbers here. Then I will see where is oxidation, where is reduction. Oxidation number increases oxidation, it decreases, it is reduction, right? After this, what I'll do, oxidation, I'll make a different half reaction, reduction, I'll make a different half reaction. Now, important part is going to start. Till here, everything is simple. Now, the important part starts. Let us see that. Let us see that. I'm happy to see your energy in the chat box, right? Now, students, here it is Fe2 positive to Fe3 positive, right? Ignore this part. Ignore all of this part, right? Ignore this part. You see, Fe2 positive to Fe3 positive, you are adding 1 electron here. Is that correct or not? Here, oxidation number. Acha, let's not even do that. Okay, let's not even do that. Okay, I'm just ignoring everything here, right? You will say, ma'am, what you are doing, ma'am? Wait a minute. Wait a minute. I'll do one more thing here. Rather than this, I'll erase this. Okay? I'll then boom. I'll wait a minute. Chalo. Okay. Chalo ji. Okay. Okay. Now you have your half reactions here. But I'm going to give you only one example because we don't have that much time, right? And this is okayish important. So let's not waste our that much time over here, right? So now Fe2 positive to Fe3 positive. This is Cr2O72 negative to chromium 3 positive. Firstly, the step is to balance all the atoms. As you can see here, I have written here, balance all atoms except for hydrogen and oxygen. So I will balance all atoms except for hydrogen and oxygen in this case. So that means I am going to balance this here. I am going to multiply this by 2. Okay, balance. Now I will balance oxygen by adding water. So what I'll do, I'll add water here. That is, here you have 7 oxygen. So I'll add 7 H2O because in 7 H2O you have 7 oxygens, right? Then I will balance hydrogen by adding H. So you have 14 hydrogen here. So I will add 14 hydrogen here. Okay? So I will add 14 hydrogen here. Understood? Till here everything is clear or not? Till here I have not balanced anything. I have balanced the atoms and I have balanced oxygen and hydrogen. In the last step, you will balance the electrons. So how you will balance the electrons? Simple thing is, Ma'am, here what we have is, here we have oxidation, you have loss of one electron. Okay, you have loss of one electron. That means one electron is getting lost. Here you have, this is +6 oxidation state. This is +3 oxidation state. So you have, if you see +6 is for, if you see +6, na, yes, this is 3. +6 is for 1 chromium. You have 2 chromium, it will be 12. You have 2 chromium, it will be 6. So the change in oxidation number is 6. So you will add 6 electrons here, right? That is why you have 6 electrons here. Okay? Now here you have 1 electron, here you have 6 electrons, so you will multiply this by 6. And that is why this was the thing that we have written before. Now once you have this thing, now what you will do, you will add both the reactions here. Okay? Now last part is to add both the reactions here. Everything is balanced, you just have to add both the reactions. This is in the acidic medium. Now if you want to convert this in the basic medium, here you have 14 H positive, right? Add 14 OH negative here. This will come out to be 14 water, right? This will correspond to 14 water, right? So you can erase this 14 hydrogen here. This will correspond to 14 water. Because you have added 14 OH negative here, add 14 OH negative here as well. This is 14 water, this is 7 water, this will come to this side, this will become 7 water, and this 14 OH negative will stay, and this is your two balanced equations in acidic and basic medium. Okay? Understood? Okay, so one method is enough for you in the exam. You don't need to do both the methods. Okay, one method is enough for you, but still for the students who want to see the other method as well, here beta, identify atoms undergoing oxidation reduction, balance all atoms undergoing oxidation reduction. Okay, so first two steps I'll write. First example I have given you here, right? One example now. Chalo. I think I'll write here only. Okay, so you have MnO2, this is MnCl2. First you have to identify which is undergoing oxidation, which is undergoing reduction. Here Mn is in +4, here Mn is in +2 state. So this is undergoing reduction, this is -1, this is 0, this is undergoing oxidation. Right? Now see this very carefully, okay? Because you have to listen to me to understand this. Okay? Now ignore this part here. Ignore this part here, right? Ignore this part here. I'll tell you directly what you have to do here. Okay? See the students, what we are going to do here. This is +4, this is +2, this is -1, this is 0. Now, can you see this step here? Balance all atoms undergoing oxidation and reduction. The ones that are undergoing oxidation and reduction. So if you see this thing here, this chlorine is undergoing oxidation, this manganese, this is 1, this is 1. This is balanced. This is 1 and this is 2. You don't have to make, ma'am, here you have 4 chlorine, ma'am, here also you make 4 chlorine. No, that is a wrong way of doing the questions. You have to balance the atoms that are undergoing oxidation reduction. So this is undergoing and this is undergoing. So that means this is 1 and this is 2. So I'll multiply this by 2. That's it. Now I will find that I'll have to cross multiply. For that, what I'll do? For 1 manganese, it is +4. For 1 manganese, it is +2. So opposite, cross multiplication will be +4 minus 2 is going to be 2. Okay, is going to be 2. Right now, don't cancel 2. Here it is -1 for 1 chlorine, -2 for 2 chlorine. 0 for 1 chlorine, 0 for 2 chlorine. -2 minus 0 is 2. Now 2 will cancel each other and hence this is the unit. This you will get 1 here, this you will get 1. 1 multiply this 1 here, multiply this 1 here. Okay, opposite things you are doing here. Opposite things you are doing here. Okay, what I told you that here you have +4, this is +2. So this will be 4 minus 2. Here you have -2 for 2 chlorine, 0 for 2 chlorine. So -2, answer is 2, 2. Then you solve the simple whole number ratio. Then you cross multiply. This 1 is multiplied here. This 1 is multiplied here. Okay, I know there is no use of multiplying 1, but it's just to tell you that you have to multiply this thing. Now you got your answer. Okay, now you got your answer. Ma'am, but answer is different, ma'am. What you are saying? Achha, see one thing. What is the answer you got is MnO2 plus 2HCl give rise to MnCl2 plus Cl2. Okay? Till here you have balanced the electrons. After this, what you will do? Balance all atoms except for hydrogen, oxygen, then balance oxygen, then balance hydrogen. So first you have to balance all the electrons, all the atoms except for hydrogen and oxygen. So this is 2 chlorine, this is 4 chlorine. So you will multiply this by 2. So this will become 4. Okay. Now you have 2 oxygen here. So that's why here also you have to add 2 water. Now you have 2 hydrogen, 4 hydrogen. Here you have 4 hydrogen. That is how you got the balanced equation. Okay. Got it, students? Okay. So that was a quick recap of these things, and these are some of the formulas of redox reactions, direct formulas. Volume strength of H2O2 is 11.2 into molarity, 5.6 into normality. Strength of H2O2 is 34 into molarity. Percentage weight by volume is strength by 10. Direct formulas, right? No derivations are needed for you. Now, this is a very difficult question. What if they give you Y percent of oleum sample? You don't have to derive anything. For example, they have given you 109% of oleum sample. What is the percentage free SO3? So this will be 80 by 18. This is the Y. This is the Y percent. Y is given to be 109 minus 100%. That is going to be your answer. 80 by 18, this Y, whatever is given to you, this will be greater than 100 only. Minus 100 is going to be your answer. Okay, students? Let me know in the comment section if that is clearly revised. Now I have revised everything, and I'll sleep very happily that, okay, those students who were here and trusted me, so, it's like even if you have less time, I'll give my 100% to make it worth it for you. That is my duty, right? Now we are going to, ma'am, start organic. Beta, I'm going to take 5-minute break, right? 5-minute break we will take. Okay, what is the time? The time is 8:38. So I'll take break till 8:40 p.m. and then we will start organic. Okay, then we will start organic. Oh, it's 38, no, 40, it's 50. Because I think my brain is needs little bit rest now, and yours also, right? So for organic, all the 5 chapters we will complete for organic with very quick charts. Okay, with very quick charts I have prepared for you, and some questions also I have for organic chemistry, right? Okay, so now I'll take 10 minutes break, and after this we are going to start organic chemistry, right? Okay, chalo. Class will be resumed at 8:50 p.m. right? Okay then, okay, see you then. By that time, let me see how many likes you have given. You have not even completed the target. Disappointed by you guys. Disappointed. So now let's see by the time I come if you are able to complete that or not. Hello, students. Yes, I am back in the class. Everybody, let me know if I am visible and audible to all of you or not, so that we can start with the organic chemistry, right? Let us start with organic chemistry, students. Okay? Till here, you have your organic chemistry. Chal. Now, I have prepared some charts for you, and according to that, we are going to see organic chemistry. Yes, okay, let us start organic chemistry, starting with all the reactions here, right? Starting with the alkyl halides here. So you can prepare alkyl halides from PCl5, right? Basically, if you have alcohol, to replace that alcohol with Cl, you can use PCl5, PBr3, PI3, SOCl2. Now this SOCl2, what is the name of this reaction? This is Darson reaction. This is Darson reaction when you use SOCl2, right? And this in presence of pyridine, Darson reaction. So one thing is, if you use simply SOCl2, that is SNI, intramolecular nucleophilic reaction, that is. If you use with pyridine, that is SN2 reaction, right? Then if you use HI with H3PO3, that is replaced by iodine. If you use HBr with NABr H2SO4, that is replaced by bromine. HCl and Lucas region, that is also called Grooves process. Grooves process, right? Here what will happen, very important point, that in this process, what you will have 3 degree is going to show you maximum turbidity, that is within second, instantaneously, right? Then you will have 2 degree after 5 minutes, and primary is not going to show you turbidity unless and until you with prolonged heating, right? After maybe 30-40 minutes, it will show you any turbidity. That question is also very important for you, right? Next page is preparation of alkyl halides. So based on this, 2-3 things we will discuss here. First is, when you have alkene, what you will see here, if you have, let's say, HBr, right? Okay. Now, firstly, I'm going to tell you how you will break the pi bond. If you have, let's say, HBr in presence of CCl4, or let's say simple HCl or simple HI you have here, right? In that case, what you will follow is Markovnikov addition. Here also Markovnikov addition. Here also Markovnikov addition. Markovnikov addition means negative part 2 less number of hydrogen. Negative part 2 less number of hydrogen. That means Markovnikov addition is there. So negative Br is attached to less number of hydrogen. Cl is attached to less number. I is attached to less number of hydrogen. But if let's say you have only in case of HBr, this is not applicable in case of HCl or HI, not applicable. HF so is not showing this reaction only. So only in case of HBr with peroxide, you will see anti-Markovnikov rule. That means negative part 2 more number of hydrogens. Okay, negative part 2 more number of hydrogens you will see here, right? Now, next question is allylic or benzylic substitution. So let's say if you have Br2 in presence of high heat, or you have H mu sunlight, or you have NBS, that is N-bromosuccinimide. In that case, what you will see is that you have the formation of allylic substitution. So instead of breaking the pi bond, if you have bromine or chlorine in presence of H mu, I am saying bromine or chlorine in presence of this, maybe chlorine also in presence of H mu. This will show you allylic. Allylic means next to double bond, you will have the carbon that will be substituted by the halogen. Okay. NBS also does the same work. But if you have Br2 in presence of CCl4, it is going to break the pi bond and both Br will be attached here, and this will be the answer that you will have in the end. Is that clear to everybody? Right? Next we have is some 3 important reactions from this to our halogen exchange reaction. One is Finkelstein, then you have Schwarz reaction. In Finkelstein, you have let's say any chloride or bromide you will have. With NaI and acetone, this will be replaced by iodine. But when you have Schwartz reaction, you will have AgF, that is inorganic fluorides you will have. This halogen is replaced by fluorine here. That is Schwartz reaction. Then there is Hunsdiecker reaction where you have silver salt of acetic acid, right? Silver salt of carboxylic acid you will have, where CO2 will be eliminated. This Ag with this Cl or Br, whatever you will have here, that will form AgBr, or let's say here if you have Br here, so it will form AgBr, and here you will have the formation of CH3Br, right? So this is one of the preparation of alkyl halides. These are the three naming reactions under the preparation of alkyl halides, right? Next we have preparation of alkyl halides, that is aromatic compounds. So with this, firstly, we will also see how to prepare this disonium chloride. We will see that in a means. But once you have disonium chloride, if you have Sand-Meyer reaction, in Sand-Meyer reaction, you use salt of that chloride or bromide. Okay, so CuCl or CuBr will be used to replace N2Cl with Cr or Cl or Br, right? But if you have copper powder, that is called Gattermann reaction. With HCl, it is going to give you chlorobenzene. With HBr, it is going to give you bromobenzene. Then, if you directly add Ki into this and warm it, that will give you idobenzene. And if let's say you add NaBH4 here, then after that, after heating, it is going to give you fluorobenzene. But if you say that, ma'am, after this also I am going to add NaNO2 and I am going to add copper here, then this will be converted to NO2, right? Then here you have Ball-Schiemann reaction. If you have again put NaNO2 and Cu, then that is nitrobenzene, that is not Ball-Schiemann reaction. Okay, now we have benzene. So let's say you have benzene here. In benzene, you are adding Cl positive electrophile or Br positive electrophile, right? Or I positive electrophile. So it is going to replace the hydrogen with the electrophile. Okay. Next question, next slide is regarding the reactions of alkyl halides. So one very important reaction that is shown by alkyl halide is when you have KOH alcoholic, right? Now I'll show you two reactions here. For example, you have KOH aqueous. In that condition, it is going to substitute Cl with OH. That means you will have CH3, CH, CH3, and this is OH. When you have KOH aqueous. But when you have KOH alcoholic, it is going to replace this, not replace, it is going to eliminate this here. So dehalohydrogenations. This is from halogen, this is from hydrogen will be eliminated, and you will have the formation of alkene. And this alkene will be a Sedzef alkene. Do you know what is Sedzef alkene? Sedzef alkene is that alkene which follows which thing? Anybody in the chat box? Sedzef says that if you want to have the product that is Sedzef alkene, according to that, you will have that alkene which is more alkylated. That means on the double bond, you should have more alkyl groups. Then that is more preferred, that is more stable. Then there is reduction of alkyl halides. So with ZnHCl, this question also they have asked you so many times in so many questions. You have alkyl halide, you add ZnHCl. This X will be replaced by hydrogen directly. Okay. Next is the reactions of alkyl halides. So what are the reactions of alkyl halides? Let us see that. So here first is Woods fatigue, Woods fatigue and fatigue reaction. So here in Woods reaction, X and Na will be eliminated, right? You will have the formation of RR. But in Woods reaction, you have both the halides which are alkyl halides. In Woods fatigue, one is alkyl, one is aryl halide. In fatigue reaction, you have both the aryl halides. That is the only difference. Otherwise, you are going to eliminate NaX from here and join those two halides, and you will have the formation of the alkane, like double the number of you will have. And this is always going to give you symmetrical alkane, not unsymmetrical alkane. Next is Friedel-Crafts reaction. So Friedel-Crafts reaction is when you have benzene. On this you have this CHCl plus anhydrous AlCl3. So this will give you CH3 positive electrophile that will attack here, and you will have the formation of toluene. Reaction with Mg metal. Now, when you have any halide that reacts with Mg, right? Now, it is going to give you Grignard's reagent. That is called Grignard reagent. Grignard reagent. Now, Grignard reagent is that organic metallic compound which has two main purposes. First thing is, it is a very good proton acceptor. Okay, that means as soon as it will get a proton source, it will eliminate this MgI, that will be eliminated, and you will have the formation of hydrocarbon. That is first reaction of Grignard reagent. Other reaction is with carbonyls that we will do in aldehyde ketones and carboxylic acid when I am on that chapter. Okay. So always remember, it needs a proton source. That proton source also can be alkynes. That is also going to give you proton. So that will also convert Grignard reagent to hydrocarbon. Okay. Now, reactions of aryl halides. Let's say you have chlorobenzene. Now, one question that is asked is, this has partial double bond. That is why it is very difficult to break this bond. That is why from Dow's process, this process is called Dow's process. From this Dow's process, what we will do, we will eliminate this Cl with OH here under high pressure and high temperature. But if you have on ortho and para positions, you have any electron withdrawing groups, then these conditions will get very easy. That means if you have just one group, it is 443 Kelvin. If you have two groups, it is 368 Kelvin. If you have three groups on ortho and para position, it is just warm it and it will be converted to Cl, will be converted to OH. Okay, so that is the why on meta position nothing like that happens, because on meta position there is no negative charge. There is negative charge on the ortho para position. That is why on ortho para position only this is applicable, right? Next is electrophilic substitution reactions. Very simple. Just see the electrophiles here. This is always going to give you Cl positive electrophile. Always ortho and para product will be formed, para being the major product. This is going to give you NO2 positive electrophile, ortho and para product being formed, para being the major product. Here you have SO3H is going to be the electrophile, ortho para product, para being the major product. Here it is going to give you CH3 positive electrophile, para being the major product again. Now, this is your Friedel-Crafts acylation. I don't know, I think I have not written here. Friedel-Crafts acylation reaction. FC acylation. FC acylation reaction. Here, you will have the formation of CH3, C double bond O positive electrophile. And if you have, let's say, if you have this benzene and C double bond O positive, Cl, then it is going to give you this kind of electrophile. That is called benzoylation reaction. Here it is called acylation reaction. Again, para being the major product. Reaction with metals. This is what we have done already. This is Wood's fatigue reaction. This is fatigue reaction. We have already done it, right? Then there is preparation of alcohols. Okay. Then there is preparation of alcohols. Yes, trust me, I am going to revise it like this. Okay, nothing I'll miss. Okay, just trust me. Preparation of alcohol. So we have basically three methods here. So I'll write it here. One is acidic hydration. Acidic hydration. So anybody in the chat box, what we will use in acidic hydration? Then there is hydroboration oxidation. Hydroboration oxidation. Then the last one we have is oxymercuration demercuration. Oxymercuration demercuration, OMDM. Now in this case you will form carbocation and then you will rearrange it, then you will rearrange it, then you will add OH negative. Here you will follow anti-Markovnikov rule. That means OH negative will be on the more number of carbons. Here you will form Markovnikov rule. That means OH negative is on the less number of carbons, less number of hydrogens. Is that thing clear to everybody? Very, very important. Three kind of hydrations that you will see here, right? Okay. Next is for carbonyl compounds. If you want to, from carbonyl compounds, how you will prepare this. So if you have RCHO, add H2 in presence of a catalyst. Right? This is directly, see, one simple thing here, right? if you have carboxylic acid, after reduction it is converted to ketone or aldehyde, right? Then it is converted to alcohol, right? Okay, that is the reduction part. So if you're reducing aldehyde, it is getting converted to alcohol if you're using mild reducing agent, right? RCOR, if you have ketonic, then that is converted to a very simple thing. Ketone is converted to 2 degree alcohol, aldehyde is converted to 1 degree alcohol, right? Ketone is converted to 2 degrees. See why? Because here you don't have like position. This is double bond O. So this double bond O will be converted to OH. So only 2 degrees is possible. That's why general statement I have written here, right? Next is by reduction of carboxylic acid. You want to convert from this to this. You need a strong reducing agent. That's why we are taking LiAlH4 here. Now, one important thing, I'm going to write it here, right? That might be asked to you. NaBH4 is not able to reduce carboxylic acid or esters. LiAlH4 can reduce acids or esters. Okay, these important then points that I'm writing here, they are very important, right? So from here also they ask you questions, right? Then LiLH4 strong reducing agent will convert this to alcohol. Next is from Grignard region. Now this is a very important question, right? So what I'll do, I'll just copy paste this slide, then I'll write it again here, right? What exactly the kind of reaction with ketones it shows you, okay? With ketones, what is the kind of reaction that it shows you? I'm going to write it here. So this is R, C double bond O, this is R dash, let's say, or there can be hydrogen as well. This is R, this is, let's say, this is R double dash MgX. Now remember one thing, organometallic compound, metal is positive, this is negative. Over here, this is positive, this is negative. So this will attack here, electrons will jump here, you will have the formation of RCO. This is negative, this is MgX, this is positive, this is R dash, this is R double dash. Then after hydrolysis, this will be converted to OH. Now this is a very important reaction, right? You have to know this mechanism to do some questions in your organic chemistry, right? These are very important reactions, okay? This all we have completed. Next is preparation of phenols. So preparation of phenols will be done how? Simple. This is phenol. If you see, one part is Dow's process. From Dow's process, we have already done it. Dow's, you add at high temperature and pressure, that is converted to phenol. This we have done. With cumene, this is called cumene, right? This is called cumene. Cumene is also very important, that is isopropyl benzene. So here what will happen, when you add O2, this is converted to OOH. Then you add water, this is converted to acetone. This is converted to acetone plus phenol. Two things are there, acetone plus phenol. Okay, so I'll just write it here as well, that this is having, after this it is converted to benzene, because this is important, okay? This is C, this is OOH, this is CH3, this is CH3. Then it is converted to acetone plus phenol. Okay. Then Dow's process we have done. Okay. If you have, this is R, this is CONA. Now, do you remember soda lime decarboxylation? This COONA will be eliminated. You will be left with RH. That means this whole R, that means this phenol will be formed. So that is nothing but this is soda lime decarboxylation, right? This is soda lime decarboxylation. Okay. Now, you know, in aldehyde ketones, you will see that questions are getting repeated only, right? So here, next one is, you have benzene sulfonic acid, you add NaOH, you fuse it with NaOH, then you add dilute HCl, you will have phenol. Not very important reaction. From disonium salt, it is important you have aniline, add NeNO2 with HCl at 0 to 5 degrees Celsius. You will have N2Cl. Now you add water and you warm it. Add water and warm it, because benzene disonium chloride is stable at 0 to 5 degrees Celsius. Beyond that temperature, it is not stable, right? So that's why it will have the formation of OH, right? Now, here one important part is, if let's say you have RN2Cl, okay, in that case at 0 to 5 degrees Celsius also, this is unstable and this will give you ROH. This is also very important. Okay, this is related to this question, that's why I put it here. In disonium chloride, if you have alkyl disonium chloride, that is not stable at 0 to 5 degrees Celsius also. So this is directly converted to alcohol. Here you need to increase the temperature, right? From phenyl magnesium bromide, this is like RMgX. When to any Grignard reagent, you add oxygen, right? With the help of dry ether, it will have the formation of ROMgBr. Right? Then you add water, this will have the formation of ROH, right? That is, you'll have the formation of phenol. Next is the reaction of phenols, as you can see here. So phenol will show you two kind of products. One is ortho, one is para, ortho, para. Now para will always be major, but in case of nitration, ortho will be major due to hydrogen bonding. So here, if you see, firstly, now very important thing is, when you add bromine water, it will give you tri-substituted product. When you add concentrated HNO3, it will give you tri-substituted product. But if you add Br2 in CS2, it will give you two mono-substituted product. If you add dilute HNO3, it will give you two mono-substituted product. Now always para is the major, but in this case, ortho is the major due to hydrogen bonding of OH and NO2, right? Next is, this all we have done. Next is, let's say you have CH3Cl and HydroCl3, that is Friedel-Crafts alkylation. So ortho and para, CH3 positive electrophile will attack on that. Let's say you have, where is alkylation? Achha, acylation reaction, chalo, I have not written. What if here you have COCH3Cl, then acylation reaction will occur, right? Now all these reactions we have done. Now let us see, if you have on phenol, you have zinc dust, then this will be directly converted to benzene. If on phenol, you have Na2Cr2O7, that is the oxidation, this will be converted to benzoquinone, right, or hydroquinone, right? Now, if you add, this is acidic in nature. If you add, let's say you are adding some metal or you are adding some base, because this is acid, this is base. So it will form a salt, that is phenoxide ion will be formed, sodium phenoxide. Now if you add H2SO4, you have both SO3H is the electrophile. Definitely para and ortho product both will be formed, para being the major product, right? Now these reactions, if you have hydrogen, this is important. Hydrogen in presence of nickel, I think this was somewhere in your previous year question, I don't remember. H2 with nickel, this will break all the double bonds, but it will have no effect on the OH, right? Next is two important reactions, that is Riemer-Tiemer and Kolb's reaction. This is Kolb's and this is Riemer-Tiemer reaction. So in Kolb's reaction, remember one thing, you have CO2 and you add NaOH also here. Then you have the formation of salicylic acid. But if you add CHCl3 with NaOH, you have the formation of salicylic aldehyde. But here if you add CCl4, then you will have the formation of salicylic acid. In Riemer-Tiemer reaction, if you have CHCl3, you will have salicylic aldehyde. If in Riemer-Tiemer reaction you have CCl4, you will have salicylic acid here. Okay, understood? Next part is test for phenols. So test for phenols, first is ferric chloride test. Okay, in ferric chloride test, what you have is, here when you react this with phenol, if boiled complexes form, we can say phenol was present. Or bromine water test also. In bromine water test, this tri-substituted product has white precipitate, that will give you a hint that there is presence of phenol. Next is preparation of ether, that is Williamson synthesis reaction, again very important. So yes, that point I forgot to tell you. Yes, in Riemer-Tamer reaction, you have the formation of CCl2, that is the electrophile, that is dichlorocarbene is the electrophile. Okay, and in Dow's process, you have benzene as the electrophile, as the intermediate, right? Next is preparation of ethers. So if you see preparation of ethers, Williams, see, from alcohols, first thing is two different type of preparations we have. See, if in alcohol the temperature is 413 Kelvin, then two alcohols, that is ROH and this is ROH, they will eliminate water and you will have the formation of ROR. If you have temperature 413, right? But if the temperature is not 413, it is less than that, then only from one molecule they will do elimination. Okay. So the condition is the temperature should be 413, right? Then second process is Williamson synthesis, where you have alkyl halide, you will have sodium alkoxide here. Then Na and X will be eliminated. You will have the formation of Williamson. You will have the formation of ether. But here important part is the alkyl halide should be primary. Okay. The condition is from here the question. They will not ask you direct Williamson synthesis. They will ask you which of the following cannot show Williamson synthesis reaction. The one where alkyl halide is not primary is not going to show you Williamson synthesis reaction. Alkyl halide should be primary here. Okay. Next, this we have done already, Williamson synthesis reaction. Next is mechanism, you don't need to go through that, right? Next is cleavage of, now reaction of ethers. Famous reaction is with HI, right? Now with HI, what will happen? This is H positive, this is X negative. We know that it will attach to one hydrogen, it will form alcohol and one alkyl halide. Now the question is which will form alcohol and which will form alkyl halide. Let's say you have benzene OR and you have HF. It will always prefer, the hydrogen will always get attached to the oxygen here. Reason being, you have the formation, reason being this has double bond character, right? So that is why it is very difficult to break this carbon and this oxygen bond. That is why it will always prefer phenol. This is important, right? Next is in general what you will do. Now this is important for you. The order of the reactivity of hydrogen halide is as follows. Now let's say you have this kind of thing. Always remember that if any of it is tertiary, I'll just write it here. I think that was written somewhere. So if it is not written, I will write it here. Okay? If it was not written, I'll write it here. Let's say if any alkyl is tertiary. In that case, what will happen? Tertiary halide will be formed. Tertiary halide. If you have none of them is tertiary, right? Then it will follow SN2 mechanism here. Wait a minute. Two kind of mechanisms we have. SN1, I'll just write it here. You have SN1 and you have SN2 mechanism. SN1 mechanism is one step where you have the formation of carbocation. This is where you have the formation of steric hindrance. Here you have 3 degree, then 2 degree, then 1 degree. Here it is 1 degree, then 2 degree, then you have 3 degree. So what exactly happens here? If any of the alkyl is tertiary, then you will follow SN1 reaction and 3 degree halide will be formed. If none of them is tertiary, then primary halide will be formed. Got it? If you have any alkyl is tertiary, then 3 degree halide is formed. It will follow SN1. If none of them is tertiary, it will follow SN2 and it will follow primary halide. Okay? Understood? Now, electrophilic substitution reaction is same, right? Just like we did for phenols. Here also, Br2 in ethanol will have Br positive electrophile, orthopara products will be formed. Friedel-Crafts alkylation CH3 positive electrophile. Then you have Friedel-Crafts acylation COCl CH3 electrophile. In nitration, you have NO2 positive electrophile. Again, ortho-para products are formed. In this case, again, para is the major reason being there is no hydrogen bonding at the ortho positions, right? Next is for aldehyde and ketones. If you see oxidation of aldehydes, right? If you see oxidation of alcohols, now see one important part here. If you see oxidation of alcohol, you have RCH2OH, and oxidation is there, right? K2Cr2 7 plus H2SO4. Now here you have water and RCH, right? Reason is because here we are using mild oxidizing agent. Oxidation is not going too far. But for example, I use some strong oxidizing agent, right? Beta, here now I'll tell you directly to remember one few things here. Where should I write it? I'll write it here. Okay. Oxidation of alcohol. Just remember two things here. Oxidation of alcohol. See, I'm drawing. This is alcohol. This is mild. This is strong. Okay. This is alcohol. This is, you have mild oxidizing agent. This is strong oxidizing agent. Right. So directly what you have to remember? 1 degree, 2 degree, 3 degree. 1 degree with mild, it will give you aldehyde. 2 degree with mild, it will give you ketone. Tertiary will have no reaction. 1 degree with strong will give you carboxylic acid. 2 degree will give you ketone only, even with strong. 3 degree will have no reaction. This is regarding mild and strong oxidizing agent, right? So here you don't have to remember, cram this thing. This is basically your 2 degree. This is 1 degree. That is what is giving you aldehyde. This is giving you ketone. Now, important part is with copper, right? With copper, but copper at 300 degrees Celsius. 1 degree will give you aldehyde. 2 degree will give you ketone. But 3 degree will give you alkene. 3 degree will give you alkene here. That is the very, very important part here. Right? Okay. Understood everybody? Right? Now, next is Gattermann-Koch reaction. These are the reactions, Gattermann-Koch reaction, not Gattermann-Koch. Right? You can remember this by CHO. So, you have the formation of benzaldehyde here with CO and HCl and hydrous AlCl3. Friedel-Crafts acylation is directly COCl will be added, right? So you have not COCl, COR will be added here. From alkynes, what you will have? Let's say you have alkyne. This is very important. This I have to tell you in detail, right? This I'll write it on the next page, right? I'll write it on the next page. Some reactions I can't tell directly, right? So this is C triple bond C. Let's see, this is CH3 and this is also CH3. So what will happen when you add water in presence of mercuric ions? This will form a carbocation, a pi bond will break, and here you will have the attachment of OH here, right? So that is why here you had the attachment of, this is CH3, this is OH. This is H, okay? So now here, after this, what will happen? We know this is enol form. Then it will go under tautomerization. Now what will happen? This hydrogen is going to shift on this side. This double bond will shift here. So this will be CH3, C double bond O. This is CH2, CH3. And hence you will have the formation of ketone here. So hydration of alkyne is a very, very important reaction. Because here you have the tautomerism. That is why this automatically becomes very important for you, right? So here I'll write, basically this is a very, very important reaction. Understood? Now, next is oxidation reduction. Simple thing how you will study this, right? Oxidation reduction also I'll explain you with my notes only, right? Oxidation reduction, see this here. Not oxidation, ozonolysis. I'll take one example here. Let's see, you have one double bond. See, because this is also very important, okay? So this is, let's say this is CH3, this is H, this is CH3, and this is CH3. In oxidation, in ozonolysis, what you will do? Firstly, what you will do here, simply break the pi bond, attach double bond O. Okay. So break the pi bond and attach double bond O here. So I will break the pi bond. I will attach two double bond O here. Now, you will break the pi bond, attach double bond O. Simple, you have already done that. Now here, till here you have reductive ozonolysis. If you have oxidative ozonolysis, this is oxidative. In oxidative, what you do? Replace this hydrogen. Replace this hydrogen with what thing? Replace this hydrogen, this is C double bond O, this is CH3. Replace that hydrogen which is directly attached to carbonyl carbon to OH. Rest of the things will remain same. Rest of the things will remain same. Okay. By chance you have, let's say, C double bond O, OH, OH. That is nothing but this is H2CO3. That will be converted to water and carbon dioxide. Okay. You don't need to worry. If you have H2CO3 anywhere, then that will be converted to carbon dioxide and water. Because that carbonic acid is not at all stable. Right? Next is aldehyde and ketones. This bit we have done. Then there is Rosenmund reduction. Rosenmund reduction, we use Lindlar's. This we have done before also. Lindlar's catalyst that was there in reduction of alkynes to alkenes, right? So this is also used to convert COCl to CHO, right? Then there is reduction of nitriles. Okay, so if you have C triple bond N, these are the different reagents that you can use to convert this into CHO. Break the pi bonds, attach double bond OH here, right? From esters also with Dibble, you can convert this directly to aldehyde. These are some direct reactions, direct reagents, right? Now, very important, oxidation of 1,2 glyols, right? So if you have 1,2 glyols, right, you want to oxidize this in presence of this OOCCH3. Okay? So now what will happen? This is converted to, wait a minute, this bond will break and this will get converted to CHO. This will also get converted to C-CHO. Okay? Now, here also if you have 1,2 glycols, you simple do oxidation. This is converted to COR because here it is, to this carbon you have 2R. So you need a very strong oxidizing agent here. Itard's reaction is when you have toluene, you add chromyl chloride, that is converted to benzaldehyde. This is also very important. It's side chain chlorination. That means when you add when you have toluene, you add C2Cl2H mu, right? And then you do hydration. Then this part, basically what you will have the formation of CHCl2 here. Then this is converted to, then the Cl will be replaced by 2OH here. Then that is converted to CH. Okay, so I'll just write it here. Firstly, this is converted to benzene. This is converted to, because this is your previous year question. Okay. Then this is converted to CHOH. Then this is converted to CHO. Okay. Understood? Then that is converted to CHO. That is also one of your previous year questions. Next one is reaction of, okay, again these reactions only. Now I think this we have done. No. So this is if you have strong oxidizing agent, right? In that case, ketone is converted to directly acid. If you have Tollens reagent, now very important thing, Tollens reagent only aldehyde. That means whether it's aliphatic, aromatic, whatever aldehydes, they will show Tollens reagent test as positive. If you have Rochelle salt, that means if you have Felling solution, you have Felling A and Felling B solution, only aliphatic aldehydes, okay, only aliphatic aldehydes will show this test. Only aliphatic aldehydes will show this test, right? Then here, if you have instead of sodium tartrate, you have sodium citrate, this is Benedict test, okay, as you have written here, this is Benedict test. Again, this is only shown by aliphatic aldehydes, right? Next is the reduction in presence of catalyst, right? Or reduction. Now these two reductions are important for you. That is Clemmensen reduction and Wolff-Kishner reduction. In both the cases, this double bond O is converted to H2, right? In Clemmensen, you have acidic conditions, zinc, amalgam, and HCl. In Wolff-Kishner, you have hydrazine in presence of basic conditions, okay? Hydrazine in presence of basic conditions. Next, students, we have aldol condensation. So I'll just write aldol condensation. Again, I can't define aldol condensation directly with a reaction, so you have to understand that. So see, if aldol condensation is only there if you have alpha hydrogen, right? So this is CHO. Self-aldol means you have same kind of molecule, okay? Same molecules. So what I'll write if I have ethanol, let's say. Firstly, I will write the C double bond O. Openly, I'll write this. Then I'll open the alpha bond here. I'll close this bond. I'll open the alpha bond, right? In one molecule, you open the C double bond O. In other molecule, you open the alpha hydrogens. Now, this is connected to this. And here you will have C. This is connected to this carbon. This is converted to OH. Right? Here you have the linkage of CH3. Here you had one hydrogen. This hydrogen is replaced here. This hydrogen shifted here. That is why C double bond O is converted to COH. Now this carbon is connected to this carbon, and here you have the attachment of CH2. And here also you have CH2. And that's how you have, and that's how I think you have your aldol product. Now from alpha and beta positions, it will lose water, right? So here you will have CH3. This is CH double bond CH. That's how you have alpha beta unsaturated aldehyde here. Okay, that's how you have alpha beta unsaturated. This is aldol, and that is alpha beta unsaturated aldehyde here. Okay. Now, next is cross-aldol condensation. So, very simple it is, right? Cross-aldol condensation, you will have two products. Let's say, I'll see, ethanol with ethanol, I have already told you. Let's see how propanol with propanol can make one compound. It will have around 4 answers, but I'll only do 2, right? One will be your homework. This is CH3, CH2, CHO. One point you open the CHO bond. Other point you open the alpha hydrogen bond. So this is CH3, CH, this is alpha, this is CH. Now this is the alpha carbon, this is the alpha hydrogen. So these two will be connected. So here you will have CH3, CH2. This is converted to COH. Then this hydrogen is as it is. This is connected to this C with H. This CH has one CH3 and one CH, right? Now you have to take out from alpha and beta position, take out carbon and OH, and this is the alpha beta unsaturated product that you will have. Okay, beta, are you able to do this? Acha, last one I'll do very slowly. Okay, for those students who are still not able to understand, this one I'm doing for you, right? Let's say you have to make, let's say CH3 with CH3, CH2OH, CHO. Now, either one way it will use this alpha hydrogen, other way it will use this alpha hydrogen. What I'll do, I'll select this alpha hydrogen firstly, and this is CHO, what it is using. So this is CH3, this is CHO, right? Okay. CHO, I'll take it as double bond here, right? And here it is CH3, this is CH, this is H, and this is CH, right? This is connected to this, and here you will have, this is connected to this, and here you will have, beta, I'm going to draw it again because I don't have enough space here. So this is CH, this is H, this is CH3, and this is CH. Okay. So now after attaching these two together, this carbon with one CH3, alpha, this carbonyl carbon, OH will be formed instead of double bond O. This is connected to this carbon. Okay. This has one hydrogen. This has one hydrogen. This hydrogen was shifted here, so I don't need to write that. This is connected to one CHO and one CH3. I know that from here alpha and beta position I'll have the elimination of water, and that is the product that will be formed. Last one also I'm doing for you because I don't want, like, you will be in that question mark condition in your exams. What if I take this as the alpha? I take this as alpha, this as CHO. Now I'm going to write it CH3, CH2, C double bond OH plus, this is CH2H, this is the hydrogen, and this is CHO. Now, one of the compound carbonyl is attached with alpha, right? This is the carbonyl part that is attached with alpha. So, this is CH3, CH2, carbon, देखो one by one. Double bond O is converted to OH, OH. This hydrogen is as it is. This hydrogen is replaced to this position. So, here this is connected to this carbon here, CH2. This is connected to CHO. Now we are saying alpha beta position, replace, this is alpha, this is beta. Sometimes students get confused, ma'am, this is alpha or this is beta. Beta, this is next to aldehyde, alpha, this is beta. Okay, so that's why I'll take out water from alpha beta positions, and hence I'll have this as the answer. So these were my 4 products. Understood, everybody? Understood? Yes? Okay, next is aldol beta. This we have done. Acha, I have one more slide here. That I forgot only. Right? Cannizzaro reaction when you have no alpha hydrogen. In that case, you will see disproportionation reaction. One will be oxidized, other will be reduced. Okay? So here what you will see, one part is converted to alcohol, one part is converted to carboxylic salt of, sodium salt of potassium salt of the carboxylic acid. So there is oxidation and reduction. So that is disproportionation reaction. Similarly, in this case, one part is converted to alcohol, other part is converted to sodium or potassium salt of carboxylic acid. Ma'am, the question is, what if we have different products? Okay, sorry, what if, ma'am, we have different reactants? So I'll write one thing here. If you have cross Cannizzaro reaction, then students, what you will do? Cross Cannizzaro, ma'am, which part will be oxidized, which part will be reduced? Anybody in the chat box, right? Anybody in the chat box, which part will be reduced, which part will be oxidized? So for cross Cannizzaro reaction, what we will do, less hindered is going to make carboxylic salt here, right? More hindered is going to make alcohol. Simple way, okay, simple. I am giving you simple tricks here, okay? It's like I am throwing marks on you, you have to catch that, okay? Yes, everybody, Gopika ma'am is also here. So Gopika ma'am, I am right now running to, complete their syllabus, right? So Gopika ma'am is here to, motivate you. Sure. Now preparation of carboxylic acid, these are different reagents. First is, if you have, let's say, alcohol or aldehyde, for alcohol you need strong oxidizing agent. For aldehyde, you also weak oxidizing agent will also work, like toluenes or phenyl will also work, right? If let's say you have RCN, you have to do strong hydrolysis, only then you will get acid here, right? With Grignard reagent, when you have CO2, right? Okay, chalo, this I'll tell you in the later part. With RCONH2, you just have to hydrolyze this. NH2 will be converted to OH, and hence you will have the formation of acid, right? With acyl halide also, you hydrolyze this Cl part will be converted to OH. Acid anhydride also, you hydrolyze this will be converted to acid. Ester also the same, alkene, alkyne, you just have to use strong acids here, Now, this is the important part in this page. This reaction is very important and this reaction is very important. This reaction is no matter on benzene ring, whatever is the alkyl chain, you will have propene, propyl, butyl, hexyl, ma'am, 20 number of carbon, ma'am. Everything is converted to COOH directly, any alkyl chain, okay? Now, as I told you, this part also I'm going to tell you. So if you have RMGX here, and this is C double bond O, this is C double bond O. So simple thing is, same thing we will do. This is positive, ma'am, this is negative, this is positive, this is positive, this is negative. Negative will attack here, electrons will jump here. C double bond O, this is O, this is MgX, and here you have the attachment of, wait a minute, here you have the attachment of R, right? After hydrolysis, you will have R, C double bond O, OH. That is how you get carboxylic acid on reacting Grignard reagents, a Grignard reagent with the carbon dioxide. Okay, that's a very, very important reaction. Next is the reaction of carboxylic acid. So see, carboxylic acid with hydrogen or water, they are going to get converted to, see, simple thing, wait a minute, are they reactions? Yes. See, when you have carboxylic acid, because this is an acid, so same reaction it will give with the way acid behaves. So acid with base or metal or bicarbonate or carbonate, they will give you salt of the carboxylic acid, right? Same way like acid behaves. HCl also reacts the same way, right? Reaction involving COH cleavage. Now, COH cleavage means this cleavage they are talking about, right? So if let's say you are adding P2O5, we are basically doing the elimination, right? So you can have the formation of anhydride ester. When you are breaking this bond with PCl5 or SOCl2, this OH will be replaced by Cl. If you are adding NH3 here, this OH will be replaced by NH2. These two are very, very important. They are frequently asked in your NEET exam, that when you add PCl3, any of the any halogenating reagent you are adding or ammonia you are adding, this will be OH will be replaced by Cl or NH2, right? Reaction involving COOH, this group, you need a very good reducing agent here so that this group is directly reduced to CH2OH, right? Then if you add soda lime decarboxylation, this is directly converted to RH, right? That we have done before as well, right? Next is reaction of carboxylic acids. So these are two very important reactions. One is Helmholtz-Zielinski reaction that says that if you have RCH2COH and you add X2 red phosphorus, on the alpha hydrogen will be replaced by the halogen here, right? Then there is ring substitution in aromatic acids, how this happens. So if you add, let's say, concentrated HNO3 or this, it is going to behave on the meta position. Can you tell me? Because this is a meta-directing group. I have told you before also, on the benzene ring, if you have any group that is directly attached to an atom, that is double bondedly attached with more electronegative element like oxygen, then it is going to be meta-directing here, right? Then it's test with, if you test this with NaHCO3, it is going to give you carbon dioxide, which is brisk effervescence. With FeCl3, it is going to give you violet, phenol is going to give you violet color test, but carboxylic will give you buff colored PPT, right? Okay, understood? Next part is preparation of amines. Now, amines is like frequently they are asking you questions from amines, like kind of their favorite chapters nowadays. So from amines, what you have to remember, if you want to prepare amines, how you will prepare? See, if you have, let's say, RNO2, you will use SNHCl or FeHCl. This is basically Stephen's reduction if you use SNHCl, right? So NO2 will be reduced to NH3, or if you do catalytic hydrogenation, that is reduced to NH2. Then you have Mendius reduction, where all the triple bonds will be reduced and you will have the conversion of that means 2 pi bonds will break and you will have the addition. See, you have C triple bond end, right? Pi bonds will break and here you will have H2, here also you will have H2. That is how you will have the formation of amines here, right? Okay. Or if you have RX, directly Hoffman homonolysis, more you add, see, if you add one RX, let's say you have RX, okay, you add one ammonia, that is converted to RNH2. You add 2 ammonia, that is converted to R2NH2. 3 ammonia, then you will have, eventually you will have, if you add just little of ammonia, this is RNH2. If you start adding more and more of it, then what will happen? This will convert it to quaternary ammonium salt. Then if you have RCONH2, you add LiL4 ether. So this is directly, basically this part is, wait a minute. This part is very important. This is, you will have the formation of RCH2NH2. Here you will have the formation of RNH2. This is important. Why? Because if in the amide you add simple any reducing agent, then this C double bond O is converted to CH2. And hence you will not eliminate this carbon here. But in Hoffman bromamide degradation, you will eliminate this CO here and you will have the formation of RNH2. That is why this is called degradation reaction. Okay, understood? Next is Gabriel phthalimide synthesis. Here you have this phthalimide. So what exactly happens? When you add K, it is replaced by K. When you add R, it is replaced by R. Then when you add water, these two bonds will break. This is H, this is H. And hence you have the formation of RNH2 here. And this is only for primary amines. This is only for the formation of primary amines. Understood? Next is preparation of amines here. This beta we have, I think this we have done already. Right. This also we have done. Okay. Then we have the reaction of amines. So in reaction of amines, what you have to understand is, reaction of amines, if you add HCl here, okay, you have, wait a minute. This is the simple thing. If you have HCl, then again you add base, not important for you, right? This is again Hoffman bromamide. This is again Hoffman homonolysis. This I have told you before also. You add Rx 2 degree, it will be more, add more 1 Rx, then it will be 3 degree, then it will be converted to quaternary ammonium salt. This is important. This is important. Then when you add C6H5COCl, then this hydrogen is replaced by COC6H5. So the hydrogen of this is replaced by COC6H5. Okay, that is benzylation. So if you add R-COCl, then this R-CO is replaced by the hydrogen of this amine, right? Then if you say, let's say you have anhydride, again this RCO, R- will replace the hydrogen, same thing. Next is carbylamine reaction for the detection of primary amines, whether it's aliphatic or aromatic. Remember that in this case you only make aliphatic. In Gabriel phthalimide, you only make aliphatic primary amines because aromatic is not possible. This Rx cannot be aromatic because it's very difficult to break the Rx bond, right? Carbylamine reaction is for primary amines, whether it's aromatic or aliphatic. Here, what we have is this RNH2 is converted by adding chloroform and alcoholic KOH, same reagents as Riemer-Tiemer reaction. This is converted to RNC, that is your false smelling compound, which is isocyanide. Okay, so that's why it is called isocyanide or carbylamine test. If you add HNO2, that is diazotization. Simple is, or they can also write NaNO2 and HCl. As I told you before also, aliphatic diazonium chloride is not at all stable. That is why here initially you will have the formation of RN2Cl. But this is unstable. That is why this is converted to ROH. Okay? This RN2Cl is unstable. That is why it is converted to ROH. Then this is your Hinsberg reagent. I'll just teach you Hinsberg reagent in detail. what exactly happens in Hinsberg region. This is detection of 1 degree, 2 degree, 3 degree. So in 1 degree, what you will have, HCl will be eliminated. You will have a compound which has hydrogen. That is why it is soluble in alkali, right? Next is, again, HCl is eliminated with 2 degree, but here you have a compound which does not have hydrogen. That is why it is insoluble in alkali. 3 degree will not show any reaction because there will be no hydrogen which can be eliminated here, right? Then we have the reactions of aryl amine. Okay, reaction of aryl amine is very simple. This is your aniline, right? So how you will do this? See, very important thing I am doing here, very important. If you have Br2 or you have, let's say, you have nitric. Where is nitric? So I'll do one by one. If you have Br2, water, it will give you tri-substituted product. Okay. So, for this, what we will do? Wait a minute. I'm going to write one reaction, that is acetylation reaction. So this is NH2. Whenever you add, let's say, CH3CO, acetaldehyde, or you can add acyl chloride, totally your choice, in presence of pyridine. Okay. Here the hydrogen will be replaced by, COCH3. Okay. The hydrogen is replaced by COCH3. And that is the reason here what you will have. Because hydrogen is replaced by COCH3. So remember one thing here, that here, now after doing bromination, you will have only para-substituted product. Okay. Bromination will give you para-substituted product. Nitration also will give you para-substituted product. Okay. So if you want to have, why it was giving you tri-bromo substituted? Because aniline is very active. Okay, it wants to donate. It's very high density on ortho and para positions. So to decrease the density over here, we have made this lone pair, because this lone pair was a culprit. It was like, I want to donate, but we made it busy with which thing? This C double bond O. Now this, if you see this here directly, if you see this, this is N. Wait a minute. This is N, this is H, this is C double bond O, this is CH3. Now this lone pair is busy in conjugation with the carbonyl compound. That is the reason it will only give you para product. If you want to get para product, you will do acetylation and you will get your para product, right? In nitration also, why we did acetylation? Because in nitration, what happens? When you add nitration, that is concentrated HNO3, you will get 3 products, that is meta plus para plus ortho. Okay, meta plus para plus ortho. Unusually, meta product you are getting 47%, para you are getting 51%, ortho you are getting 2%. Why we are getting meta product? Because this is converted to anilinium ion. What is anilinium ion? This is base. These are acidic conditions where you have concentrated HNO3, concentrated H2SO4. That is why this will accept the proton and getting converted to anilinium ion, which is meta directing. That is why you get meta product also. To eliminate this thing, we firstly do acetylation, and after that we do nitration so that we only get the para product. This we have done, that is carbylamine. This also, beta, just like in phenol, you add K2Cr2O7, you get benzoquinone. Similarly, in aniline also you get the same. This we have done. This also we have done. Okay, all these we have done. Okay. Last is disonium chloride reactions. These reactions, Sandmeyer, Gattermann, we have done before also, right? Okay. If you have disonium chloride and you add H3PO2 or you add water or you add ethanol, you will get the formation of benzene. So this question is also very important. From disonium chloride to benzene will be formed. If you add H3PO2 or let's say ethanol, that will give you benzene, right? Then there is, if directly you add Ki, you will have idobenzene. If you add HBF4, this also we have done. This I taught you before also. This also I have taught you, right? This I have taught you, that NaNO2 plus CO2. This I taught you na, that directly in disonium chloride, either you add HBF4, then you add NaNO2 and copper, you will get nitrobenzene. Or directly you add NaNO2 and copper, you will get nitrobenzene. If you add benzene here and NaOH, you will get diphenyl, that is called Gomberg reaction. Okay? That's it. Now, rather than questions, I'll do, okay, because questions, we don't have that much time. Right? Question we will do some other day. Don't worry. Question we will do some other day. Right? Let's do biomolecules, okay, because the theory part is important. Now, I thought that I will be able to complete questions also, but I don't think so that is possible. And I don't want Baswa sir to wake up till 5 a.m., right? Obviously, he is also waiting for us, right? So, in next 10 minutes, I'm going to finish biomolecules, right? So, biomolecules, let's see glucose here. First is glucose. So for glucose, you should remember all the reactions. So this is glucose. If they ask you, how can you justify that glucose has 6 carbon atoms linked in a straight chain? If you react this with HI, you have the formation of hexane. Okay. Then glucose, when it reacts with NH2OH, then it has the formation of CH double bond NOH. Now this is also very, very important. I'll just write it here. You know, you have a reaction. I'll also send one page on your Telegram channel. Please go through that page, okay? So this is C double bond O, this is something, and this is NH2, this is Z, okay? Now, I'll just write it like this, N, this is Z, this is H2. Now, this water will be eliminated and you will have N, this is Z, and this is C, this is double bond, and this is this thing, right? Now this Z is going to vary one by one, and according to that you will have the formation of different things like Schiff's base, semi-carbazone. That table is there in NCERT. I'll send you that table on the Telegram channel, right? If I forgot, then please write it in the comment section that ma'am, you have to send that table, because sometimes it just, I skip things, right? Okay, so you have to remind me also. Now, why I taught you this reaction? Because here you can see that why it confirms the presence of carbonyl compound. Because if you have C double bond O, only then with the elimination of H2 and O, it can have the formation of C double bond NOH. C double bond NOH. That means there is formation, there is presence of carbonyl group. Then if you add HCl, that is also confirming you, because it is forming cyanohydrin. So when you have C double bond O, right, you have H positive, Cn negative. Cn negative is going to attack here, right? Here you will have Cn, and here electrons are going to jump, you will have OH. Again with this, what you will have is cyanohydrin, that again confirms the formation of carbonyl group, right? When you add bromine water, what happens is you have the formation of gluconic acid. This is very important, right? Gluconic acid, where you have just one COH group, right? But when you add nitric acid, that is oxidation, now both CHO and CH2OH both are oxidized to COH, that is saccharic acid is formed here, right? Okay. Then let's say you add, now these two things are confirming, this indicates aldehydic group and this indicates the presence of primary alcohols. How this is indicating? See, very simple thing. If you add an oxidizing agent, right, it is going to oxidize not alcohol, but it is only going to oxidize this CHO to COH. Right? That confirms presence of one aldehydic group. And here, if you see the next part, when you add acetate group here, then all the alcohols are replaced by the acetate group. That means you have 5 alcohols. But when you add nitric acid here, then only the primary alcohol will be oxidized here. Right? This indicates the presence of one primary alcohol here. Because This is such a strong oxidizing agent that it can also oxidize primary alcohol, not only the aldehyde. This is, as compared to this, it is a weak oxidizing agent. That's why it is not able to oxidize primary alcohol. It only oxidizes CHO, right? Now, these were the reaction parts. Now, beta, you have to remember few things. Glucose does not show 2,4-DNP test, shifts base test, and NH test. That confirms the cyclic nature here. This is very important. Structure of glucose is this, right? Now, I'll explain you that basically. Structures, beta, you have to draw yourself. I can only tell you that this arrangement is there, right? So this is the structure of glucose. You can mark it 1, 2, 3, 4, 5, 6. What you will see on the third position, you have OH on the left side. In all the other position, OH is on the right side, right? Then if you draw the cyclic structure here, these are the two cyclic structures that you will have, alpha and beta. Okay, alpha and beta, these two are very, very important. So here what you will see, 1, 2, 3, on the third position again you have OH, right? Rest of this hydrogen is on the left side only, right? Only on the third position it is on the left side. And first carbon and fifth carbon is linked by OH here, by O here. That is the cyclic structure, right? But in beta carbon, in beta glucose, OH is on the first carbon also. First carbon also, OH is on the left side. But in this case, only on the third carbon, OH is on the right side, that is left side. That is the difference between alpha glucose and beta glucose. Okay. Next is the structures. It has pyranose kind of structures. Achha, for this, just remember one thing. If you remember this structure, right, just remember DR. The right side will be on downwards. The right side, if you, let's say you have, this is the first carbon where OH is on the right side. So first carbon, OH is on the right side means it is downwards. So it's not a big deal to prepare this thing. From here, you can easily prepare this thing. That means OH is always, if you have something on the right side, that will be downwards. Okay, from that you can prepare alpha D and beta D glucose. It will use pyranose ring here. But for furanose ring, okay, furanose ring, you have 5-membered ring. That is for fructose. Okay, so here what you happens, for alpha carbon, what you will see on the first position, OH is on the right side. That means it is downwards. But for beta fructose, OH is on the upwards. Okay, OH is upwards for the beta glucose, right? These structures are very, very important. Glucose, fructose, galactose, you have to draw the structures, and then also you have to see the glycosidic linkages. Now I'll just directly tell you the glycosidic linkages here. Sucrose is non-reducing sugar, very important. Then you see this here. What are the linkages here? The linkages you should remember is, for sucrose, you have C1 alpha D and C2 beta D fructose linkage, glycosidic linkage. When you talk about lactose, you have C1 galactose and C4 galactose linkage, C4 glucose linkage. And here what you should remember, what is the difference between galactose and glucose? At C4 position, they have the difference. If you see the C4 position, this is 4th position, this is 4th position. Here OH is upwards, here OH was downwards. Here H is downwards, here H was upwards. That is the only difference between galactose and glucose. Okay, at the C4 position. Next is, you have maltose. In this you have linkage between C1 of alpha D with C4 of another alpha D glucose. Okay, C1, C4 linkages of alpha D glucose. Then if you talk about polysaccharides, you have amylose and amylopectin in starch. Linkages you should remember because directly they will ask you from the linkages. I think this yesterday biomolecules, Baswa sir was also doing the same at 3 p.m. if I remember, right? So that's why I am, doing only those things. More of the structural part I am doing because I know in bio also you have done the same thing, right? Alpha D glucose unit held together by C1C4. Alpha D glucose in amylose, right? If you talk about amylopectin, here C1C4 and C1C6, both the linkages are there. That's why it is branched. And if you talk about glycogen, it is same as amylopectin, but it is highly branched as compared to amylopectin, right? Then cellulose has a different linkage. It has beta D glucose C1C4 linkages. It has beta D glucose C1C4 linkages. Okay, so these are very, very important. These linkages directly they ask you. Students focus more on drawing the structures. Trust me, that is more structure drawing is more important. You should know that, but it is more important in board examinations. Linkages should be on your tips. It's not like you will skip the structure drawing. That you should also know that as well. Directly they can ask you in this structure at C4 position, where is the OH? You should know that, right? Then you have amino acids. Amino acids we know that is having NH2 and COHO group, right? And because when this accepts the hydrogen from this acid, it forms Zwitter ion here, right? Then classification of amino acid is two types: essential, non-essential. Those which cannot be synthesized in our body and are provided externally. Non-essentials are that our body can itself synthesize. It does not need it from the outside. This is more in detail in your bio, right? In biomolecules, this is more in detail regarding what are the kind of amino acids, all of this. Do it from there. Full detail you have to do, right? Now, talking about proteins here, fibrous and globular protein you have, right? Fibrous are insoluble in water, like our hair, right? Like our nails, they are insoluble. But globular are, they are soluble in the water, right? Next is primary, secondary, tertiary and quaternary structure of protein that gets more complexity as you go beyond, right? In primary, you have the linkages of amino acid, the peptide bonds. In secondary, the way they are arranged, that is whether it's alpha helix or beta pleated structure. Then how this alpha helix and beta pleated structure in a tube. If I put something in a tube, let's say I have some ring, I'll put it in a tube, right? How that ring is arranged. Okay, the tertiary structure is basically, you can say that is your this what I told you, fibrous and globular, right? Then you have your quaternary structure, which has the more complexity when you arrange all these tertiary structure together. I tell my students that it's like you have a snake, right? The snake, the atoms are bonded to each other. Then the snake, how it is connected? Is it connected like this? Is it sitting like this? Is it sitting like that? That is alpha and beta plated. If you put the snake in a tube, right? How you are rolling that tube? That is tertiary. If you have so many snakes in different tubes, and how those different tubes are connected, that is your quaternary structure. It gets more complex as you go beyond this. Then there is nucleic acid. Nucleic acid is RNA and DNA. Here you have ribose. Here you have 2-deoxyribose sugar, right? Now, three things we have, okay? One is pentose sugar, other is phosphoric acid, third is nitrogen containing base, right? What you should remember is, this is ribose, this is deoxyribose. These are the structures here. Here on the second position you have OH, here you have deoxy, means oxygen you have taken out here from the second position, right? Then nucleotide and nucleosides. In nucleotide you have base plus sugar. In nucleotide you have phosphate group also linked. In this case we call it nucleotide, right? DNA and RNA, remember one thing, if you have A, T, or let's say AU, okay, they both have two hydrogen bonds. If you have G and C, it has 3 hydrogen bonds. Okay, it has 3 hydrogen bonds, that is G and C. Now remember that in DNA everything is same, it's just that here you have thymine and in RNA you have uracil. That is the only difference. Okay, that's why I drew A or T or A or U. Okay, so that's how Hydrogen bonds also, you should know how many hydrogen bonds what is making, right? Okay, so these are the diagrams, right? That I know you have done in your bio part, right? Then is vitamins, last part of today, that is vitamins. There are two kind of vitamin. One is fat soluble, other is water soluble. Fat soluble vitamins, the examples are very important. This is KEDA, Kida. Okay. So fat soluble vitamins, they are stored in the liver and adipose tissues. They get stored in our body. That is why vitamin A, vitamin D, vitamin E, vitamin K, they are fat soluble, they stored in the body. But if you talk about vitamin B and vitamin C, they are water soluble. We will urinate it out, right, from our body. So we need to take care of vitamin B and vitamin C, right? They are readily excreted in urine and cannot be stored except for vitamin B12 that is stored in our body. Vitamin B12 can be stored in our body. The sad part is, your ma'am, my vitamins are, vitamin B12 is very less, vitamin D is very less. That is stored in the body, that is very less in my body. Oof, problems of Diksha ma'am. Okay, now students, these are the vitamins and their deficiencies. Sources you can skip, sources you don't have to do. Do the deficiencies of these diseases. Okay, what are the deficiencies, right? Like for example, vitamin B2, right? Okay, then for example, vitamin B6, right? Then for example, vitamin B12. Okay, so what are the different deficiencies, diseases that you can have according to these vitamins here, right? Okay. Yes, everybody, I think now I should call Baswa sir. Everybody let me know in the chat box if that is clear to you or not. Everybody let me know in the chat box if everything is clear to you or not. Yes, everyone. Oof. 4 hours of non-stop speaking I have done for you guys only, right? And I want to see that whether you like this, whether full class 12th revision along with the redox reactions you have done or not, right? Okay, so I promise you that thing, if you have done this thing in detail, I promise you can easily crack 160 plus marks, okay? Some 20 marks here and there, obviously we need something more in detail, but 160 plus, so I can guarantee you, right? You can even score 170 plus, right? Easily, if you do DNF block, P block, block chemistry exceptions in detail, right? Because from inorganic chemistry, they will ask you from line by line, they ask you the questions, or maybe some exceptions. Mostly things I have covered here, right? Okay, then more thing that you need, why I'm saying those 20 marks, I'm still in question mark, because what you need is practice, okay? So practice, questions, a lot of things you need after this, that definitely we will do this, right? Okay. Chal. Now, if you want break, then let me know here. Then let me know here. And for all my students here, what we are doing right now for you, let me see. First, let us see how many likes you have given here. Let me see. I think it should cross 500. Yeah, what is this there? What is this? What is this? 331 likes. 4 hours, someone is non-stop speaking in front of you, not even speaking. See the kind of content that we are providing you here. It makes me feel so weird that I have to ask you for this. Really? Do we need to ask you for this? What is this there? What is this? 331 yeah. What is this? It should have crossed 1K by now. Very disappointed by you. You guys always, you're like, okay, ma'am, we will always disappoint you. Sometimes it breaks my heart. When you sit in the morning, right, at 10 a.m., you are like studying, making PPT for the kids, making PPT for them. You have class, you have again class, you come here without having dinner. I have not eaten anything. I have eaten from 3 p.m. I had my lunch. After that, I am on water only, right? In front of you. You can sit there. You can sit there. You can eat something. I can't. Now, Baswa sir will take the class till 3 p.m. or something. Sorry, 3 a.m. or something. It's not a joke, right? It takes a lot of effort of teacher as well, a lot of dedication of teacher as well, right? to make these kind of sessions where in very less time you revise so many things, right? For that, at least you can give us some likes, right? Some comments. Like yesterday, I went through your comments, right, on class 11 chemistry. That made my day, right? But very few students are there who are actually willing to, appreciate the teachers. Teacher has given up their whole life for them, but they will not use their hand to type one comment. This much laziness you guys show. Liked. Chalo. Those who have done for those, I have one this heart for you. Those who don't do this, I have nothing for you. Okay, see the video, go and chill. I can't do anything about you guys, right? Those who have, liked the video, right? Survey is saying so conjuice you guys are. Okay, chal. Now let us see what we have for you. This is all totally for free of cost, right? So this is NEET Revise-a-thon. As you can see, all these things that I'm showing you right now is totally free of cost. Okay, so this is NEET Revise-a-thon. You can revise everything, all the chapters, even mock test will be provided to you totally free of cost. AIMT All India mock test will be provided to you. You can click here, you will get that, right? NEET Telegram boot, right? That will be provided to you. Full on 24/7 assistant will be there with you. NEET PDF for smart notes and library, right? Your notes, let's say you're talking about, ma'am, notes I want previous year question, ma'am, I want NCRT questions. Everything is there in this NEET PDF, right? The NEET Champion Test Series, Test Like a Topper, designed by NEET expert. Click here, that is NEET Test Series. So everything we are providing you here, every single thing, that is totally free of cost, right? You just need to click there and see whatever you want to have, okay, what you need, okay? Yes, our students only break hearts. Yeah, that is true, Baswa sir. Now, Baswa sir is going to take class, right? And it's not easy to give up your sleep, guys. It's not easy, right? And from 9 a.m., it's not like we don't have other channels, right? We have other channels, we have other classes also that are going on. Right? But still we give priority to you guys, right? So that means you mean something to us. Okay, for that we also want something in return. Okay, what if you have crush on someone and you are only putting efforts, and one time you'll be like, okay, go away, I don't want to, I will not even look at this person, right? So same thing is with us. We are also humans. Okay, when we put so many efforts for you, right? What we want is your appreciation and your shares, your likes, that's it. And one more thing, your selection, your seat, because all this what we are doing is for your selection, right? So that after cracking NEET, you will be like, yes, I studied from Vedantu NEET English. My teachers were there with me, right? So that you can thank us, because right now when we get messages after NEET exam, that makes us happy, right? So that is the kind of motivation that we all need, right? Okay, chal. Now I'll end this class, and tell me in the chat box, Baswa sir is here. If you want any 5-minute break, Baswa sir will decide. I am nobody to decide here. So what I'll do, I'll just take the stream off, and then it's the talk between you and Baswa sir whether you guys want to take break or not, right? Okay then, bye-bye, take care. See you all in the next class. Bye-bye. And also, tomorrow I am going to take practical chemistry that will be uploaded on the channel. I'll provide you that on the Telegram channel, right? And go through that lecture. That is only 2 hours lecture that will help you. Everything we have done except for practical chemistry, then we will do in that particular lecture. Okay then, bye-bye. This is Diksha Kaushal signing off. All the best for your botany section. Bye-bye.
Hello students, hello everyone. Students, quickly tell me in the chat if I am audible and visible to all of you. Students, quickly tell me in the chat right now if I am audible and visible to all of you. Students, quickly in the chat, all of you. If I am audible and visible. Yes, I am, right? I am. Now students, right, I think we'll give you a small break. For 10 minutes, for 10 minutes sake, right? After 10 minutes, we'll start. Sure? Okay? Yes, all of you students, yes, I'll give you a break. Don't cry. What? Already crying. Don't worry, students. I am not very ruthless. Okay, I'll give you a small break. We will start fresh and with full energy exactly at 10:30. Yes, students. We will start exactly at 10:30. All of you students. At 10:30 p.m. Shall we, students? Shall we? Yes. Yes. Students, yeah, notes I'll send you, don't worry. Notes I'll send you. Okay. Notes I'll send you, students, don't worry. Okay. So exactly at 10:30, last class notes I'll send you, don't worry. Okay. Yeah, how fast that comes because I can't wait. Okay. So students, we'll start exactly at 10:30 p.m. Until then, take a small break, go eat something and come. Okay. Don't be hungry. Again, if you're hungry in the class, you'll not have any ATP. If you do not have any ATP energy, you will not be able to remember anything. So as a matter of fact, please eat something and come. I hope all of you have eaten dinner by now at least. Okay. Shall we? Yes. Okay. Omnivores we are. Okay. We don't know discrimination. So students, I'll see you exactly at 10:30 p.m. in my class. Okay. Take a small break. Hello students, everyone in the chat, all of you dinner done? I hope the dinner is finished, all of you in the chat quickly. Yes? Is the dinner over? All of you students in the chat. Is the dinner done? All of you. Yellow, I'll start. I will start right now. Students, dinner done. What did you eat, all of you? What did you eat? Anyone in the chat who can tell me? Yes, I know time is up. What did you eat, students? What did you eat? So I ate nicely. I ate fruits. So in the night I eat only fruits. So I ate nicely fruits. So, okay. What did you all of you eat? Yes. So let's slice the bot with 100% energy. Yes, full energy now. Full energy. So students, can we start today's session with entire human reproduction? All of you, shall we? Yes. I finished. All of you. I finished dinner. Crazy dinner I had. Okay. Yes. Dosa, idli, parota. Oh. Students, you're making me jealous now. All of you eating biryani in the night time also. Crazy. Now, students, let's start the human reproduction chapter. First of all, what do we need to study in this chapter? In this chapter, we will be starting off with students gametogenesis. Then we have insemination, fertilization, implantation, gestation, parturition. Again, students, I'll tell you one more thing. Question can come from anywhere. As a matter of fact, question can come from any of the following parts for your NEET 2025 examination. Okay, students. So I'll be telling you topics one by one. I'll be telling you this topic. This is very important. So students, if you have any doubt regarding any question anywhere in the middle, always ask me in the comment section or in the chat box, and I will reply to all of you personally. Okay, students. So with that being said, students, let's start the class with the first topic in the hand. The first topic is right here, students. The first topic is right here. Now here we have something called as male reproductive system, students. The male reproductive system. Now if I ask all of you one simple thing, what is the location of male reproductive system? The location is between the two coxal bones in the abdomen region. So in the abdomen region, male reproductive system is located. Okay. In the pelvic region or the abdomen region, it is located here. Now students, in the case of human male reproductive system, right? Entire thing is divided into two categories. We have something called as primary sex organ and secondary sex organ. Now students, can anyone in the chat who can tell me what is the primary sex organ here? The primary sex organ is nothing but the testis here. Testis. Now students, every single primary sex organ should be able to do two things. It should be able to do what? It should be able to produce hormone as well as gametes. So a primary sex organ in the case of your human male reproductive system is a testis. It should be able to produce hormones and gametes here. Now, does it do that? Yes, it does. Students. Yes, it does. Now, what is the location of testis? Students? Location of testis is actually outside the abdominal cavity or abdomen. The location of testis is actually away from the body. That is, the testes are situated outside the abdominal cavity. Now you might ask me, why, sir? Why so? Why are we giving special treatment here? Very simple, student. Very simple. The testis is located in a pouch-like structure called as scrotum. The reason being, students, because in the scrotum, the temperature of to maintain the temperature of the testis 2 to 2.5 degrees lower than the body temperature. Why? Because for the spermatogenesis. If the spermatogenesis has to take place, the temperature in the testis has to be 2 to 2.5 degrees less than the body temperature. Now, that comes to one more question. Students. Let's take a man who is in desert. Let's take a man who is in Thar desert. The temperature is very high there. Will he be able to do spermatogenesis? Tell me yes or no. Students, let's take a man who is in Thar desert or Sahara desert. Will he be able to do spermatogenesis? The answer is yes. Let's say take one more man. This one more man is, let's say, he's in Antarctica. He is sitting inside an igloo. He's sitting inside an igloo. Will he be able to do spermatogenesis? The answer is yes again. Why? Because of beautiful process in our body. Because of a beautiful process in our body called as homeostasis. With the help of homeostasis, humans can maintain the internal body temperature. Humans can maintain the internal body temperature, and henceforth spermatogenesis will happen. It will happen, students. It will happen. Now, students, now what is present inside testis? This is a typical internal structure of a testis now. Now, if you look at inside a testis, it has something called as 250 compartments. What do you call that, students? What do you call that? So inside one testis, right, there are 250 compartments, 250 compartments. And these compartments are called as what? Testicular lobules. These compartments are called as what? Testicular lobules. How many are there? 250 in one testis. So can anyone tell me the chart right now? What about in the case of a human male? In the case of a human male, how many testicular lobules can you find? In the case of human male, how many do you find, students? How many do you find? 500. 500 because two testes, 250 in each, so 500 in each. Okay. Now, students, inside one testicular lobule, inside the testicular lobule, there is something called as seminiferous tubule. So inside one testicular lobule, there are 1 to 3 highly coiled structures called as seminiferous tubule. Now I'll give you a perspective. Imagine there is a very large house. Imagine there is a very large house here. Okay. This large house is the testis. Okay. In this large house, there are around 250 rooms. 250 rooms are there in this house. Now, students, inside every room, there are 1 to 3 window. 1 to 3 window. And the window here are the seminiferous tubule. So one testis, 250 testicular lobules, and 1 to 3 highly coiled structure called as seminiferous tubule. Done, done, students, done. Now, what is present inside now seminiferous tubule? Now, what is present inside the seminiferous tubule actually? Now, understand, students. If you take the cross section of a seminiferous tubule, inside the seminiferous tubule, this right here is a seminiferous tubule. Inside one seminiferous tubule, there are two types of cells. Can anyone tell me which are these two cells? Students, can anyone tell me which are the two types of cells here? Inside one seminiferous tubule, two types of cells. In the lining of seminiferous tubule, there are two cells. First one is called as what, students? Sertoli cell, also called as the Nernst cell. Nernst. All of you know Nernst cells, right? Nurses will help in what? They will take care. Nurses will take care, right? So here also, Sertoli cell or Nernst cell, main function is they can provide nutrition. They also produce something called as ABP. What is ABP? ABP is nothing but androgen binding protein. ABP is nothing but androgen binding protein here. Now, it also helps in, Sertoli cells also help in spermiogenesis, not spermatogenesis. Okay. Now, the second cell here, student, the second cell here is called as your male germ cell. Male germ cell. Now, this male germ cell is also called as spermatogonia. And this spermatogonia actually is going to be, students, diploid in nature. And it is the same spermatogonia which undergoes meiosis to produce sperm here. Now, students, if you can notice here, spermatogonia is diploid in nature, sperm is haploid in nature. So this process right here, meiosis, can I call it, students? Can I call it, let's say, reduction division or equational division in the chat? So meiosis is change in ploidy. So I will call it reduction division. Meiosis happening. So we can have meiosis 1 and meiosis 2 can be happening here. Meiosis 1 and meiosis 2 is happening here. Done, students? Done. Now, this is happening inside the cell here, inside the cell. Now, what about the outer area here? Now, students, the outer area is called as interstitial space. Like outer space is there, no? Imagine this is earth here. This is the earth here, okay? Now, outside part is the space here, space. Now, this space is called as interstitial space. Now, students, in this space, we have a interstitial cell. This cell is also called as what? This cell is also called as Leydig cell. So interstitial cell is also called as Leydig cell, which is present in the outer surroundings here. What is the main function? The main function is going to be production of androgen. Testosterone, type of testosterone. So students, remember, let's go back. Here I told you students, a testis has two main functions: hormone, androgen, gametes, sperm production. Both checkpoints done. Both checkpoints, students. Androgen tick mark, sperm tick mark. So both are produced inside the seminiferous tubule. So students, if I ask all of you a simple question, what is the site of sperm production? What is your answer? What is the site of sperm production? What is your answer? You will tell me, sir, the site of sperm production is the seminiferous tubule. It is going to be what, students? Seminiferous tubule is going to be the site of sperm production. Students, how is the energy today? Students, how is the energy today, students? So we finished all of this. Yes, we finished all of this, students. We finished all of this. Let's just put some tick marks here. 250 compartments done. Seminiferous tubule done. Seminiferous tubule, Sertoli cell, nutrition done. Male germ cell, spermatogonia done. Leydig cells done. Done. Students, till now, any doubt in the chat? Students, till now, any doubt in the chat? All of you, I'll take up the doubts. Any doubt in the chat, students, till now? Till now, do I see any doubt in the chat? All of you. All of you? Any doubt till now? Any doubt? Yeah, correct. So I hope there is no doubt till now, students. I hope there is no doubt. Okay. Yeah. Bioclass students, you should know bioclass how it's going to be. Okay. Perfect, students. Perfect. Now, students, let's quickly decode the diagram as usual. As usual, we completely decode the diagram. We do not give any room for errors now. Now, one by one, let's completely destroy this diagram right here. And I will teach you every single point here. So try to follow with me. Every single time I ask you a question, you should tell the answer in the chat. Do not be lazy. Laziness will kill your concentration. Laziness will kill your energy. So no more laziness in my class. Okay. Now students, starting the diagram. Here, the first thing is, students, can anyone tell me which is the primary sex organ here? The primary sex organ is going to be the testis right here. Testis. Now here what happens is the sperm is produced inside the seminiferous tubule, which is a part of testicular lobule. So the first location where the sperm is produced here is the testicular lobule. Now from here the sperm is traveling. The sperm is moving here. It is going on a long journey. Okay, journey to the center of here, part here. Okay, so you understand here. The first location of sperm travels is called as retate testis. The first part here done. The second part is called as vasa efferentia here. Vasa efferentia here. The third part is called as epididymis here. Epididymis. And remember, students, the entire sperm maturation happens in the epididymis. And again, epididymis is actually the longest part. Epididymis is the longest part. It is like a spring. Students, all of you know what is a spring, right? See, when a spring is this much, it looks very small. But if I pull the spring apart, it becomes very long. So your epididymis is like a spring here, where entire sperm gets matured and stored for some time. Now, from here, epididymis, next step is called as vas deferens here. Now, students, all of you tell me in the chat right now, if I cut the part here, if I cut it and I join these two, if I cut it and I join these two parts, what do you call that process? That is called as what, students? That is called as what? What do you call that? Vasectomy. Vasectomy, students. Vasectomy. Now from here, the sperm is moving up, and the sperm reaches this region right here. Can all of you see this region? Now this is a region which is very special here because, understand, students, understand here. Now from one gland, we can see here. This is going to be seminal vesicle gland. Okay. Now from this seminal vesicle gland, it's right here. Now we have vas deferens. Vas deferens is coming from top. Vas deferens is coming from the top like this. Okay. Now this region right here, where the one duct is coming from, vas deferens here. The second duct coming from, so vas deferens duct here, and seminal vesicle duct here. So from here, all the seminal plasma is coming from here. Okay. At the same time, the sperm is traveling from the top here. Now this region, the common point that region is there, right? This region is called as what, students? This region is called as ejaculatory duct. Ejaculatory duct. It is not mentioned in NCR, students. It is not mentioned in your diagram, but mentioned in the writing part. Students. So here is the ejaculatory duct right here. Now, students, here we know that there are 3 ducts here. There are in total of 3 ducts. In total of 3 ducts are present here. The first duct is called as seminal vesicle, right here, the first one. Second is called as prostate. Third is called as bulbourethral gland. My first question to all of you is that out of the three glands present here, which gland is lonely? Which gland is unpaired here? Which gland is, students, unpaired here, students? Anyone who can tell me? Anyone who can tell me, students? Anyone who can tell me which gland here is unpaired and alone, basically? Okay. Anyone who can tell me, students, which gland is alone here? That is going to be, students, what? The alone is going to be the prostate gland here. The prostate gland is going to be alone here. Prostate, unpaired. Now, apart from, student, prostate, bulbourethral gland is also called as Cowper gland. It is also called as what? Cowper gland also. Remember that. Now, the seminal vesicle, prostate, these 2 glands mainly produce something called as seminal plasma. The seminal plasma has fructose, calcium, and enzymes. This much you remember. Repeat after me. The secretion of these 2 glands mainly consist of fructose, calcium, and enzymes. Multiple enzymes are present here. Okay. This person is single, exactly. Lonely person. Okay. Now, what about bulbourethral gland? Bulbourethral gland actually produces mucus because that is required during the intercourse, right? So it provides mucus for lubrication here. Done. Now, students, the secretion of these glands is called as what? The secretion of this gland is called as seminal plasma. Now, plus the sperm which is coming from the top here. Sperm. Now, the sperm plus seminal plasma, it is called as what? Semen. It's called as semen. Semen is coming at last. Done, students. Done. Now what happens, students? Now we can't tell sperm here. We should say semen. The semen is traveling right here. It is traveling in this middle part. This is a common duct here. This part is called, middle part is called as a common duct. The common duct is called as urethra here. Now, what do we mean by common duct? It is a common duct for 2 different passage, for urine release as well as a semen release. It is a common duct for semen and urine release, also called as urogenital tract. Also called as what, students? Urogenital tract here. Now, this region, do you see here, students? This part here has something called as erectile tissues. It has something called as erectile tissues here. Corpus, all of you know, right? Erectile tissues here. They help in the erection, this region here. Now, students, then the semen is traveling and coming down to the swollen end of the penis here. This entire thing is called as the penis, the external male external genitalia. The swollen end is called as glans penis. This part is called as what? Glans penis. The entire penis, especially the glans penis, is covered by a loose skin that is called as foreskin, also called as prepuce. Also called as what, students? Prepuce. Now, this small opening, do you see here, students? This small opening is called as urethral meatus. Urethral meatus is the opening of the penis, is called as urethral meatus. And with that, the diagram is over. With that, the entire diagram is done and dusted. Starting with the testis, sperm, ejaculatory duct, 3 glands here, common tract, erectile tissues, glans penis, urethral meatus, and foreskin. That's all you should know. Every single point has been dealt right now, and nothing more than this will be as an examination. Whatever you need to know about the entire male reproductive organ is discussed in just 5 to 10 minutes. Done, students. Done, students. All of you understood? Students, all of you understood? How was it? This is called as proper revision. This is called as a proper revision where every single detail gets stuck in your head. Every single detail, students. Every single detail gets stuck in your head. And again, students, I can make you write all this 10,000 times. But when I say a word, it should get imprinted in your brain. It should get copy paste in your brain. Okay. Now, students, let's go back. What if you missed out anything? So all of you should know the passage. All of you should know the entire passage here. Okay. Now, urethral meatus is the opening here. Opening here. Glans penis is the swollen end of the enlarged end of the penis, and foreskin is the loose tissue. Done, students. Done. Nothing more. This is important here. The male axillary glands are called as your seminal vesicle, bulbourethral, and unpaid is prostate here. You should know it has fructose, calcium, and certain enzymes. Okay, students, I can tell you more information. I can tell you about it makes fluid alkaline in nature. It has multiple different types of secretions, but all that they'll not ask you in examination. This is the only lines they'll ask you in examination. This much you should know, examination point of view. Okay. Now, students, with that, can we start right now the female reproductive organ? Students, can we start right now? Shall we start? Students? Shall we start? The female reproductive organ, shall we start? Students, where is the energy? I don't see the energy in the chat. See, students, if you not, there is a correspondence of energy is not there. What is this? Shall we start right now, students? Diagram is, this is the, that's all the diagram is. Nothing more than this that I can ask you diagram. Okay, shall we start? Let's go. Now, again, in the case of female reproductive organ location, it is again located in the pelvic region between the two coxal bones. But here the coxal bones are going to be much more wider in nature also, because in the females the pelvic is much more enlarged for the childbirth purposes. All of you know that. Okay. Now again, students, in the case of female also, right, there is something called as primary sex organ here also. Primary sex organ. Also, there is something called as secondary sex organ here. Can anyone in the chat tell me, students, which is the primary sex organ in the case of female? Quick. The primary sex organ in the case of female is going to be ovaries are the primary sex organs here. Again, as usual, students, as usual, a primary sex organ should be able to produce what? Hormone as well as something called as gametes. Gametes here. Okay. Now, students, about 2 to 4 centimeter in length, is connected to the pelvic walls of the uterus by ligaments here, mesovarian ligaments. Okay. Now, understand the diagram here. Students. Okay. This is a cross section of one ovary. Done. Now, here, students, I want all of you to understand very clearly is that the entire ovary has an outer layer around it. The entire ovary has an outer layer around it, very thin layer called as epithelium. Called as, students, point number 1, epithelium is the outermost layer, outer layer. Now the inner part is called as what? Stroma. Inner part is called as what? Stroma. So outer we have epithelium, inner part is called as stroma. Now, students, understand very carefully. The inner part is now divided into 2 parts again. The inside itself is divided into 2 parts now. Okay. So first outer layer, inside part. Inside part is what, students? Inside part is called as stroma. Now, stroma is divided into outer cortex and inner medulla. Outer cortex and inner medulla. So, outer cortex we have here. Outer cortex here, where the development of follicle happens. In the outer cortex, students, development of follicles happens. All of you know secondary follicle, tertiary follicle, Graafian follicle. All the development happens in the outer cortex here. Now, what about the inner part? The inner part is called as what? The inner part is called as medulla. It's called as what, students? Inner medulla. Now, this inner part is called as inner medulla. It is very rich in blood vessels, nerves, as well as lymphatic vessels. That's all is the concept here. So here, I'll repeat again. Epithelium, stroma. Stroma is divided into outer cortex, inner medulla. Done, students. Done. Peripheral cortex, inner medulla. Done. Stroma is divided into. Now, students, that is the primary sex organ done. Now we come to something called as secondary sex organ. In secondary sex organ, students, shall we start the diagram? Shall we decode the diagram, students? Shall we decode the diagram again? Shall we? Like how we did for male reproductive system. Shall we decode the entire diagram of female also? Shall we start? All of you? Yes. Because when I see you, I can give you the notes. I can give you the notes. You can read your notes. That is very simple to things to do. But when I say something, it gets fixed in your mind. My words should be fixed in your mind like there's no tomorrow. Okay. Let's decode the diagram. Let's decode the diagram here. Now again. Now students, again here we have the primary sex organ, ovaries here. Ovaries. There are 2 ovaries. Every single ovary, every single month. If this month, let's say April, this ovary releases a secondary oocyte. This ovary will release secondary oocyte in the next month. That's all you have to remember. Now here students, this region is called as what? This region is called as fallopian tube. Do you think fallopian tube has one more name? Fallopian tube has one more name? Yes, it does. Fallopian tube is also called as what? Oviduct. Oviduct. So in examination, if they give you, don't get confused. Like, oh, what is this out of syllabus? It is not out of syllabus. All of you know that. Okay. Now, let's take this ovary, releases a secondary oocyte. Secondary oocyte is released now. Now, this secondary oocyte is now picked up by a finger-like structure. The secondary oocyte is picked up by a finger-like structure called as fimbriae. This fimbriae will pick up the secondary oocyte now. Now, let's say the secondary oocyte is entering inside the fallopian tube. Now, it will reach a cone-shaped structure. Cone-shaped structure called as infundibulum. Infundibulum right here. Now, from infundibulum, the secondary oocyte will travel up. Now, it will reach a much more wider region called as ampulla region here. Now, again, if they ask you question examination, students, which is the region where the entire fertilization takes place? What is the answer, students? What is the answer? If they ask you in examination, the site of fertilization, that answer is ampulla region. If in the old NCERT long back it was ampullary isthmus junction, but in the new NCERT it is going to be ampulla region. It's going to be ampulla region. Now let's say the fertilization takes place here. Then what happens? Then the zygote travels, friend. Zygote travels. What if there is no fertilization? If there is no fertilization, then the secondary oocyte is now reaching a much more narrow region. That is called as isthmus region. So infundibulum, ampulla, isthmus. Now students, now the secondary oocyte is entering a inverted pair. See, this is an inverted pair. Okay, or let me draw it a better way. This is an inverted pair, students. This is a inverted pair. Okay. This right here is a inverted. Why did it change? Why did it change, students? Why did it become a 0? Never mind. This one is the entire inverted pair shape called as uterus. Now uterus is also called as, womb, also called as hysteria. Now what if I remove the uterus, students? In women what happens? Sometimes uterus is removed out. That is called as what? Hysterectomy, students. This is called as entire thing is called as uterus. Uterus fundus is the top part here. Now students, in the uterus, this entire uterus here, it has 3 main layers here. How many, students? 3 main layers right now. Autocorrect. I know, I'm like autocorrect. Uterus is becoming some O here. Okay. Now in this uterus, students, the outermost layer is called as very thin layer called as perimetrium, outermost layer. Second layer is called as myometrium. Now question can be asked here. What is myometrium made up of? What is myometrium made up of, students? Myometrium is made up of what? Smooth muscle cells, smooth muscle tissue. Smooth muscle tissues, the myometrium is made up of. Function, listen to me very carefully. The function of myometrium is that it undergoes contraction. The entire myometrium undergoes contraction during childbirth. Childbirth here. Undergoes contraction during childbirth. Now, what is the innermost layer, students? Innermost layer is called as endometrium. The endometrium is very glandular. The meaning of glandular is that it can become secretory in nature. The entire endometrium can become secretory in nature. That is why it is called as glandular in nature. Glandular. Done, students? Done. Now, all of you need to understand here is that myometrium undergoes contraction during childbirth, but endometrium undergoes cyclic changes every single month in the menstrual cycle. Because of menstrual cycle, it undergoes cyclic changes. That is the entire endometrium. Done, students. The 3 layers done here. Now, the entire uterus is opening into vagina. Uterus is opening into vagina through a cavity or through a narrow region called as cervix here. Cervix here. Uterus is opening into vagina through a small narrow path called as cervix here. The canal of cervix is called as cervical canal here. Cervical canal. The external opening is called as vagina right here. Now, students, the cervical canal plus vagina together give rise to dash. A question to all of you. Cervical canal plus vagina, what do we get? We get the birth canal. This is how the child is born. Birth canal is the opening here through which the child is born, student. Child is born. Yes, removal of uterus. There are multiple cases where the uterus is removed, right? That is called as your birth canal. Student, do you see that? The entire diagram is decoded from top to bottom. Done. All the way from the ovaries with fallopian tube, uterus. I hope all of you remember the points in your mind. Then vagina and the birth canal. Now, question to all of you students: is the vagina external genitalia here? Is the vagina external genitalia? It is not. It is not. The external genitalia in the case of female is called as vulva. It's called as vulva. Okay. Vagina is just an opening here. Vagina is just an opening. How we had a urethral meatus. Urethral meatus is an opening there. Similar to urethral meatus in the case of male, vagina is an opening here. It is not the external genitalia here. Not the external genitalia. Done, students. Done. Inverted canal, cervical canal, vagina birth canal done. 3 layers: perimetrium, myometrium, endometrium. Done, done, done. Now, students, what is the external genitalia here? The external genitalia is called as vulva. It is made up of mons pubis. Is a part of female external genitalia. Okay, part of it, with cushion of fatty tissues covered by skin and pubic hair. That is the outer part, cushion part. Then there is something called as labia minora, labia majora. Labia majora is the flappy tissues present on the outside. Now, inside the labia majora, we have labia minora. Okay, so labia minora are paired foldings of tissues under the labia majora. So, under the labia majora, labia minora are present here. Okay. Now, students, the opening of vagina is often covered by a partial membrane called as hymen. Hymen. Now, here one thing which is very controversial, which everyone talks about, is hymen indicative of sexual experience? It is not, because hymen can even break because of other activities. For example, if a woman undergoes, let's say, horseback riding, sudden fall, kabaddi, coco, things, hymen can break. Even after the first intercourse, hymen can still be present also. So it is not an indicator of sexual experience, hymen. It's a myth. It's a myth. Now, students, at the end of labia minora, the top part of labia minora is called as clitoris. It is called what, students? Clitoris here. So clitoris is a tiny finger-like structure on the top, tiny finger-like structure which lies on the upper junction of two labia minora. Upper junction of two labia minora is the clitoris here, above the urethral opening. Above the urethral opening. So remember, students, in the case of female, there are two openings: urethral openings, vaginal opening. In the case of female, there are two openings: urethral opening as well as vaginal opening. But in the case of male, a single opening in the case of male. That is going to be that is going to be the urethral meatus. Single opening there. Single opening. Now, students. Students, any doubt till now? Any doubt till now, students? How are we going? Going strong? Going weak? All of you? Understanding? Going strong already? Perfect, perfect, students, perfect. Now, in the case of female students, in the case of female, there is something called as mammary glands or the breast here. Mammary glands and the breast are very important for the childbirth or the taking care of the child here. Now, again, students, mammary glands are present in every single female primate, functional ones. Even though all of you know platypus, right? Platypus, that also has a functional, right? Mammary glands. Even in the case of platypus also. Students. Now, if you look at a breast here, right here, diagram, here, the entire mammary gland here, it is made up of something called as, students, it is made up of something called as 15 to 20 mammary lobes. Entire thing is made up of 15 to 20 mammary lobes here. Mammary lobe 1, 2, 3, 4, 5, 6, 7, 8, 9. Can all of you see this? It's called as mammary lobes. Apart from mammary lobes, students, there is a variable amount of fat. Variable amount of fat can be there. So more fat or less fat can be there. But there are around 15 to 20 mammary lobes can be there. Okay, mammary lobes can be there. So 15 to 20 mammary lobes containing cluster of cells called as alveoli. Students, remember students, alveoli is the site of milk production. Milk production in the case of female, and also storage of milk also happens here. The storage also happens here in the cavity of alveoli, okay, and stores in its cavity. Now students, all of you understand now. All of you understand here. Now, mammary glands, okay, in mammary glands, now transport of milk, very important concept. Now from alveoli, the milk transfers to mammary tubules, to mammary ampulla, to lactiferous duct, students. Okay, from lactiferous duct, the milk is coming out. The milk is ejected out. The small thing you should know. Okay, mammary duct. Did I miss anything, students? Mammary tubules, mammary duct. Oh, mammary duct. That's what I was thinking. Something is missing here. Mammary tubules to mammary duct, then mammary ampulla, then lactiferous duct, and the milk is coming out. That is the important thing here. Okay, that's all as the entire flow, students. If you know this, you are good to go. If you know this, you are good to go, students. Okay, I thought something is missing. I was like, something is missing no here. Okay, now students, with that, your entire male and female reproductive organ is done. Actually, it is done. Okay, now students, shall we start with spermatogenesis now? Shall we start? Done, students? Shall we start? No, students, I was just thinking something was missing there. Shall we start now, students? All of you drink some water. All of you drink some water now, students. Shall we start? Now, students, I will teach you the entire spermatogenesis in 5 minutes. Challenge, students. Entire spermatogenesis in 5 minutes. Not even 5 minutes. 2 to 3 minutes. Challenge, all of you. Challenge accepted. Deal. I will teach you the entire spermatogenesis in just 5 minutes. Entire thing in just 5 minutes, and you will learn it and never look back again. Never look back again. Shall we start? All of you. See, students, what everyone thinks is that till here, everyone loves human reproduction. Human reproduction is like, oh, human reproduction. Ma'am is teaching, sir is teaching. First bench will come and sit. Till here, everyone loves. But it is very easy. But from this point onwards, everyone thinks it's very difficult. I don't even know why. But let me tell you, students, from this point onwards, everything is even more easy. Everything is even more easy right now. So shall we start? Challenge accepted. Let's go. Okay. Students, look at the time now. One of you, all of you, look at the time. We will start right now. Okay. First thing first. Spermatogenesis takes place in the case of males, human males here. Males. Spermatogenesis takes place in the case of human males here. First point done. When does it start? It starts at puberty. It starts at puberty, students. Puberty in the case of male. Now, what is the starting location here? So, all of you remember, students, inside the seminiferous tubule, there are two types of cells. One is called a Sertoli cell, other is called as what? Spermatogonia. The same spermatogonia is the starting point here. The same spermatogonia is the starting point here. This spermatogonia, which is going to be diploid in nature, also called as male germ cell, in the starting it undergoes meiosis. In the starting it undergoes meiosis here. Sorry, mitosis. In the starting it goes mitosis. That is why, student, there is no change in ploidy. No change in ploidy here. Okay. Now, if every single time mitosis takes place, one cell will divide into two cells here. Now, one such cell, students, one such cell undergoes growth here. Now, this enlarged cell right here of type of your male germ cell is called as your primary spermatocyte. Now, students, in examination, they will all of you ask you. In examination, they will ask you, students, what is the ploidy of primary spermatocyte? All of you tell me, sir. The ploidy of primary spermatocyte is diploid in nature. Diploid in nature, right here. Diploid in nature. Now, this primary spermatocyte undergoes something called as meiosis 1. All of you know there is meiosis 1, meiosis 2. The first one is happening right here. Meiosis 1. When primary spermatocyte undergoes meiosis 1, it can give rise to two cells. And these two cells are called as what? These two cells are called as secondary spermatocyte. So, from primary spermatocyte, secondary spermatocyte we get. So, two cells here. Two cells. 22 plus X, 22 plus Y. Now, students. Now, after secondary spermatocyte we get, now these cells undergoes meiosis 2. Undergo meiosis 2 now. And at the end of it, this cell right here will give rise to two more cells. This cell will give rise to two more cells. And that's how we obtain 4 haploid cells. Now, students, these 4 haploid cells are called as spermatid here. Now, students, all of you tell me in the chat, do these spermatid look like sperm in any angle? Look at the angle, see. For me, it doesn't look like. It looks like a motetale. This looks like a motetale right now, motetale. Okay. Doesn't look like sperm at any cost. It does not. Now, students, understand here, these spermatid, which are obviously haploid in nature, right? They undergo one more process called as what? Spermiogenesis. It undergoes something called as spermiogenesis. Now, can anyone in the chat tell me which particular cell is helping here? Nernst cell. Nernst cell. Very good. Now, conversion of spermatid into spermatozoa or the sperm. Spermatid into spermatozoa is called as spermiogenesis. Now, finally, they look like sperms. Finally, they look like sperms right now. Finally look like sperms here. Now, are they released as such? They are not. Now, once the sperm is produced, the head of the sperm is embedded in the seminiferous tubule. Understand, students? The head is embedded in the Sertoli cell. Head is embedded in the Sertoli cell right now. Head is embedded in the Sertoli cell. They are not released as such. They are not released. Okay. Now what happens? Now where are they? They are in the Sertoli cell. Sertoli cell is a part of seminiferous tubule. Sertoli cell is inside the seminiferous tubule. Now, release of sperm from the seminiferous tubule. Release of sperm from seminiferous tubule is called as what? Spermiation. It is called as spermiation. So that is the entire spermatogenesis done and dusted. I'll give you exactly 30 seconds to look at the board. Any doubt, ask me. 30 seconds to look at the board, students. Any doubt you can ask me, students. Any doubt you can ask me. Done? Done, students? Any doubt you can ask me, students. Equal, obviously, they're equal. Now, students, I'll give you a small recap. Students. Now, first, spermatogenesis, human male, puberty. Male germ cell called as spermatogonia, right here, undergoes mitosis. we get a cell. This is called as primary spermatocyte here. Primary spermatocyte which is diploid undergoes meiosis 1. 2 cells equal. This is called as secondary spermatocyte now. Now secondary spermatocyte undergoes now meiosis 2. 4 cells spermatid here, spermatid. It undergoes a process now conversion to sperm, that is called as spermiogenesis. Nernst cell is involved here. Now all the sperm's head is embedded in the Sertoli cell. Now from here they are present inside the semifrost tubule. Release of sperm from semifrost tubule is called as spermiation. So all of you should know students, the difference between spermiation, spermatogenesis, spermiogenesis. 3 things. All of you remember? All of you remember, students? Spermiation, spermatogenesis, spermiogenesis. And with that, it's over. With that, it's over, students. With that, it's over. Then students, okay, very good question, Purnima. Purani. Okay. So if they ask you an examination, one question, okay, one primary, okay, one secondary spermatocyte will give how many sperm? What is the answer, students? What is the answer? If they ask you question examination, students, one secondary spermatocyte will give you how many sperm? What is the answer, students? What is the answer? Purani, Rani, I'll call you. Or Poo. Tell me the answer, students. Tell me the answer. This is where they can catch you. Students. The question is, one of them will give you how many sperm? Now you tell me, students, if this part is missing here, this part is missing completely. Okay, this part is missing. The question was, one will give how many sperm? This one secondary spermatocyte will divide into 2 spermatid. So this is missing here. So one secondary spermatocyte will give you 2 spermatid. 2 spermatid will develop into 2 sperm. So what is the answer? What is the answer, students? The answer is going to be, all of you tell me the answer in the chat now. Answer is going to be 2 in the chat right now. Answer is going to be 2. So one secondary spermatocyte will give you 2 sperm. 2 will give you 4. Simple as that, students. Simple as that, students. Done, students. All of you understood? Can we go to the next topic now? Shall we go to the next topic? Okay. Understood, students? Understood. Now, next question is going to be what? Next thing is going to be the sperm structure here. This is the, students, can anyone tell me, is it haploid or diploid? Haploid, diploid, students? It is going to be haploid in nature. All of you know that. Haploid in nature. Done, students? Done. Now, all of you need to understand here, it has 3 main regions: head, middle piece, tail. Head, middle piece, tail, 3 regions present here. Now, in this head, we have a nucleus containing chromosome material is there. Here, haploid in nature. Now, students, okay. Okay. Now, this entire head region here, it is wearing a topi here. It is wearing a cap here. The cap is called as what? Cap is called as acrosome here. Now, this acrosome has a lot of enzymes which are involved in fertilization or attachment of sperm into the egg or entry of sperm into the egg. All the enzymes are present here. Now, middle piece has a lot of enzymes. Middle piece has a lot of mitochondria which provides ATP. Tail helps in movement. Here. Now, all of you should know, students, what is the main hormone involved in spermatogenesis or entire reaction? That is going to be from hypothalamus. There is the release of GnRH. GnRH will work on anterior pituitary. From anterior pituitary, we get FSH, LH here. FSH, S works on Sertoli cell. LH works on Leydig cell. How to remember? L for Leydig, S for Sertoli. But what is the actual thing? The actual thing is follicular stimulating hormone, luteinizing hormone. But for convenience, you can remember such way. Okay. Now, students, This Sertoli cell will help in spermiogenesis. Lady cell will produce androgen. Both are involved in spermatogenesis. Both are involved in spermatogenesis. Done. Now, students, shall we start now? Shall we start? Students, my comment is not commenting, not appearing. Students, I can't see the comments. Sometimes my comments are not appearing. Okay, it happens sometimes. It happens sometimes, students. Sometimes things don't appear. It's fine. But you're commenting. I know all of you are commenting. Students, shall we start now? Shall we start? Oogenesis, all of you. Is the energy going down? Shall we start? 11:30. Students, it's just 11:30. Huh? Life is only not lifing. What to do, students? Sometimes things don't go right in life. What to do? Huh? You can't really, nothing will work sometimes in life. You have to adjust and go. Okay. Shall we start, students? Okay. Okay. Now, students, we will take our time for this, because if I rush this topic, brain, it will never go inside. I mean, the topic will never go inside. Brain will be there for you. Okay. I don't mean brain is going to be removed. Brain is going to be there with you, but this topic might not enter your head if I go it a little fast. So I'll go in a moderate pace. Try to follow with me every single point. Okay, students, shall we start? Students, shall we start? Shall we start, students? Shall we start? Okay. Let's take a deep breath, students. Let's take a deep breath. Let me drink some water before starting, because this topic, okay, if you understand this topic, chapter is over. If you understand this topic, right, technically chapter is over. After this, every topic is very easy. After this, every topic is very easy, students. Okay. If you understand this one, right, remaining chapter is going to be very, very easy. It's very easy after this. Very easy. Okay. Students, I want someone to save me only. Okay. Shall we start? Now, 3, 2, students, again, ultra focus time. Maximum effort right now. Ultra focus right now. Okay. 3, 2, 1. Let's go. Oogenesis, students. Oogenesis. Oogenesis starts at what stage? Oogenesis starts at the embryonic stage. Point number 1. Everyone should know. When the female child is at the embryo stage, before even the development of any single thing, right, any single organ also, embryogenesis, oogenesis starts at that time only. Oogenesis starts at the embryonic stage. Okay. Initially, what do we have? Initially, there is something called as oogonia. Oogonia. Oogonia is the first cell here, which is diploid in nature. Diploid in nature. Now, students, this germ cell here starts to undergo mitosis. No change in ploidy, no change in ploidy. It undergoes mitosis. We get 2 cells here, 2 cells here. Now, students, one such cell will grow and differentiate. One such cell will grow and differentiate, and that enlarged cell is called as primary oocyte right here. Primary oocyte. Now, this primary oocyte will now start to undergo meiosis 1, but gets stopped or arrested suspended at prophase 1 diploiding stage. I'll repeat again. It will start to undergo meiosis 1. It is just starting, but it will stop. It will get arrested, not because of police and all, because it is getting arrested. Okay, it is just suspended at prophase 1 at diploiding stage. Don't ask me who's arresting and all. Don't ask me. Okay. Now, all of this is happening at the embryonic stage. Now, what happens? Now the child is born. The child is undergoing childhood, going to school, first standard, second standard, third standard, fourth standard, fifth standard, sixth, seventh, eighth. Okay. Now, what happens, students? When the female child reaches puberty, that is when the first period takes place. When the first time the menstrual cycle starts, the first time ever. In that age, what happens? The meiosis 1 is finally completed. The meiosis 1 is finally completed, and that is result of that is secondary oocyte. So from primary oocyte, after meiosis 1, we get secondary oocyte. Along with secondary oocyte, we get a small tiny some structure called as first polar body. Now students, this entire thing is happening where? Is it happening inside the ovary? Is it happening inside the fallopian tube? It is taking place inside the ovary. Taking place inside the ovary. Now students, again remember at this point students, this secondary oocyte is the same secondary oocyte. The same secondary oocyte which is released during ovulation. During ovulation, every single month in the case of female, the secondary oocyte is released every single month. Secondary oocyte, not ovum. Ovum is wrong. You cannot write ovum here. Secondary oocyte now. Now students, this secondary oocyte now starts. It is starting again. It starts to undergo meiosis 2. It is starting here again. Starting. Now students, but again it gets suspended at metaphase 2. Suspended now. Suspended or arrested. Okay. Suspended right now students. Suspended. Now you understand all of you. Understand now. Understand here. Now what happens students? Here we have secondary oocyte now. Secondary oocyte is suspended. Nicely chilling. Okay, nicely chilling in where? It is nicely chilling in the ampulla region. In the ampulla region. Okay, ampulla region it is chilling right now. Now in the ampulla region what happens? In the ampulla region the sperm is entering now. Because ampulla region is the region where the fertilization takes place. All of you know that, right? So what happens when the sperm comes in contact with the secondary oocyte? Initial contact before fertilization. Before fertilization, when the sperm comes in contact with the egg, the second meiosis is finally completed. Finally completed, students. It is finally completed, and that will result in ovum or ooted and the second polar body. Now a question to all of you. This ovum or ooted and the second polar body are produced in which of the following part? Ovary, isthmus, ampulla, or infundibulum? Answer is supposed to be ampulla region of oviduct. Ampulla region of oviduct, we get the second polar body and the ovum or ooted. Now this entire thing, students, this entire thing is called as oogenesis. Starting from the oogonia, mitosis, second primary oocyte, meiosis 1, suspended, getting over at puberty, secondary oocyte, first polar body inside the ovary, secondary oocyte and starts to undergo meiosis 2, suspended at metaphase 2. During fertilization, meiosis 2 is finally completed. We get the ovum or ooted. That is the entire oogenesis. But when this oogenesis is happening simultaneously, there is also follicular-genesis. That is, development of follicle happens simultaneously. For example, I'll give you a small perspective. Let's take this is an ovary here. Students, I need a waste paper here. Let me just take a small waste paper, students. Oh my god, I just realized these are your old notes which I made for your classes. Wow. Okay, never mind, students, never mind. Let me use your old notes. Okay, students. Let's take here. Okay, this is a oocyte. This is a oocyte. Here we wrote right everywhere. Oocyte here. Secondary oocyte, primary oocyte, everything. All of you understood? Okay. The sperm is coming in contact with the secondary oocyte at the time of fertilization. When the sperm is traveling on top, that is when it happens. Now let's take, students, this is a oocyte right now. Oocyte. This oocyte right here has a extra covering on top. Okay, all of you see, students, this oocyte right now has a extra covering on top. Okay. Now this structure right here is called as a follicle. This entire structure is called as what? Follicle here. Follicle. Inside one follicle, inside the follicle, what do we have? Inside the follicle, if you open, ta-da, there is a oocyte. So entire thing is called as what, students? Entire thing is called as what? Entire thing is called as follicle. Inside the follicle, what do we have? Inside the follicle, there is oocyte. There is oocyte. Now, understand the concept here. We have something called as primary follicle. There is something called as primary follicle. Primary follicle has what? Primary oocyte plus layer of granulosa layer is there. Now, what is present in secondary follicle? Secondary follicle has something called as primary oocyte, more layer of granulosa cells. Now in the secondary follicle, there is a theca formation also happens here. Now, then there is something called tertiary follicle. Now, what exactly happens in the tertiary follicle, students? In tertiary follicle, the entire thing, students, in tertiary follicle, what happens is primary oocyte is converted to secondary oocyte. Primary oocyte is converted to secondary oocyte. So, students, understand here. Here we have secondary oocyte. Here we have secondary oocyte. It means, students, what do we have actually here? This is the secondary oocyte is present here. Secondary oocyte is present here right now. Before ovulation, students, we have the tertiary follicle here. We have the tertiary follicle. So before ovulation, before this point right here, before we get the secondary oocyte, right, we have the tertiary follicle. We have the tertiary follicle. So in the tertiary follicle, we have secondary oocyte here. Secondary oocyte. Okay. Now, all of you need to remember, students, in tertiary follicle, we have something called as theca externa, theca interna, theca externa, theca interna, and also there is something called as fluid-filled cavity called as antrum is also present here. Antrum is present here. Okay. Now, students, this tertiary follicle now becomes Graafian follicle. Now, this Graafian follicle, students, this is the follicle which ruptures during the ovulation. So, after tertiary follicle, we have Graafian follicle. Now, can anyone tell me in the chat? Can anyone tell me in the chat? Right? Anyone tell me in the chat right now? This Graafian follicle has which oocyte? Primary or secondary? It has secondary oocyte, because here we already have secondary oocyte after meiosis 1. After meiosis 1, we have secondary oocyte right here. Okay, the same secondary oocyte is present inside Graafian follicle, which ruptures and secondary oocyte is released. Can you see? Secondary oocyte is released here. And this Graafian follicle has a layer around it called as what? It has a layer around it called as zona pellucida layer. Okay. No, not secondary oocyte, students. Yes, secondary oocyte can have it. Secondary oocyte is present where? In tertiary follicle. So tertiary follicle has what? Tertiary follicle obviously has antrum. It has antrum. Okay. Done, students? Done? That's all. That's all is the concept of your follicle development. Here they can ask you multiple questions. Here they can ask you, students, after meiosis 1, which follicle do we have? Can anyone tell me in the chat? After meiosis 1, when the meiosis 1 is completed, which follicle do we have technically? We have the tertiary follicle after meiosis 1. After meiosis 1, we have a tertiary follicle. Okay, tertiary follicle. Or they can ask you, where do we get secondary oocyte first time? Secondary oocyte is first time found in tertiary follicle. Or they can ask you, students, students, fluid-filled cavity, where do you get? Fluid-filled cavity is found where? Tertiary follicle. Okay. Now, what gets ruptured during ovulation? Graafian follicle gets ruptured during ovulation. Now, once Graafian follicle is ruptured during ovulation, right, secondary oocyte is released. What happens to remaining part? Remaining part is converted to corpus luteum. Remaining part is converted to corpus luteum. That's all. Students, tell me easy or not? Students, tell me easy or not? Tell me in the chat right now. Easy or not? All of you. Yeah. All magic happens in tertiary follicle. All magic happens in tertiary follicle here. Okay. Now see here, students. The process of female gamete called oogenesis. Oogonia starts division and get temporarily arrested at prophase 1 stage of meiotic division and are called as primary oocyte. At puberty, during puberty, students, 60 to 80,000 primary follicles are left behind in each ovary for human female. 60 to 80 are left at puberty. This number cannot increase. The number of primary follicles is fixed at puberty. If all the follicles are over, female reaches menopause. Okay. All of you just know this. All of you know this. Tertiary follicle fluid cavity done. Secondary oocyte forms a new membrane called as ZP. Oh, secondary oocyte forms a new layer called as ZP. Okay. Surrounding it. I told by mistake, I told students. I think a mistake I told you. Graafian follicle. See, this secondary oocyte has ZP. Secondary oocyte has ZP. Okay. Secondary oocyte is ZP layer. And release is called as ovulation. Students, done? Done, all of you? Students, done? See here also. Here we have the tertiary follicle, antrum, secondary oocyte. Ruptures, secondary oocyte is released, and remaining part gets converted to corpus luteum. Corpus luteum later on. Primary oocyte, zonal pellucid layer. It doesn't have actually. Development happens here. Students, if that is clear, can we start right now, students? Shall we start? Sir, meiosis 2 is finished until no. Aditi, understand. The second when the sperm is there, right? When the sperm comes in contact with the egg, that is when meiosis 2 is getting over. That is when meiosis 2 is getting over, students. Okay. Done, students? Done? It will not finish. Meiosis 2 will get over during fertilization, when the fertilization starts, before fertilization finishes. Okay. Shall we start? Next concept. Students, again I'm telling you, these chapters are very big chapters. Ecology is very easy. Shall we start? All of you. Now again, students, function of polar body is not known. Function of polar body is not known actually, right? If there is any research, new research, I will read and tell you. Okay. Students, shall we start with next concept called as your menstrual cycle? Again, students, I will not give you any notes for it. All you need to do is listen to me. For the next 10 minutes. Just listen to what I say. Every single doubt will be clear. Shall we start? Students, shall we start right now? Just listen to what I say and your doubt will be cleared. Just follow through what I'm saying right now. Just follow through what I'm saying here. Everything is going to be very easy. Okay. Just follow through. Let's go. All of you students, can I get some fire emoji in the chat? Let's go. Okay. 3, 2, 1. Let's go, students. Now, the entire process of menstrual cycle happens in the case of female primates. In the case of non-primates, estrous cycle. Female primates, menstrual cycle. Okay, menstrual cycle takes place. Now, students, when does it happen? Menstrual cycle takes place. It takes place because if there is no fertilization, there will be menstrual cycle. So it takes place. Okay, so menstrual cycle happens every single month. This bleeding stage happens. If there is no fertilization. The bleeding stage happens now. Now, what exactly happens here? Understand here. In the case of menstrual cycle, there are two events happening. Two events are happening simultaneously. One event is happening in the uterus. One event is happening in the ovary. So, can all of you see, students? Can all of you see here, students? Here we write ovarian events right now. Ovarian event written, done. Here it is uterine event. So, uterine event in the uterus, ovarian event in the ovaries here. Done. Both of these events are influencing each other. Especially the ovarian event influences the uterine event. Influences them. And these are happening simultaneously, means together it's happening. Now, at the same time, there are two types of hormones involved here. One is called as pituitary hormones. Other one is called as ovarian hormones. So, ovarian hormones as well as pituitary hormones. Then, two types of hormones. Okay. Now, here I've written ovarian events, uterus events. Okay. Now, first what happens, understand. Can anyone tell me in the chat right now, which hormone, which line is on the top right now? Is the red line on top or blue line on top? Red or blue? Tell me in the chat. Is the red line on the top or blue line on the top? You will tell me, sir, if you look at the diagram right now, you will tell me, sir, FSH is higher right now. Follicular stimulating hormone is higher right now. It's higher. Now, if follicle stimulating hormone is higher, what will it do? Follicular stimulating hormone. It will do what? Development of follicle. It will stimulate the development of follicle. So it is stimulating the development of follicle, and finally we have the mature follicle. Finally, we have the mature follicle. Now, students, understand very carefully. Once where there is a dominant follicle, once we receive a dominant follicle for the month of April, dominant follicle is done. Do the females need one more follicle, extra follicle backup? Not required. Not required, students. One follicle per month is more than enough. So what happens is that this follicle here, especially the granulosa layer here, sends a feedback mechanism along with inhibin, right? Along with inhibin, what happens? Inhibin, what happens? Along with inhibin, what happens? There's a negative feedback mechanism. And students, can all of you see, students, the red line is coming down now? The red line is coming down. The red line is coming down. Can all of you see? The red line is coming down. It means that we do not need more FSH. FSH work is over here. It's over. Okay. So then we have development of follicle is happening here because of FSH here. That is why it's called as what? That is why this stage in the uterus, in the ovary, is called as follicular phase. Why? Because development of follicle is happening. Follicular phase is done here. Now, at the same time, what happens is this developing follicle will increase the levels of estrogen. Can all of you see the estrogen level is up here? It is up here. Estrogen level is up here. So in this stage, what happens? In this stage, because of estrogen, because of increase in levels of estrogen, it will induce a change in the endometrium layer. What happens? The endometrium layer piles up. That is, thickening of endometrium layer happen. And this stage is called as what? This stage is called as proliferatory phase in the uterus. Why? Because there is proliferation of endometrium. The meaning of proliferation is what? The meaning of proliferation is that development, increase is happening. So during the first phase right here, follicular phase, development of follicle, increase in FSH, then increase in estrogen because of this, and there is development of endometrium layer. Now what happens, students? Now what happens? Now at the 14th day, there is something called as LH surge, increase in LH, increase in FSH, and at the same time, increase in estrogen also happens. Estrogen is also at a peak here. It is at a peak here. Now, at this stage, what happens? Ovulation takes place. The Graafian follicle ruptures open. Secondary oocyte is released. Secondary oocyte is released right here. Released here. Students, till here any doubt? Till here any doubt, students? Till here any doubt? Till here any doubt till now? Any one of you? Till here any doubt at this point? I believe there is no doubt until here. First point done. Follicular phase here. Proliferatory phase bottom. Endometrium is ready. Endometrium is thick right now. Now what happens, students? Now what happens? Now all of you can clearly see that in second phase what happens? LH is obviously high here. LH is obviously high right now. High. Now this increase in LH will maintain the corpus luteum. It will maintain the corpus luteum. Corpus luteum is the remaining part of Graafian follicle. This remaining part of Graafian follicle is called as corpus luteum. Now this corpus luteum right here, students, it will produce what? It will produce red line. What is the red line? Progesterone. So corpus luteum is producing the progesterone. Now, what is progesterone doing? Progesterone is actually maintaining the endometrium layer. It is maintaining the endometrium layer. First, what happened? Formation happened because of estrogen. Now, endometrium is maintained because of progesterone. So this stage is called as what? This stage is called as luteal stage. Why? Because increase in luteinizing hormone here. This stage is called as what? Secretory phase, because the entire endometrium layer is glandular. It is secretory in nature. It is going to be what? Secretory in nature. Okay, secretory in nature, students. Secretory in nature. So entire endometrium is secretory in nature here. Now, students, till here the entire endometrium layer is ready for implantation. Endometrium is thick for implantation. That is, if fertilization takes place, if the secondary oocyte as well as the sperm undergoes fusion, the egg and the, not secondary oocyte, the egg and ovum and the sperm undergoes fertilization, the zygote is produced. Zygote undergoes cleavage, zygote, then we get the blastocyst, then implantation happens. That is ready now, it is ready. But, what is the but here? The but here is that, what if there is no fertilization? Then what will happen, students? If there is no fertilization, then what happens? Then what is happening, students? Let's see here. LH level drops. What happens? LH level is dropping here. Dropping. Can you see? Blue line is coming down. Blue line is coming down here. LH level is dropping. Now, if LH is dropping, students, who will maintain the corpus luteum? No one. No one will maintain the corpus luteum, students. Okay. No one will maintain the corpus luteum. So, can you see? Regression of corpus luteum. Corpus luteum becomes corpus albicans and gone. So, it is gone here. So, if corpus luteum is not there, no one is producing progesterone. So, can you see? Progesterone level is going down here. If progesterone level is going down, who will maintain the endometrium? No one. And that's how entire endometrium collapses here. Entire endometrium starts to collapse here. So, entire endometrium gets collapsed. Blood, all the blood vessels collapse. The unfertilized secondary oocyte collapses. Not the egg, not the ovum. Secondary oocyte also comes out. And that is called as menstrual cycle. And students, the starting of menstrual cycle is called as menarche. It happens in the case of female in the puberty. Stopping is called as menopause. And there we go, students. There we go. That's all. Removal of egg, not egg, students. Saura, remember, it is removal of secondary oocyte. Be very clear. Be very clear. It is removal of secondary oocyte. This same secondary oocyte. No fertilization, coming down. Done, students? Done? Done, all of you? That is the end of it. That is the end of entire menstrual cycle, students. Done. Primary follicle, students. Aditi, primary follicle. Done, students. Entire, what do I say? Concept is decoded on the board. So I'll just give you a small recap. What happens first? Increase in FSH, follicle development happens, follicular phase. Because of which estrogen is increased, development of endometrium, proliferation phase. Here, first part. Ovulation, LH surge, 14th day, second oocyte is out. Then what happens? Increase in LH, luteinizing phase, luteal phase. Follicle, corpus luteum, progesterone, maintaining endometrium, secondary phase. No fertilization, decrease in LH, degradation of your corpus luteum, decrease in progesterone, endometrium is breaking apart. That's all. That's all, students. Okay. Done, students. Done, students. Done. LH surge, graphene follicle, corpus luteum secretes large amount of progesterone. Done, students. Everything is done. Menopause. Done, students. Fertilization takes place where in the ampler region? Done here. Okay. Students, this I will not be explaining right now, students. Just remember, when this is not given you NCERT also. This is extra information on the board. When the sperm comes in contact with the egg, it is not a very easy thing. Because when the sperm is coming in contact with the egg, multiple reaction can take place. That is called as your cortical reaction. Before even the sperm comes in contact with the egg, the sperm has to undergo activation. That is called as capacitation. The sperm gets activated, right? Sperm gets activated, it's called capacitation. Okay. Then there's something called as acrosomal reaction. Okay. There are multiple things happening. Let's say we have hyaluronase enzyme produced that will break the granulosa cells here. Then there is something called CPE, coronal penetrating enzyme, that will completely degrade the coronal radiata layer here. Then there is zona lysine or acrosin, which will completely break the zona pellucida layer. So do you realize all of these enzymes are present in the acrosome? They are completely degrading the layers, multiple layers of the secondary oocyte, one by one. Now, when the sperm is coming in contact with the egg, the sperm has something called as fertilization. Sperm has something called, sperm has something called anti-fertilization. Sperm has anti-fertilization. Ovum has fertilization. They will match here, like a matching will happen, and then when matching happens, sodium channels open, and the entire membrane here, undergoes depolarization. When the entire membrane undergoes depolarization, no more sperm can enter inside. So as soon as the first sperm enters, entire membrane undergoes depolarization, no more sperm can enter inside. Okay, that is the meaning of membrane depolarization. Now students, now now the sperm and the egg are fused. What do we get, students? What do we get? We get the zygote here. Now can anyone tell me, students, what is the ploidy of zygote? Anyone in the chat who can tell me what is the ploidy of zygote? Students, you will tell me, sir. Students, the ploidy of zygote is nothing but diploid in nature. Diploid in nature, students. Here, right here. Here we have the zygote here. Zygote now. Now this zygote undergoes now mitosis. Mitosis. So 1 cell to 2 cell, 2 cell to 4, 4 to 8, 8 to 16, 16 to 32. So it goes on dividing. It goes on dividing here. Now students, remember this 8 cell to 16 cell stage. This stage right here is called as morula also. Morula. Then finally we get the blastocyst here. Now I want all of you to remember is that, students, here each cell inside the morula or blastocyst, right? Each cell is called as what? Blastomere. It's called as what? Blastomere, students. It's called as what? Blastomere. Each cell here is called as blastomere here. Blastomere. So here we have 8 cells, that is called as 8 blastomeres, 16 blastomeres, multiple blastomere in the end of blastocyst here. Okay, students, understand here. See, multiple blastomeres are present here. Now, students, what happens is in the blastocyst, the arrangement of blastomeres vary. Most of the blastomeres are present on the outer side, not most. Some of them are present on the outside. Arrangement of blastomeres on the outside, this region is called as what? Trophoblast. Remaining blastomeres are arranged in one corner. This part is called as what? Inner cell mass. Inner cell mass. So inner cell mass here, trophoblast on the outside. Trophoblast on the outside, students. This is called as a blastocyst. It is called as a blastocyst here. Blastocyst. Now, students, this blastocyst can undergo implantation now. This blastocyst now can undergo implantation. Okay. See here, students. This is how. See this. This is the blastocyst here. It undergoes implantation on the endometrium layer. This is the endometrium layer. The blastocyst undergoes attachment here. Undergoes implantation. Now, when the implantation takes place, what happens here? The entire uterine tissue undergoes rapid multiplication. This is the blastocyst uterine tissue. It is undergoing implantation. It will completely engulf inside. Okay, completely engulf inside, students. That is called as implantation. Students. Now what happens? Students, understand here. Now, students, on top of this trophoblast, students, there are small structures here. They are called as what? Chorionic villi. They are called as what, students? Chorionic villi here. Chorionic villi on trophoblast cells. Now, students, this chorionic villi, remember very well, chorionic villi plus maternal blood and plus uterine tissue, student, this is not able, right? Okay, uterine tissue, chorionic villi, maternal blood, uterine tissue, all three together, when they join together, or they become interdigitated, everything joins together, that will result in the placenta. That will result in the placenta, students. That will result in the placenta here. You can see here, students. Implantation is the process of the blastocyst gets embedded in the endometrium layer. After implantation, finger-like projection appear after implantation. Finger-like projection appear on the trophoblast called as chorionic villi, which are surrounded by uterine tissue and maternal blood. So maternal blood plus uterine tissue and chorionic villi, when they together join together, placenta. Placenta does what, students? Supply of oxygen, nutrients, and removal of CO2. Because obviously, the baby inside, growing baby inside, needs oxygen, removal of CO2, entering of food, removal of waste. All that is happening because of placenta. Now, students, understand here. All of you need to understand here is that this placenta here will start to act like a temporary endocrine gland. Temporary endocrine gland. It means that placenta can now start to produce hormones. Hormones here. Now, which are the hormones produced here? The hormones produced here are HCG, HPL, estrogen, and progesterone. And especially, students, especially here, HCG, HPL, and relaxin. These three hormones are produced only during pregnancy. Only during pregnancy. If they ask you question examination, which hormones are produced only during pregnancy? These are the hormones. And because of this hormonal changes, the females during pregnancy have something called as morning sickness. You might have heard the morning sickness because of this. Because at this time, the female body undergoes a lot of changes because of the hormonal changes. Okay, a lot of changes happens. Okay, now students, that is the placenta story. Now what happens after implantation, students? So in later phase of pregnancy, hormone called as relaxin is also produced by ovary also, remember. Also produced by placenta and ovary also. Now after implantation, the inner cell mass differentiates. Can you see here? After implantation, the inner cell mass is differentiating. Okay, it can give something called as endo layer, endoderm, mesoderm, ectoderm. Three different layers here. Now you will learn more about it. You will learn more about it in the tissue chapter, right? You can just see a small thing here that mesoderm can give you circulatory system, lungs, skeletal system, muscular tissue. Ectoderm can give what? Hair, nails, skin, nerve tissue. So different things can be produced by different layers here. Now students, now what happens? Now students, this is very important. This is very important right here. Here. This is very important here. Now listen to me, students, all of you, listen to me one by one now. Okay. What is important here? See here. 9 months is the pregnancy. 9 months is the pregnancy right here. Okay. Now what happens? After 1 month, what is happening? After 1 month of pregnancy, what is happening? After 1 month of pregnancy, students, what is happening? Heart is formed. So after 1 month of pregnancy, heartbeat is audible. Okay. All of you know that doctors will keep the stethoscope and hear the heartbeat 1 month. After 1 month of pregnancy. Now students, the embryo, now the first stage of growing fetus, the first sign of growing fetus may be noticed by listening to the heart sound carefully. Stethoscope. Now by the end of second month or 8 weeks, okay, second month, what happens? Fetus develops limbs and digits. Limbs and digits are after second month. By the end of 12 weeks, that is the first trimester now. 12 weeks, first trimester, what happens? What happens is most of the major organ systems are formed here. 12 weeks. Example, limbs and external genitalia of the organs are formed here. This is happening after 12 weeks, first trimester. Now, people say, right, the baby is kicking. They say that, right, baby is kicking right now, kicking football inside, football player. That happens in the 5th month. Okay, the first movement of the fetus and appearance of hair on head observed during the 5th month. Now students, next thing here. Okay, now about your 24 weeks, end of second trimester. What happens? Body is covered with fine hair and eyelid separation. By the end of 9 months, the baby is born. 9 months baby is born, students. So I want everyone to make a table here. So you can tell 1 month heart, 2nd month of pregnancy limbs and digits, 12 weeks organs are found, first movement 5th months, 24 weeks covered with fine hair, eyelid separation. So everyone should know every single point given here one by one, students. All of you will remember? All of you will remember, students? Tell me yes or no. All of you will remember, students? Yes or no, students? BTech friends, NCERT is not giving you. NCERT does not tell. It says, students, see this. This is the confusion which many students have. What does it say? This is your NCERT line also. This is the NCERT line also. In later phase of pregnancy, a hormone called relaxin is also, students, relaxin is also secreted by the ovary. All of you, I want you to read the NCERT line here. This is not given here. In NCERT, it says that a hormone called as relaxin is also secreted by ovary. What is the meaning of also? It means some other organ is also producing, some other structure also producing. That is the placenta. So placenta also produces relaxin. Please remember that. Just because it is not given NCERT, it doesn't mean it is not there. Clear, all of you? Clear? If you do a small Google search, you can find. No. Now, students, last topic is called as parturition. What is parturition, students? Parturition is called as what? Childbirth. Childbirth is happening. Okay. Now, students, here what they can ask you the question here. The question they can ask you here, students, it's a neuroendocrine mechanism. Okay. Now, where is the first signal coming from? Who is telling students, I am ready to come out now? Please, childbirth should happen right now only. I cannot take it anymore. Who is telling that? The child is telling that, student. The child and the placenta. The first signal for parturition. The first signal for parturition comes from the placenta and fully developed fetus. Placenta and the fetus is sending a signal here. I want to come out. I can't take it anymore. Okay. Now, parturition comes from the fully developed fetus and the placenta, which induces a mild uterine contraction that is called as fetal ejection reflex here. Called as fetal ejection reflex now. So because of the signal, there is a small contraction of the uterus. Fetal ejection reflex is called as. Okay. Mild uterine contraction called as fetal ejection reflex now. Now, students, as soon as the signal is produced, as soon as the fetal ejection reflex, what happens? From the maternal pituitary, there's a hormone is released. That is called as oxytocin is released here. Oxytocin is released now. Okay. Now what happens, students? Because of the oxytocin hormone, once it is released, more contraction happens. More contraction, more oxytocin, more contraction. So it goes on a cycle. What happens? More contraction, more oxytocin, more contraction, and it keeps on happening until there is enough of contraction for the child to slip out. Okay. So stronger contraction here. Now during this stage, students, which muscle of uterus is very undergoing contraction? Myometrium. So and then baby is coming out. That is called as parturition. Now, students, during the starting stage of your entire childbirth, after childbirth, right, milk is produced in the female, right, and the milk produced in the starting stage is called as what? Colostrum. It is called as colostrum, and it is rich in a lot of antibiotics. Doctors usually tell the mother to feed the baby because only breast milk, because it has a lot of antibiotics, because child needs protection, right? IgA, IgG, right? So child needs protection, and that's where we get from. Because when a child is coming to the world, it is seeing so many things. It is sensitive to a lot of diseases right now. So mother's milk is the best that time. Mother's milk is the best that time, students. Okay, and that is the end of chapter. That is the end of chapter, students. Done, students? Done? Done, students? Yes. I think we took 1.5 hours, which should have, what, 2 hours? What time did we start? 10:30, right? 10:30 to 11:30, 11:30 to 12:30. Oh, students, we took 2.5 hours. We started at what time, students? 10:30, right? 10:30 to 11:30, 11. Okay, 1.5 hour. Not good. It's good. It's good. It's good, students. 1.5 hour. Very easy. So at the end of chapter. Done, students. Done. 1 hour 30 students is a very good number. 1 hour 30 minutes is very good actually. 1 hour 30 minutes is a very good for human reproduction, because human reproduction generally takes 3 hours. Generally takes 3 hours. So 1.5 hours is a big achievement actually. Okay, students. Okay. Now, can we start POI? We will take a 5 minutes break and we'll start POI. 5 minutes break. All of you can chill right now. Ask me some questions. I will clear the doubts right now. 5 minutes we'll do doubt clearing session. Then we will start. Okay. Let me eat something in the background. Snacks break. 5 minutes snacks break, students. 5 minutes snacks break. Students, ask your doubts. Sir, plant physiology coming week. Students, pedigree, students. Purni, I'll give you pedigree of I'll give you today what you need to do for pedigree. I'll give you all the information required for pedigree questions. If you have that hacks, you're good to go. Okay. Oh, looks very nice. Friends, ready all of you? Ready? Shall we start? Shall we start all of you? POI. First polar body and second polar body, students. First polar body and second polar body doesn't have any main function. Doesn't have any main function, students. Students, any doubt? Reproductive health I won't be doing. Reproductive health go become thing. Students, Surya, remember bryophytes are in the water body itself. Bryophytes are produced near the water body. In the case of bryophytes, they need water for only one thing. They need water for fertilization. Remaining other process and all, it can take from the ground directly because it has root-like structures, and more of it is growing in the water itself, near the water body. So bryophytes don't have to worry so much. Okay. What is the question? Next question, students. Sir, why hibiscus doesn't? Hibiscus has seeds. Hibiscus has seeds. It has a fruit also. The fruit is called as a pod. The fruit is called as a pod. Dark chocolate is. It's not a dark. It's a protein bar. Another class on PYQ, students. No. PYQ session we did already. Students, quickly ask me. Doubts quickly ask, students. No one waits this much for doubts. No one usually in YouTube they don't ask doubts, students. But I'm asking you because I care for all of you, right? So students, you have never seen a hibiscus pod. It is a brown color structure where we can get a lot of brown seeds. Social. What is the social hormone, students? Oxytocin. See, what happens is that in the case of parturition, right? If the body is not producing enough of oxytocin, oxytocin is induced artificially by doctor also. Remember that much. Okay, remember that much, students. It's a protein bar, not proportion bar. No doubt. Shall we start, students? Students, all of you sleepy? By any chance, all of you sleepy? By any chance, all of you sleepy? Because I'm not. Okay. Students, let's try to finish this entire chapter in 1 hour. Okay. My dog is sleeping already, students. My dog is sleeping already. Harry Potter. Huh? Okay. Students, 3, 2, go. Let's go. POI. Okay. Now, students, first thing first, you need to know certain terminologies. All of you should know, students, the entire genetic information in the case of humans or animals or organisms is stored where? The entire genetic information is stored in a structure called as DNA. So, entire genetic information is stored in the DNA, students. DNA. Now, students, when a DNA undergoes compaction, what do we get, students? When a long piece of DNA undergoes compaction, we get a nucleosome. All of you know what is a nucleosome, students? All of you know what is a nucleosome? Yes? Students, all of you know what is a nucleosome? All of you know what is a nucleosome. Nucleosome is nothing but it has histone proteins and the DNA around it. Now, when this nucleosome undergoes further condensation, we get a long thread-like structure. The long thread-like structure called as chromatin. That a chromatin is a small thread-like structure which has a DNA, proteins, histone proteins and non-histone proteins are present in the chromatin. Now, students, when this chromatin fiber, when this long thread called as chromatin fiber, it undergoes further condensation, it can give rise to chromosomes. So, chromatin undergoes condensation, we can get a chromosome. Now, students, on this chromosome, we can have genes. On these chromosomes, we can find genes are present on the chromosome. Now, what is a gene technically? Gene is the smallest segment of DNA. Smallest segment of a DNA is called as a gene. You can see right here. Let's say this is a DNA here. A small segment is called as a gene here. Gene is the smallest segment of DNA. Now, students, this gene right here, it has a twin brother. What do you call that, students? What is the twin brother of a gene called as? Anyone, students? The twin brother of a gene is called as what? Anyone? That is called as what, students? Allele. So, allele is nothing but alternative form of a gene. Alternative form of a gene is called as a allele here. Now, let's say this is one chromosome. This is a homologous chromosome. Let's say I have one gene here, one allele here. Its alternative form will be present on the another homologous chromosome. Here we can see a flower color, eye color. It won't be like this because this is present in your plants, present in the case of your animals here, in the humans here. But remember, genes are present on a chromosome. It has an alternative form that is called as an allele here. That is, alleles are present on the same loci and same for the same character or homologous chromosome. Okay, allele here. Twin brother done. Now, what is the difference between a character and a trait? Difference between a character and a trait. Understand, students. Understand. Here, let's say a flower color, eye color, plant height. All of these are called as what? All of these are called as character. Then if one character has multiple different types of alternative forms, that is called as a trait here. Let's, for example, a flower color can be red, white, pink, traits. Eye color can be red, brown, green. Students, what is your eye color in the chat? My eye color is little brown color, and little brown color my eyes are. Okay, so red, brown, green. These are called as traits. Plant height, tall or dwarf, that is going to be plant height. So plant height is going to be character, tall and dwarf is going to be a trait. So trait are the variations of a character. Traits are what? Variation of a character, students. Okay, that is a trait. Now, next thing, students, phenotype is the morphological out the plant from the outside. Genotype is the genetic makeup. Genotype is genetic makeup. There is something called as homozygous, heterozygous. Homozygous means what? The two alleles are looking the same. Who is Ramesh? Who is Suresh? I can't tell. One is Ramesh, one is Suresh. We can't tell who is Ramesh and Suresh. That is called as homozygous condition. Twins which look alike. What is heterozygous condition? Twins which don't look alike, look different. They look different, students. That is called as your heterozygous condition. Heterozygous students. Then, in this heterozygous condition, one is dominant, one is recessive always. Dominant, recessive. Like in the class we have no first benchers, last bencher. First bencher are very quiet, nice little study. Last bencher are little cuckoo in the head, because last bencher will always keep on making noise. But students, tell me in the chat right now, if you're a first bench or last bench in the chat. So here also, your capital T is dominant, small t is recessive always. So this is called as a dominant allele, recessive allele. Dominant, recessive allele. Done, students, done. Now, every single time when we talk about your principles of inheritance, the meaning of inheritance is that, let's take, you might have heard in your life that, right, your eyes look like your mother, your nose looks like your father, the way you talk looks like like your father, you got your father's height. All of you have heard that. All of you might have heard in your life, when you go to a wedding, when you go to a, let's say, a event, any family event, there are some relatives which will come behind you and tell you, you look like your mother. Okay, now why is that? Because students, there are certain characters which are passed from your parent to the offspring. That is called as inheritance. Now students, now, do you look exact copy of your parents, or are there small changes? You will tell me, sir, there are small changes there. You don't look exact copy. That'll be a little weird. Okay, if you're exact copy. Okay, you might be a clone. Don't tell anyone. Okay, so if there are small changes, right? Those small changes from parent to the offspring is called as variations. That is called as what, students? Variations, students. Okay, that is called as variations. So variations are the changes now. Now, students, when we talk about the chapter inheritance and variation, the first scientist which comes to your mind is Gregor Mendel. It is going to be, students, what? Gregor Mendel here. Gregor Mendel right now. Now, when was Gregor Mendel born? July 22nd, 1822. Okay, 822 right here. Now, students, what did he work on? His main work was on Pisum sativum. Students, what do you call Pisum sativum in your language? What do I call in Kannada? I don't forget, students. I forgot. What do you call Pisum sativum in Kannada? See, it's pea plant, right? Pea plant. Mutter in Hindi. I know mutter in Hindi. But in Kannada, I don't know. I forgot. What do you call? I forgot, students. Brain is not brain a little bit. Okay. I don't know what do you call in Kannada. I forgot. So if you know in your language, tell me in the chat. I'll be good to know. I'll be fun to listen to. Okay. Now, he worked on pea plant. He worked on, students, garden pea plants. Students, he worked on garden pea plants for 7 long years. All of you are crying. You don't want to study this for 1 hour. You're crying. Imagine working on a pea plant for 7 long years. How difficult it would have been. He worked from 1856 to 1863 for 7 long years. 7 long years, students. Now, was he simply observing all the pea plants? Yes, he was observing. When he was observing the pea plants, he noticed that there are 7 different characters which he took into consideration. 7 characters, 14 traits. Okay, he took 7 characters of contrasting traits. So 7 characteristics, 14 traits. Okay, clear to all of you. Now, all of these 14 traits, students, they are of pure breed lines. What is the meaning of pure breed lines? They are homozygous in nature. They are going to be homozygous in nature. How do we obtain pure breed lines? By repeated self-pollination. By repeated self-pollination, we obtain homozygous condition. They can be capital T or small t. This is called as homozygous condition. So all of these 14 traits were homozygous in nature. They can be dominant or recessive in nature. 14 pure breed lines. Okay. Can always see, students. They can be capital R, small r, capital Y, small y, capital B, small v. So if you can notice here, all of them are what? All of them are homozygous in nature. Okay, all of them are, students, homozygous in nature. Okay. Students, let me tell you, if he did not work on all of this that time, right, many of the genetic disorders would not be able to be cured by now, or we will not be able to do advancement in genetics. Now students, let me tell you again, the advancement in genetics is going to be next level in the future, because if gene editing becomes commercialized, we will get something called as designer babies in future. Designer babies. What is the concept of designer baby, students? You can decide what trait has to be present in your baby. You can tell a scientist that I want my baby to have blue eyes, very tall, it should have very fair skin, dark skin, it should be able to, all the traits can be managed. Designing a baby can happen because of gene editing. That happens. So all of that is possible because of Gregor Mendel only, students. So it became like literally you'll be playing a god there. Okay, you'll be playing a god there. So all of these are called as your 14 different traits here. 4 different traits here. Now you might ask me, students, why did he even take a pea plant? Like why? He could have taken a rose plant, he could have taken an onion plant, he could have taken a potato. But why a pea plant? Because, students, a pea plant has multiple advantages. For example, pure variety is easily available. That is, crossing, self-pollination is very easy. Large number of seed produced. Easy detectable contrasting characters. All of them can be, students. All of them can be very easily be found. Now, students, short lifespan, reproduction 3 months, can be grown very easily. So all of these, students, all of these reasons, Mendel took pea plant. Because of all of these reasons, students, Mendel took the pea plant right now. Okay, Mendel took the pea plant. Okay, customizing, exactly, customization. Now, students, now understand. Now, what did Mendel give you? Mendel gave mainly three laws: law of dominance, law of segregation, law of independent assortment. Now, law of dominance and law of segregation, these two laws are derived from monohybrid cross, while law of independent assortment is obtained from dihybrid cross. Monohybrid, dihybrid. Okay, monohybrid and dihybrid, students. Now understand, what did Mendel work on? Mendel's main work was on hybridization. There were 3 steps in hybridization: selection of parents, this parent, that parent you take. Then what happens? Crossing of parents, that is basically pollination is happening to obtain F1. Then there is something called a selfing of F1. 3 main steps in your hybridization experiment. Okay, hybridization experiment. Now, the first one is called as monohybrid cross. All of you know it is very simple. I've taught this multiple times. I've taught you this monohybrid cross, right? There is something called as parents dominant, recessive, homozygous in nature, gametes crossing over. We get the phenotype here. So we get the capital T small t. This is called as F1 generation, first filial generation. It is going to be tall, students. Why? Because of law of dominance. Capital T is dominant, so we get a tall plant here. Then selfing of F1, what do we get again? This is called as a Punnett square. Then we get a phenotype, genotype here. Phenotypic ratio is what? Tall, 3, 1 dwarf 1. Genotypic ratio is homozygous dominant 1, heterozygous dominant 2, homozygous recessive 1. So we get 1:2:1 genotype, 3:1 as a phenotype. This is easy to all of you. Doesn't require much time. Now, students. Now, next thing is called as a test cross. Now, if they ask you a question, now they ask you a question, students. Let me ask you one question, students. Is every test cross a back cross? Yes or no? Is every test cross a back cross? True or false? Is every test cross a back cross? True or false? Tell me yes or no. Is every test cross a back cross? Yes, it is. Students, understand there is something called as a back cross here. Something called as a back cross. What is back cross, students? We take F1 plant, cross with dominant parents. When this happens, it is called as the outcross. Outcross. It is not given you syllabus. When we take a F1 plant and we cross it with recessive parents, that is called as a test cross. Now, what is a test cross actually? What is a test cross here? What is a test cross here? In a test cross, what is happening is, it is a cross between dominant phenotype. Students, can anyone tell me capital T or capital T small t? In both the cases, can we get dominant phenotype? Tell me yes or no. Tell me, students, yes or no? Yes, we do. Yes, we do. Right. So here capital T and capital T small t, both of them will give what? Both of them will give tallness here. Tallness. So both of these plants can give dominant phenotype here. Okay. So it's a cross between dominant phenotype with recessive parents. Recessive parents. Okay. So we can take any of these two, cross it with small t, small t. Small t, small t. Okay. Now, but why do we do it? The entire test cross is done to find the, or to know the genotype of F1. So students, as I told you, this one is F1 right now. This one is F1. This is F1. Now we know this F1 has a dominant phenotype. But do we know the genotype? Tell me yes or no. Do we know the genotype? No. It can be capital T or it can be capital T small t. Any of the two is possible. To know the genotype, but what is the genotype? We are doing the entire test cross. The test cross here. To find the genotype of F1, we need to look at the phenotype of F2. This line I'll teach you right now. This line I'll teach you right now. See here. All of you look at the example given in NCERT. Here we have a dominant phenotype, unknown genotype. We do not know the genotype. The genotype can be capital W, or it can be capital W small w, because both of these genotype will produce dominant phenotype because of law of dominance. Both of these genotype will produce purple flower, will produce violet flower, will produce the violet flowers here. Okay, will produce the violet flower. Okay, both of them will produce the violet flowers right here. Dominant phenotype. So the whole point of test cross is to find, is this the genotype or is this the genotype? Both of these can be genotype. That is why we are doing test cross. Let's take, we do a test cross right now. We do capital W, small w with the recessive parents here. So when we do a cross here, we obtain here all purple here. It means that since we have capital W here, everywhere else we will have one capital W and we will get a all violet here. But in this case, since we had one recessive allele here, we end up getting two white. So how do we get this? To find the genotype of F1, to find this genotype, we need to look at F2 phenotype. In the F2 phenotype, if we have all purple, then the genotype is going to be this. In F2 phenotype, if it is going to be, if we can see a white color, then this is the genotype. So based on, if you want to find the genotype, look at the phenotype here and we can get it. That is called as a test cross. That is called as, students, what? Test cross, students. Done. Now students, in this law of dominance, here we have three main points. Here we have three main points on test cross, students. Three main points on test cross. Characters are controlled by a discrete unit called as factors, according to Mendel. Factors occur in pair, capital T small t, alleles here. In a dissimilar pair of members, one pair is dominant here, capital T is dominant, other one is recessive. law of dominance is used to explain the expression of only one of the parental character in a monohybrid cross in a F1. In a monohybrid cross, students, we can see here in this F1 we get capital T is expressing. So this is explained. This is explained by law of dominance. Law of dominance is explaining why we are getting tall here in this capital T small t. Okay. Small t S1. And the expression of both in F2 in the 3:1 ratio. That is the main thing about your law of dominance, students. That is the main thing about your law of dominance. Say once again, which one, students? This in test cross. Understand test cross once again, one more time. I'll give you a small recap. Okay. We are taking F1 and crossing with rescue parents. Here you can see here, students. We are taking F1. We are taking F1 here. What is the F1, students? What is the F1 here? The F1 can be two things here. It can be capital W, or it can be capital W, small w. Any of the following can be used as F1 here. Okay. So we are taking F1 and crossing with residue parents done. Now why are we doing it? We are trying to find what is the genotype. Is this the genotype giving you this phenotype here? Or is this genotype giving you the phenotype here? See here, students. Here we are doing this entire thing to find the genotype of F1, because when we have a dominant phenotype, I'll give you one more example. Okay, let's take, we have tall plant. We have a tall plant here. This is a dominant phenotype. Now students, tell me, what is the genotype here? Anyone who can tell me what is the genotype of this tall plant? Can anyone tell me what is the genotype of this tall plant? Can anyone tell me? Tell me, could you tell me in the chat? What is the, I will tell you, Janani, I'll tell you. Tell me, students. See, this tall plant can be capital T, or it can be capital T, small t. Both can be obtained here. Tell me yes or no. It is not just capital T. It can be capital T, small t also, right? It can be both. Tell me yes or no. It can be both. Tell me yes or no. Both is a possibility for this tall, because here also law of dominance says that capital T will express. So both is possible. So we are doing the test cross. To find this. We are doing the entire test cross to find what is this genotype here. See, here I have given you the tall plant, but what is the genotype here? It can be this, it can be this. So to find that, we are doing the test cross here. To do that, we are doing the test cross here. Okay. So in test cross, what do we do? In test cross, we take F1 and cross with the rescue parents. That is called test cross. What is out cross? Dominant parents, here rescue parents. That's all the differences. Okay. Now students. Now here, what is the dominant phenotype? The dominant phenotype here is violet flower. Now this dominant phenotype, just like tallness, genotype can be this or it can be this. So we are trying to find the genotype here. How do we do that, students? How do we do that? How do we do that, students? We do a test cross here. We take the genotype, cross with rescue parents, take the genotype, cross with rescue parents. And students, when we look at this phenotype now, this is the phenotype of F2. Phenotype of F2. When you look at the phenotype of F2, if this was capital W, then we will always get violet. Why? Because of law of dominance. Capital W is present everywhere. So law of dominance is that all violet. If this was a genotype, students, if this was a genotype, we will get 2 small w because of law of dominance here. And that's how we get to know that this is the genotype here. Okay. Now I'll give you the same example back here. Okay. let's take this example for instance. Let's take this example for instance, student. This example for instance here. Okay. Now I'm crossing, let's say, this one here. Okay. Capital T. What is restive here? Small t, students. Small t is restive parents. Students, what do we get here, students, in this case? Tell me, what do we get here in this case? In this case, what do we get here? What do we get here? All tall plants, all tall plants. If this was the genotype, if this was the genotype of this F1, this is the result in F2. So you can look at this F2 and you can confidently tell me, sir, the genotype of this tall plant is this. But, let's take, if this is the genotype, capital T, small t, small t. What do we get? This is what we get, student. This is what we get, right? Tell me yes or no. Now here you can tell me clearly, sir, these two are tall here and these two are dwarf. These two are dwarf. But why are they dwarf? They are dwarf because, student, they are dwarf because this was the genotype. So if you look at F2, students, by looking at F2, you can tell the genotype of this one. I hope all of you understand right now. With one of this example, you can understand right now. By looking at the F2 phenotype, I can tell this genotype here. It can be this or it can be this. Done, students? Done? Test cross done? Test cross done. Usually test cross takes a lot of time because test cross, it is not 3:1 here. We don't get 3:1 here, students. We do not get we get 3:1, but here we don't get 3:1 here. Small t. We get 1:1 ratio here. 1:1 ratio. Tell me yes or no. We get 1:1 ratio here. We get 1:1 ratio here. Okay. 1:1 ratio. 1 is, this entire thing is tall, entire thing is dwarf. 1:1 ratio. Okay. And students, tell me the phenotype and genotype here. Here, look at the genotype also. Look at the genotype. These two are tall, right? Homozygous, heterozygous dominant, 1. Homozygous recessive, again, 1. So here what happens in a test cross is, phenotypic ratio is also equal to, students, equal to genotypic ratio also here. Both is equal. Okay. This is law of dominance done. What is law of segregation? Understand. Okay. What is law of segregation, students? Law of segregation is called as law of purity of gametes. Now, all of you students, tell me what is your favorite milkshake? Tell me, students, what is your favorite milkshake in the chat? See, my favorite milkshake is mango lassi. Actually, my favorite is mango lassi. Okay. Now let's take, I'm trying to make mango lassi there. I will add mango pulp. I will add milk, condensed milk, sugar. Okay. I will add everything. Nicely I'll mix. I'll get my lassi. I'll get my mango lassi here. Now, students, you tell me in the chat, is it possible after blending it, students, is it possible to remove all the substances? After making the mango lassi, is it possible for me to remove the mango separately, milk separately, sugar separately? Not possible. Because everything has blended right now. Everything is blended. But according to law of dominance, according to law of segregation, students, alleles do not show blending. That is, in F1, when I write capital T small t, in the F1, even though the phenotype is tall here, are the two alleles blending here, students? Are the two alleles fusing here? No, they are not. I'll give you a simple example. If these two alleles are becoming one, if these two alleles were blending, how do we, students? Tell me in the chat. Tell me, students, how do we obtain here small t again? Is it possible, students? Is it possible to obtain small t again? No. If these two alleles underwent blending, this would have not been possible. Not possible. So if this is obtained here again, small t is again reappearing in F2. It means that the two alleles are not blending. That is called as law of segregation. First point in law of segregation. That is the first point in law of segregation. Alleles do not show blending. Alleles do not show blending. What happens? They do not show blending. They separate into gametes. All of you know, when we have capital T, small t, they will separate into gametes here. Capital T is in this gamete, small t in this gamete. They are segregating into gamete. Law of segregation. Law of segregation. They're segregating into gamete. Now students, that is also called as law of purity of gametes. Why? It is called as law of purity of gametes because this gamete is pure for tallness because only capital T is there. This gamete is pure for dwarfness. So pure. Every gamete is pure right now. It is pure for one character. So one trait. This gamete is pure for tallness. This gamete is pure for dwarfness. Law of purity of gametes. They are very pure right now. They are very pure. All of you understood, students? All of you understood the law of segregation? No. In incomplete dominance also, students, in incomplete dominance, the phenotype is seen different. But alleles, see students, I'll show you incomplete dominance now. See. In incomplete dominance, you see students. In incomplete dominance, what happens? One allele is incomplete dominant over the allele. One is incomplete dominant over the allele here. Okay. The F1 does not resemble both parents. If F1 is not resemble both the parents here, one parent is red, one parent is white. The child is going to be pink here. Child is going to be pink here. The child is going to be pink here, students. Understand here. Example is dog flower, snapdragon, atrium species. Examples given here. Now what happens you see here, students? What happens you see here? Now students, this capital R, small r we have here. We have capital R, small r here, pink color flower in the F1. All of you know that. Law of purity of gametes. This gamete is pure for red. This gamete is pure for white. Now students, you tell me in the chat, if the two alleles are blending here, how do we get R here again? RR? If these two alleles are blending here and became pink forever, how can we obtain here white color flower again? White is supposed to be impossible. Yes or no? It's supposed to be impossible. So again, listen to me very carefully. Law of purity of gametes, law of segregation is universal. There are no exceptions here. This right here, incomplete dominance, is an exception to law of dominance. Law of dominance has exceptions. Law of independent assortment has exceptions. But law of purity does not have exceptions, students. Does not have exceptions. Okay. Then students, then yes, it is incomplete dominance. Yes, it is incomplete dominance. Okay. Then students, then all of you, it is called as incomplete dominance. Here we get, students, one red, two pink, one white here. Here phenotypic ratio is equal to genotypic ratio. Okay, 1 to 1, 1 to 1. All of you know this. All of you know, students. Okay, all of you know this is called as your incomplete dominance. In the case of incomplete dominance, one allele is incomplete dominant over. Usually what happens is R is supposed to be dominant, small is supposed to be recessive, but that is not happening. That is not happening, students. Capital R is more dominant, small r is recessive in nature. Small r is recessive in nature. Now what exactly happens in codominance, students? In the case of codominance, it's very easy concept. In the case of codominance, both the alleles are dominant here. Both the alleles want to express here. So we end up getting an offspring. We end up getting an offspring which is similar to both the parents. Now students, Saurav asked a question. You got a hibiscus which was 50% white, 50% what? 50% white, 50% pink. Now if you are getting an offspring which is 50% white, 50% pink, you need to look at the parents. How is the parent right now? Is the parent white, red, white and pink? If the parent is white and pink, and you are getting both in the offspring, it is codominance. If the offspring is very different, it doesn't look like parents, then it is incomplete. Then it is incomplete, students. If the offspring does not look like the parents, incomplete. If the offspring is looking like both the parents, then it is going to be student. Then it is going to be codominance. So you need to look at the parents and the offspring. If it is looking like both of them, codominance. If this one, let's say, if this one becomes, let's say, red color, students, if this bird becomes red color, if this one becomes red color, then it is incomplete. Then it is incomplete because this one does not look like both the parents. Then it does not look like both the parents. Then it is red here. Then it is red here. Understood, students? Understood? Then it is red here. Since now it is looking like both the parents, it is codominance. It is codominance. Okay. Both alleles are dominant. F1 generation resembles both the parents. Both the parents. Example is human blood group. Human blood group, students. Okay. Diksha is over actually. Okay. Now, students, in the case of blood grouping, what do we have? We have something called as, there is I gene here. I gene. Now, this I gene has multiple alleles. When one gene has more than two alleles, it is called as multiple allelism. Usually what happens is that one gene has two alleles. All of you know that. Capital T, small t, capital T, capital T, small t, small t. Yes or no? Yes. Now, if one gene has more than one alleles, it is called as multiple allelism. For example, in the case of blood grouping, gene I has three alleles here, three different alleles, out of which only two alleles are present in our humans. Now here, the A and B blood grouping, they are producing different types of sugar on them. That is why they're different. This IA and IB both are different because both are producing different type of sugar. Now, can anyone tell me in the chat, this small I, right? Is it producing a sugar? Is the sugar produced here, students? Is the sugar produced in a small I? Tell me yes or no in the chat. Is a small I producing any sugar? Students, is a small I producing any sugar? No sugar. No sugar, students. Okay, no sugar. Clear? So, A is producing one sugar, B is producing one sugar, I is producing no sugar. No sugar. I is producing, students, no sugar. No honey here. No honey here. Okay? No honey and no money. Clear, students? Clear? All of it done. No sugar. That will Gopika ma'am will give you that. Gopika ma'am will give you that. Okay, students. Now I want anyone volunteer to tell me your blood grouping. I want anyone volunteer to tell me your blood grouping. Okay, anyone volunteer. Let's take. Who should I take, students? Who should I take? Anyone? Anyone who wants to volunteer? Quick. Anyone, students? Anyone? Anyone? Tell me quickly, students, in the chat. Okay. Kendrick has O blood grouping. In O blood grouping, what are the possible genotype? What are the possible genotype in O blood grouping? Small I. Okay. Then Akshana B blood grouping. What is possible genotype in B? IB or IB and small I. Now, students, Manaswini, okay, A blood grouping, IA or IA small I. Now, can anyone tell me in the chat, students, how many genotype? One more is missing. Any AB is also missing here. AB will have what, students? IA and IB both are present here. Codominance. Now, students, anyone can tell me, students, how many phenotype do I have here? Phenotype? Mine is O positive, students. Mine is O positive. I can denote everyone. I can give a blood to all of you. Don't worry. Okay. So, phenotype is 1, 2, 3, 4. 4 phenotypes. But, students, how many genotype do I have here? Genotypes. How many genotypes do I have here? Genotype 1, 2, 3, 4, 5, 6. So in total of human blood grouping, students, in the case of human blood grouping, I have 4 phenotypes, 6 genotype. 4 phenotype and 6 genotype. Done? Done. Students, you will get a lot of questions from here. You will get a lot of questions from here, so please remember. Okay. Pramod is little happy in life. Let him be happy, no? Let Pramod be happy in life. Okay. Now, students, inheritance of 2 genes now. Starting with inheritance of 2 genes. Shall we start, students? Shall we start? Very easy again. Parents we take capital R, capital R, capital Y, capital Y. Round yellow. Receive parents small r, small r, small y, small y. Winkled genes. Okay. Now we get gametes. Gametes are obtained here. Now again, students, you tell me, this gamete right here, it is pure for one trait. This capital R is pure for roundness. Small y is pure for seed shape and seed color. They are again pure for one trait. They are pure for one trait again. One trait. Okay. Now we get F1 here. Now F1, students, round in yellow, dominant. Then we do something called selfing of F1. Selfing of F1, we take the following, same F1 and cross it twice. Cross it twice, students. Cross it twice. Now, how do we find the genotype here? So how do you find the gametes here? Very simple. Very simple. What do we do, students? What do we do here? This with this, this with this. So what do we get? Capital R, capital Y, capital R, small y. This with this and this with this. Small r, capital Y, small r, small y. Small r, small y. So these are the gametes here. This is the gametes here. So you have to take these gametes, add it here, cross multiply, you get the entire ratio, students. You get the entire ratio, students. Now, can anyone tell me what is the phenotypic ratio here? What is the phenotypic ratio here, students? Now, by chance in examination, if you do not know the phenotypic ratio, how do you find? Listen to me very carefully. A dihybrid cross is a typical 2 monohybrid cross together. One monohybrid cross, when 2 monohybrid into monohybrid, we get dihybrid. Now, students, can anyone tell me what is the phenotypic ratio in the case of monohybrid? Phenotypic ratio in the case of monohybrid is 3:1. 3:1. Now, students, can anyone tell me what is 3 into 3? 9. 3 into 1? 3. 1 into 3? 1 into 1. 9 is to 3:1. Okay. Now, students, can anyone tell me what is the genotypic ratio? 1:2:1. 1:2:1. So what do we get here, students? What do we get here? 1 into 1, 1. 1 into 2, 2. 1 into 1, 1. 2 into 1, 2. 2 into 2, 4. 2 into 1, 2. 1 into 1, 1 into 2, 1 into 1, 1. This is the genotypic ratio of dihybrid. Then students, all of you, tell me yes or no. Then all of you, phenotypic ratio, genotypic ratio of your dihybrid cross. You can do here. 9 is 3:1. Students, again, in examination, all of you should know. One small thing here. This round yellow, round green, wrinkled yellow, wrinkled green. This you have to know, because in examination sometimes what they can do is they will change the traits. They will change the character. Here they have given you, students. Here they have given you seed shape and seed color. But in examination they can give you, students, they can give you something called as pod shape, pod color. That time you should be able to do this trick here. Same thing you should be able to do. And here, students, remember, this round yellow and wrinkled green, these two are called as parental. These two are parental here. Because round yellow is parental, students. All of you remember? All of you remember here? Round yellow, wrinkled green. These two are parental here. These two are parental here. Now, round green and wrinkled yellow, these two are recombinant. So please remember in examination, what they can ask you, what they're asking you, students. Okay, so these two are parental, these two are recombinant types. Multiple question can come from that. Students. Okay. Now, students. Now what do we study right now? Students? In 90s, right, three scientists, Hugo de Vries, Carl Cons, and von Schmuck, independently rediscovered Mendel's result on an inheritance of characteristics. Let me tell you, students. Until Mendel's death, until Mendel's death, he did not even know that his work is legendary. He did not know that. Can you believe that, students? Mendel died without knowing the value of his work, because no one recognized his work. No one gave a single shot at his work. So Mendel died without even knowing that, yes, his work was absolutely correct. His work is world famous right now. His work is still studied by every single student who are writing NEET examination. Still you are studying that. That's how important Mendel's work was, and unfortunately, students, Mendel did not know that. Sad ending. Sometimes life can be unfair, students. I'll tell you one more instance, students. Right? Do all of you know who discovered the double helix model of DNA? Anyone, students? Anyone? Who discovered the double helix? Who gave the double helix model of DNA? Students? Who gave the double helix model of DNA? You'll tell me, sir, Watson and Crick. And Watson and Crick also got the Nobel Prize for it. But there was one more scientist, actually, female lady, who was called as Rosalind Franklin. Rosalind Franklin did not get any recognition. She did something called as X-ray crystallography, okay, of your entire DNA there, right? The problem was that, students, by the time they got Nobel Prize, she was no more, and she could not get the Nobel Prize yet, because Nobel Prize is only given to living people, not to dead people. So Gregor Mendel also never got a Nobel Prize. So Nobel Prize is only given to students. Nobel Prize is only given to living people. So there also life can be unfair. What to do? Life can be unfair sometimes. Lesson for today, students. Lesson for today, all of you. Okay. Now, students, we come to something called as chromosomal theory of inheritance. It was given by Sutton and Boveri. Gave the chromosomal theory of inheritance. What does it say? Students, I need a volunteer in the chat, students. I need a volunteer in the chat. Who can do? Okay. Can I get a volunteer, students? I need a volunteer. Exactly. Even I can't believe it's 1 a.m. already. I need a volunteer, students. I need one volunteer quickly in the chat. Who can come on the board as a volunteer? Okay. Let's take Nitya today. Let's take a Nitya today. Nitya. Okay. So Nitya is right here, students. Now, students, Nitya has a best friend. Let's say who is the best friend? Okay. Students, I can't see, students. Oh my god, it's so difficult to see also. Let's take Darshini. Oh my god. Okay. Now, students, understand here. Okay, Now, Nitya is right here. Now, let's say their house is 10 kilometers far. Her house is here. Okay. Don't ask me why I'm drawing small house. You should not tell me later on. Okay. Excel, you have to see easy names. Okay. Now what happens? Their house is 10 kilometers far. Now what will Nitya do, students? Nitya will take a cab, or she has a car. Let's say she has a Lamborghini. Okay. Nitya will sit in her car now. Students, I can't draw a car now. What to do? No. She will now sit in her car. Okay, not a Lamborghini. Okay, it's not a Lamborghini. It's some car you say. Okay. Now she will sit inside a car. Okay. Light is coming from there. Okay. Night time. No, night time. Okay, it's a night time. Now, students, Nitya is sitting in a car and she is traveling to Darshini's house. Traveling to Darshini's house. Okay. Now, students, now all of you understand. When Nitya is traveling in a car to Darshini's house, is the car also going? Car also is going. Is the Nitya also going? Nitya also going. Okay. Now, small understanding. Now, if you understand this concept, if you understand this concept right here, chromosomal theory of inheritance is over. What do I mean by that, students? What do I mean by that? Here, understand, students. Here, car is going to be what? Car is going to be chromosome. Nitya is going to be gene. According to chromosomal theory of inheritance, the behavior of a gene and behavior of a chromosome is same to same. Why? Because students, if you take a chromosome, genes are technically present on the chromosome. Genes are present on the chromosome, students. If the chromosome is moving, is gene also is moving? If the car is moving from here to here, is Nitya also moving by the same time? Yes, she is moving. Obviously, she is moving. So, chromosomal theory of inheritance tells you that behavior of a chromosome is parallel to behavior of a gene. Now, during the meiosis or cell division, what happens? If the chromosome is splitting here, is gene also splitting, students? Tell me, students, in the yes or no in the chat. Is the gene also splitting? Why? Because gene is technically present where? Gene is technically present on the chromosome. It is a part of it. Here, students, tell me in the chat right now. Is it possible that only Nitya will go and the car will not go? Or will the car go, only Nitya will not go? No. It is not Tesla right now. It is not Tesla. It is not a Tesla car. It is a car where someone has to drive here. Okay. Since both are present together, both behavior is combined here. So similarly, students, if a gene is separating out, if the chromosome is separating out, the gene also will go along with it. If the car is moving from here to here, Nitya is also moving from here to here. All of you understood, students? All of you understood? Tell me yes or no in the chat. Students, all of you. Yes. So chromosome behavior and gene behavior is parallel to each other. Behavior of chromosome is parallel to gene and propose the chromosomal theory of inheritance. That was your chromosomal theory of inheritance. That's all is chromosomal theory of inheritance. It is not complicated at all. Both have same features. All of you understood? See, genes occur in pair, students. Alleles are there. Chromosome also has two pairs. That's all is the concept, students. That's why it's not a Tesla. Tesla will drive on its own. Okay. Now, students. Now, this was chromosomal theory of inheritance. Now, one more scientist came into picture, students. One more scientist came here. He told us that, students. He gave experimental proof. The scientist who gave the experimental proof is called as what? T.H. Morgan. So T.H. Morgan came and gave the word linkage right now. He gave the word linkage and he told us that he worked on Drosophila. And he gave the concept of linkage and recombination. Now, students, do you want me to teach you linkage and recombination? Tell me yes or no in the chat. Do you want me to teach you linkage and recombination? Tell me yes or no quickly in the chat. Do you want me to teach you linkage and recombination? Yes or no? Quickly, students in the chat, tell me. Or do all of you know? Do you want to learn? Oh, law of independent assortment is missing, students. Oh, almost forgot, students. Law of independent assortment says that. Okay, I forgot, students. Almost forgot. Here you see this, right? You see this, right? This is a hybrid here. It has seed shape and seed color together in it. Seed shape and seed color in it together. Law of independent assortment says that segregation or separation or assortment of seed shape is independent of seed color. Seed shape will assort independently, seed color will assort independently. They will not influence each other. Assortment of seed shape and seed color are independent of each other. That's all. So that's all, students. Okay, that's all, students. That's all. Law of independent assortment. Students, here you can read this. You can read this paragraph. Why he only took that is Drosophila malling ester. Okay. Now, students, here I have few examples from previous class. Okay, here I have few examples from previous class, students. Previous class. I'll tell you in a very small way. Understand. Okay. Here we have Rohit and Balaji. Both are BFF. What are they? BFF, students. If they are BFF forever, okay, best friends forever, between them linkage is high, recombination is very low. Recombination is very low. Then there is Ravi and Rohit. Between them there is not a good bond. They do not like each other. They do not like each other at all. Some cold war is between them. Cold war is happening between Rohit and Ravi. Okay, cold war is happening here. So between them, what is happening? Between them, linkage is low, recombination is very high. They will very fight with each other. Linkage is not there. Linkage is not there between them at all. So here we can tell that, right, linkage is inversely proportional to recombination. Linkage is inversely proportional to recombination here. Okay. Now, if you take the same concept, and apply it to a chromosome here, let's take, this is one chromosome right here, student, one chromosome here. On this chromosome, we have multiple genes on one chromosome. Here we have gene A, gene B. Two genes are very close to each other. It means, what students tell me in the chat right now? If A and B are very close to each other, will the linkage be high or low? Tell me in the chat. Between A and B, students tell me in the chat right now. Right? Between A and B, is the linkage high or low? Tell me in the chat. All of you. Tell me, students. Linkage is very high. Linkage is going to be very high here. Linkage is very high here. Now, what about A and C? Here they are very tight linked. Their linkage is very high. Linkage is very high. They are tightly linked here. Tightly linked. Recombination is low. Now, what about A and C, students? A and C. What about A and C, students? They are very far from each other. They are very far from each other. Very enmity. So, in this case, between A and C, linkage will be low. Recombination is going to be high. Linkage is going to be low here. That is your linkage and recombination concept here. If you look at this table right here given you NCERT, right? This is a table given you NCERT right now. You can see here right now, here Y and W, which are very close to each other, means what? Linkage is high, recombination is just 1.3%. If you look at this cross here, they're very far from each other, Okay, so linkage is kind of low here. Recombination, can you see, you can very high. Not very high, little bit high. 37.2%. Now some of you will ask me, sir, recombination is not very high, students. Recombination is not very high. Now, how can this recombination become even more high? This recombination can become even more high when the two genes are present on two different chromosomes very far from each other. In such a case, it is going to be very high. Okay, such a case is going to be very high, students. That is called linkage and recombination. That is called as linkage and recombination, students. Now, I always tell you, Mendel is very lucky. Why? Because Mendel is very lucky because, students, whatever traits which Mendel took, or whatever characters which Mendel took, right, all of them were present on only 4 chromosomes, or all the characters were almost very close to each other, and that's why he did not get a lot of variation, not much variation. Okay, but in reality, what happens? In reality, what happens is that sometimes what happens is the two genes are very far from each other. When the two genes are very far from each other, what happens? There is more recombination. When there is more recombination, this 9:3:3:1 ratio is not obtained at all. It is not obtained. This 9:3:3:1 ratio is not obtained at all. Okay, so law of independent assortment is not always true. It is not universal. Because of law linkage and recombination, we know that variation can be obtained here. More variations can be obtained. According to Mendel, only few variations, no. But here, more variations can be obtained here. Clear, all of you students? Clear? All of you clear, students? Is it clear? Tell me yes or no in the chat. Tell me yes or no. Done, students? Done? Done? All of you? No. Now, next concept is called as polygenetic inheritance. Now, what is polygenetic inheritance, students? Now, according to Mendel, we can have either short people or tall people only. But is that the case? First, is that the case in reality? In reality, we don't have only tall and short. We have gradation of height. Can you see here? There is a gradation of height here. But according to Mendel again, we should have only full white people and dark people. But is that the reality, students? That is not the reality. We have a gradation in color also. We have a gradation in color. Now, how can we explain this? This entire concept of gradation, right? Gradation is explained by polygenetic inheritance. What do you mean by that? Polygenetic inheritance tells you that many genes control one trait. That is, for example, skin color. Skin color is one trait here. This one trait is colored by many genes. One trait is controlled by many genes. Here we can see capital A, capital B, capital C. Okay, it's going to be much more brown skin color. Let's say we have capital A, capital A, capital B, capital B, capital C, capital C. Very dark skin color can be here because all dominant alleles are present here, right? When all dominant alleles are present here, dark skin color. As we go lower and lower, here we can see, students, all recessive alleles. So white skin color. So this entire polygenetic inheritance, right? It can show additive effect. So more number of dominant alleles, stronger is the phenotype. Less dominant alleles, weak is the phenotype. Okay, and at the same time, students, it is environmentally influenced. What do I mean by that, students? What do I mean by that? Okay, let's take this girl here, right here. This girl right here, students. Let's take this girl. Now this girl, even though her skin color is a little bit brown color, now if she goes and stands in the sun, 24 hours throughout the year, what will happen? She can get cancer, that is there. Apart from getting cancer, right, her skin color can become dark because of tanning, environmental control. Now students, understand, even intelligence is also a polygenetic trait. We don't have only low IQ, high IQ. No, we have a gradation in IQ also. Now students, this IQ is there, right? Or intelligence can also be environmentally influenced also. If you study well, if you do better, when you're young, if you do a lot of brain activities, your IQ can actually increase to some extent. it can increase. Okay, if you eat almonds, almonds can also increase. Your parents tell you, right? Your parents still eat almonds. Why? Because it can actually increase your brain activity. So eat almonds. Okay, eat almonds. Okay. Now, what is this? Is your polygenetic inheritance. Here, many genes, one trait. Exact opposite pleiotropy. Exact opposite pleiotropy. In the case of pleiotropy, students, in the case of pleiotropy, a single gene will control many traits. Single gene, multiple phenotypic expression. Multiple phenotypic expression. Example is phenylketonuria example. Okay, where phenylalanine is not converted to tyrosine. Because of that condition, what can happen? Skin pigmentation can happen, reduction in hair, mental retardedness. They become mental basically. They become mental basically, students. Okay, so that is called as pleiotropy. That is called as pleiotropy, students. Then, students, then all of you. Then, students, any doubt here? Any doubt here, students? Students, I hope all of you also get Government Medical College. If you all your hard work should show. All your hard work should show, students. Okay. Now, students, next concept is called as sex determination. Now, sex determination, the name which should come to your mind is supposed to be Hanking here. Hanking told us that, students, there is something in 50% of sperm. They receive something called as X nuclear material. 50% do not receive that. Okay, 50% receive something called as X body. He called it X body. 50% do not receive that. Later on, we go to know, students. Later on, we got to know that whatever sperm is receiving the X, right, that is the X chromosome. Whatever sperm does not receive the X, that is called as a Y chromosome here. Okay, Hanking. Now, this is the sex determination. There is something called as male heterogamety, female heterogamety. In male heterogamety, what happens? Example is humans and grasshopper. Here, what happens is that males has two different types of chromosomes here. So, since male has two different types of chromosomes, males can determine the sex of the offspring. For example, if this X and this X comes female child, if this X and this Y comes male child. Male heterogamety, humans and grasshopper. What is female heterogamety? In the case of female heterogamety, what happens is that the females decides the sex of the offspring here. For example, in the case of birds and butterfly, what happens is that we can see here birds as ZW and ZZ here. Here ZW will determine the sex of the offspring. Z not butterfly. This female will decide the sex of the offspring. That is called as female heterogamety. Now, students, there is something called as, in the case of honeybees, very special in the case of honeybee. In the case of honeybee, what is happening? We have haplodiploidy. What do I mean by that? Haplodiploidy is a concept where the number of chromosomes decide the sex of the offspring. For example, see this. Here, male honeybee are haploid, female are diploid here. Mitosis, sperm, meiosis, egg. Why? Because we need haploid gametes. Meiosis, mitosis. Male are haploid, female are diploid here. Okay. Whenever there is fertilization, 100% of time, we always get female. Always we get female here. 100% of time, always female here. Okay, because why? N plus N is 2 and just 1 N. Now, this female can become queen or worker. Now, how do we get male here? Male are produced by a process called as parthenogenesis here. For example, this is a female here. It undergoes egg here. Now, this egg undergoes parthenogenesis to produce the male here directly. Now, here, this is called as parthenogenesis here. Now, here, students, you tell me in the chat right now, does this male has a father? No father. So, no father. Can this male right here has a son? Not possible, because always female here. Now, students, you tell me in the chat right now. Let's take we get a male here. Let's say we get a male here. Does this male has a grandfather? This is the grandfather here. See, no father but grandfather. Does this male has a grandson? See, no son grandson is available. So there is grandfather, grandson, no son, no father. No son, no father here. Okay, no son, no father right now. Okay, so this is male is called as a drone here. Male is called as a drone is produced as a result of parthenogenesis here. Parthenogenesis. Okay, haplodiploidy. Students, in mutation, what you have to remember? What is mutation, students? Mutation is nothing but sudden inheritable change. All of you know X-Men. X-Men is a result of mutation. Now here, sometimes they might ask you a question. Okay, there is something called as aneuploidy or euploidy. Understand, very simple. Aneuploidy, there can be two types. Say aneuploidy and euploidy. First, understand euploidy. What exactly happens in euploidy? In the case of euploidy, the complete set can change. 2n to 3n, 3n to 4n, the entire set will change here. Now, but what about aneuploidy? In the case of aneuploidy, students, there is something called as hypo and hyper. In the case of hypo, there's a decrease in number of chromosome, and in the case of hyperploidy, there's an increase in number of chromosome. Now, can anyone in the chat tell me a disease where chromosome number decreases? Anyone who can tell me, students? Anyone who can tell me a type of disease where chromosome number decreases? Turner syndrome. All of you remember, students? In Turner syndrome, one X chromosome is missing. Listen. Can anyone tell me an example of hyperploidy, Down syndrome, trisomy of 21, Klinefelter syndrome, one extra X chromosome? So here is the example. Here is the example, students. Here is an example. Here is an example, students. Here we have Klinefelter and Down syndrome here. Okay. Students. Now we come to pedigree, students. In pedigree analysis, very simple rule. All of you need to know the entire symbols here. Now in this symbol, the main important where the question is generally asked is this one right here. This one here. Consanguineous mating, you have to remember. Always they ask you this one only. Okay. Now students. Now pedigree, students. This is the holy grail of pedigree. If you know all of these rules, you can solve any pedigree, students. Here are the shortcuts on your board. Just have a look at it, students. Have a look at it. Have a look at it, students. This is called as pedigree analysis. This is called as pedigree analysis right now. Here, what is autosomal dominant? Don't skip generation. Recessive is skip generation. Affected parents can have unaffected children here. Okay. Similarly, students, for X-linked recessive, Y-linked. So if you learn all of this from my notes, you can solve any pedigree. Any pedigree, students. Okay. But in your NCERT, you only have two of them. In NCERT, students, you only have two. For example, look at this one. Autosomal dominant, right? Autosomal dominant. Not skipping generation. Not skipping generation. See here. Autosomal dominant, don't skip generation. Done. Affected parents can have unaffected children. Here, understand. Affected parents can have unaffected children here. Autosomal dominant. Done. If you look at this one, students, autosomal recessive. Unaffected parents can have affected children. Here. Unaffected parents here. Parents are not affected. Unaffected parents can have affected children. That is going to be your autosomal recessive here. But in your NCERT, students, in your NCERT, there is only one example for autosomal dominant, mitotic dystrophy. An example of this one is going to be your sickle cell anemia. Sickle cell anemia is autosomal recessive here. Okay. Now, apart from that, students, do you have other diseases? Yes, you have other diseases. For example, autosomal dominant, we have only one, MD, mitotic dystrophy. Recessive, we have PKU, sickle cell anemia, thalassemia. All three are examples of recessive here. Because in examination, they will give you a list. They'll give you a list of diseases. Then they will ask you which is autosomal here. Simple as that. Okay. Now, sex-linked, we have two, color blindness and hemophilia. Two are present for sex-linked here. Color blindness and hemophilia. Okay. Now, chromosomal, we have autosomal is Down syndrome, sex-linked, Klinefelter, Turners. Now, again, I'm telling you, students, this entire one table can get you so many marks. It can get you so many marks, students. So all of you try to take a mental image. All of you try to take a mental image here. And once you're done, just say done sir in the chat. All of you try to take a mental image right now. Done? Done, students? Done? Just try to absorb this and you'll be good to go. Done, 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 done. Students, tell me, phenylketonuria is an example of which type of disease? Phenylketonuria is an example of which type of disease? Phenylketonuria. Answer in the chat. PKU is which type of disease? Quick, quick, quick. Phenylketonuria is a which type of example? That is going to be recessive, autosomal recessive. PKU is autosomal recessive. Okay, students. What about hemophilia? What about hemophilia, students? Hemophilia. Quick, quick, quick. What about hemophilia? What about hemophilia, students? Hemophilia. Hemophilia is going to be, students, sex-linked recessive. Sex-linked recessive. Hemophilia is going to be sex-linked or X-linked recessive. X-linked recessive. Not autosomal. Done? So such questions can be asked in examination, so be ready. Okay, be ready, students. Now, students, now. Can we finish the last part in next 15 minutes? 10 minutes, we'll finish the entire chapter. In next 10 minutes, I'll finish the entire chapter. Ready, all of you? Ready? Students, again, if you want to solve questions on this chapter, students, hair fall is happening. Oh my God, hair fall. Sad story. Students, again, if you want to do numericals, I have done all possible numericals already on the channel. If you go watch my video on class 12 MCQ, class 12 PYQ, students, class 12 PYQs, you can find all the numericals there. You can find, students, you can find something called as a, okay, you can find all numericals there, all possible numericals. You can find questions on color blindness, crossing color blindness, everything can be found there. Okay, shall we start, students? Yes, they are X-linked recessive, hemophilia and color blindness. Okay, exactly. I'm getting old. What is this? Hair fall is happening, students. Hair fall is happening. Pray for me. All of you pray for me, students. Yes, Cash is my dog, students. My dog name is Cash. Okay. Rosemary water. I will write to you, students. Rosemary water. First of all, I have to grow rosemary now. I have to start growing rosemary. Can't buy from outside. Okay. Students, I use jasmine oil. I am not very fancy. My very simple oil is parachute or jasmine oil. That's all. Nothing. Alternate days. Or castor oil. Castor oil is the best, actually. Castor oil. Best. So what my mom does is, my mom takes parachute oil. She will add the parachute oil. She will add garlic into it. She will add all types of herbs into it, and she'll make a special oil. And every Saturdays, she will make me sit oil on the head. Okay. Try it, students. Try it. Shall we start, students? Shall we start with color blindness? Color blindness is starting, students. Students, I've always told you, color blindness people has no value, students. No value. Because unlike if you're blind in real life, you can apply for PWD quota and you can get a reservation. But color blindness people, students, no respect only. No respect. Color blindness people, they don't have any quota only, no reservation only. Okay, and it's so dangerous. Imagine a colorblind person is driving a car. He cannot see which is red color, which is green color. He cannot even see, students. He cannot even see the signal, red or green. Very dangerous, students. Very dangerous person. Okay, very dangerous person, students. Always remember, students, it's an X-linked recessive disorder. Here, what happens? It is a defect in the defect due to the mutation of gene present on the X chromosome. one gene present on the X chromosome, there is a mutation here. Okay, here males will suffer more, obviously students, RIP males here. Okay, males will suffer more here compared to females here. Okay, because it's X-linked, because it is X-linked here. Because when males get one X chromosome from your female, it is, if it is carrier, colorblind directly students. Okay, so there in the eyes there is something called as, in your eyes there is something called as rods and cones that gets affected here. Okay, now what is hemophilia students? What is hemophilia? Again, it is sex linked. Now hemophilia is sex linked recessive disorder. Again, it is called as bleeding disease. What happens here is, one small cut, one river will come, give me a river. Okay, one river will happen. Okay students, so people who like to cut themselves, the mental people, for them this is heaven. If they have the disease, they are in heaven. The people who try to cut themselves, right students, whenever some breakup happens, cut people. Okay, so for them this is a heaven. Okay, now this disease students, what happens, there is no clotting factor is not there. The blood clotting will not happen. The blood will keep on flowing. This is a disease which is found in your Queen Victoria family also. Okay, Queen Victoria family, it is seen here. Okay, now students, what is sickle cell anemia? Understand what students, what exactly happens in the case of sickle cell anemia? In the case of sickle cell anemia, what happens? It is, first of all, it is a autosomal recessive disorder. Students, it is a blood disorder also. Hemophilia, bleeding happens. Okay, not a blood disorder. This is a blood disorder actually. This was a proper blood disorder. Okay students, now what happens? Here a person will have abnormal hemoglobin. Now why does it happens? This entire thing happens because of a mutation, because of a point mutation. What happens students? Understand here. Let's take, we have GAG here. Now GAG becomes GTC. Yes, here adenine. Here adenine is replaced by thymine. So A becomes T here. Just because of one single change in a base pair here, right? One single amino acid change, A became T, and because of that we have mRNA is changing. Because of the change in mRNA in the beta globin chain, instead of glutamic acid, we have valine here. Valine is there, and because of this one small change here, the entire shape of hemoglobin changes here. Entire thing changes here. Okay, so you can see here students, it became what now? Entire cell became sickle shape. Students, and because of a sickle shape, right, hemoglobin cannot be stored, and the person here will not get enough of oxygen. That's all students, that's all. Write down here. Now always remember students, here normal person will have HbA normal, carrier is going to be HbS. Sickle cell anemic person will have HbS. It means they are sickle cell anemic in nature. Okay, now what is phenylketonuria students? Understand, very simple again. Normal person, what happens? Phenylalanine gets converted to tyrosine because of the enzyme present here. Which enzyme? Phenylalanine hydrolase enzyme. If the enzyme is missing, what happens? Phenylalanine will not get tyrosine. Conversion is not happening. If there is no conversion of tyrosine, what happens? Phenylalanine is accumulated and converted to phenylpyruvic acid now. Now students, accumulation of this in the brain results in the mental retardedness. These are also excreted through urine and cause of poor absorption by kidney because of accumulation of phenylpyruvic acid now. All of it is happening because of one enzyme is missing here. Now students, remember, in the case of sickle cell anemia was a quality problem. Because the beta globin chain was, one quality was missing. But thalassemia is a quantity problem. What happens in thalassemia? Understand. First of all, it is the autosomal linked recessive disorder. Here we have something called as alpha thalassemia, beta thalassemia. Now what happens students? Understand here, in the case of alpha thalassemia is there, here on the chromosome 16, students, there is a defective in a gene. What is happening? HbA2 gene and HbA1 gene are not functioning properly. Because of this condition, there is an abnormal alpha chain. So in alpha thalassemia, alpha chain is reducing. So quantity is reducing. Quantity is gone. Now, in beta thalassemia, what is happening? Here it happens on chromosome 11, HBB gene is defective here. Because of this effect here, what happens? Beta globin chain, beta globin chain is reducing. So in beta thalassemia, beta globin chain is reducing, alpha thalassemia reducing here. So because of this condition, one chain is missing. So it is a quantity problem. Now, what is Down syndrome, students? Down syndrome, what happens? In the 21st chromosome, extra one chromosome is here. Extra one chromosome here in 21st position. Discovered by Langdon. Now, where will the question come from? The question will mainly come from, students, the symptoms here. Question will mainly come from the symptoms here. Write down, students, write down. Symptoms is what, students? Short stature, small round head, furrowed tongue. Meaning of furrowed tongue is what? Meaning of furrowed tongue is outside. Tongue is out, students. Tongue is outside. Okay. Now, partially open mouth. The mouth is like small, lightly open here. Palm with broad creases. On the palm, they can see multiple creases can be seen on the palm here. Let me come here. Okay. Physical, psychomotor, and mental retardedness can be seen here. Students, have you noticed people with Down syndrome? Raise your hands. Have you seen people with Down syndrome? Raise your hands, students. Tell me, students. This is the Down syndrome. These are the kids with Down syndrome, students. These are the kids with Down syndrome. You might have seen, students. You might have seen. Okay. These are the kids with Down syndrome. These are the kids with Down syndrome, students. Furrowed tongue, small open, round, small head. Okay. Small round head. Okay. Again, speaking also changes happens. Okay. Now, next is called as Klinefelter syndrome. In Klinefelter syndrome, there is an extra X chromosome. Students, everything X is not good in life. Okay. So here what happens is XXY condition happens. Gone case. Because of this one extra X chromosome, what happens? The entire male will develop feminine features. That is development of breast called as gynecomastia. Gynecomastia happens here, development of breast. Okay. Now, what is Turner syndrome? In Turner syndrome, what happens? One X chromosome is missing. This is normal condition. Turner syndrome, XO condition. One X chromosome is missing here. Now, what happens? Symptoms. What are symptoms here? That is, ovaries are rudimentary. Other features including lack of other secondary sexual characteristics are also missing in the case of female. So this happens only in the case of female. Klinefelter syndrome happens only in the case of male. Only in the case of male, students. Only in the case of male. Okay. And with that, students, the chapter is over. Now, students, again, microbes, I will not be doing microbes. Microbes is very easy. Microbes is very, very easy. All you need to do is remember the examples of microbes. If you remember the examples of microbes, you're done and dusted. You're done and dusted, students. Okay. Microbes is very, very easy. Microbes is very easy. Only thing in your microbes you should remember, students, the only concept you have to remember is BOD. For example, let me teach you that concept. The only concept which you might feel difficulty is the BOD concept here. I'll teach you that one here. Listen to me. Let's take, I have two water bodies here. Water body A, water body B. Okay. Let's take, I have two water bodies here. Okay. Now let's say water body A, first of all. Water body A, what happens? Understand, students. Okay. Here there is more pollution. More pollution. In water body B, students, less pollution. Less pollution. Now, students, you tell me in the chat right now. Here, if you have more pollution, it means that do we have more organic matter or less organic matter? If there is more pollution in this water, organic matter is more or less? Tell me in the chat, students. Tell me in the chat. All of you in the chat, tell me. Tell me students quickly in the chat. We have more organic matter here. What about here? Less organic matter. Okay. Now students, you tell me in the chat, if there is more food here, lot of food is here. Okay. More microbes, less microbes? Tell me. More microbes, more bacteria here. More food, all of you tell me in the chat. If I give you free food, you'll also come to me. Also come to me. Okay. Here less bacteria. Less bacteria. Now what happens, students? Here, if there is more bacteria, students, it means that is the demand of oxygen more or less? Tell me, students, in the chat. Is there more oxygen demand here? Obviously. More. What about here? Less O2 demand. Now students, what about biochemical oxygen demand? BOD is also very high here. BOD is very high. BOD is very low. So whenever we get a polluted water, students, very high polluted water, it will have very high BOD. Now students, if I take this water and I will make it undergo. Students. I will make it undergo sewage treatment plant. If I take this water and undergo sewage treatment plant, I will make sure by the end of it, this water, students, this water should have very low BOD. That is the main aim. That is the main aim of STP. The main aim of STP is what, students? The main aim of STP is to reduce the BOD of this water, and that is what we're trying to achieve in STP. Students, is the concept clear, students? Tell me in the chat right now. Concept clear, students? Is the concept clear? The main concept of STP is to reduce the BOD of the water. Okay. Students, here is a flow chart. Here is a mind map which has all the examples given right here. So you can read once. Students, in STP, all of you should know, students, in STP, what this is STP right here. This is a very large STP. I'll tell you in a very small way. Understand? Okay. There are multiple chambers in STP, students. There is something called as primary treatment. In primary treatment, there is physical removal of waste. And the first two chambers are primary treatment here. Okay. Now, what exactly happens in the first chamber, students? What exactly happens in the first chamber? Understand. In the first chamber is called as filtration tank. Okay, filtration tank. Now, students, can you see grids here? Background grids. There are multiple grids like this. Here we have bigger size. Here we have very small fine grids. So what happens is large particles are stuck here. Small particles are stuck here. So as we go from here to here, the majority of your filtration happens here. Large particles, small particles here. It's called as filtration tank. Okay, filtration tank. It's called as sequential filtration. By sequence, as we go, we make smaller and smaller. Okay, filtration tank. Second is called as sedimentation tank. In sedimentation tank, all about gravity here. As we whenever there's gravity here, what happens? All pebbles, grids, everything will go down and settle. Top part is called as effluent. Bottom part is called as primary sludge. Okay, sedimentation tank. Top part is called as your effluent, which can be sent to the next group. See here, sedimentation tank because of gravity. Now here, understand, students, the top part, what happens? Top part is sent here to the next one. Bottom part can be primary sludge, can be sent back here again for more filtration. Now, that is two things: filtration, sedimentation. Okay. Now, students, second is called as secondary treatment. Now, secondary treatment, we use microbes. here. Now, third tank is called as aeration tank. In aeration tank, what are we doing? Air is doing. Now, why are we increasing air here, students? We are increasing your oxygen. Why? Because in aeration tank, We have a lot of bacteria. Lot of bacteria is present here, and all of this bacteria will nicely munch on all the organic matter. So all the organic matter, can you see? All the organic matter will be eaten here. Now here, students, what happens is that mechanical agitation and pumping of air increase the number of aerobic bacteria. Now here there is something called as flock formation. What is a flock, students? Flock is nothing but it is a mass of bacteria and fungus. Bacteria and fungus is attaching, intermingled. That is a flock formation happening. Now with the help of flock, students, all the organic matter is consumed. Done. That is aeration tank, students. Aeration tank. Now the whole point in aeration tank, students, in the end of aeration tank, BOD level is coming down. BOD level is coming down by the end of aeration tank. Okay. So see this. Greater the BOD of water, higher the amount of organic matter. Okay. Sewage treatment is treated until BOD is reduced. BOD is reduced, students. That is aeration tank. Now, students, what happens is that next tank is called as settling tank. Settling tank. In what happens again in settling tank also gravity. Gravity takes place. Gravity, students. Okay. So gravity takes place. Now, what happens, students, in the case of settling tank? What happens? Remember in the sedimentation tank, what was there? Bottom part is called as primary sludge. Here now, students, bottom part is called as activated sludge. You might ask me why, sir? Why is it called as activated? Because students, this bottom part is actually active dividing microbes. Microbes, students. So what do we do here, students? Understand here. From this bottom part, we send some amount of bacteria again to the aeration tank. This same concept applies in your curd making also. What do you do, students? We have a milk here. We take a small amount of curd and put into a milk. Next day, the entire milk is converted to curd because of we are adding bacteria as an inoculum there. Same concept here. Here in aeration tank, we have a lot of waste material here. So some amount of bacteria is again added back here. That is activated sludge is added back here. Now, after settling tank, what happens? Remaining part is sent to the last part. Last part is called as anaerobic sludge digester tank. Now, what happens here is, understand, students, in the last tank, what are we doing? We are removing all the oxygen. Done. Now, if I remove all the oxygen, students, what happens? All the aerobic bacteria will die now. Entire aerobic bacteria is dead, gone. Every single aerobic bacteria is also gone now. So, what is remaining, students? The remaining part is going to be all the anaerobic bacteria, students. Only anaerobic bacteria will remove. Now, you tell me, students, in the chat, do I even need to treat? Do I even need to treat the anaerobic bacteria? Not required. Imagine if I remove this waste into water body directly. Obviously, when this anaerobic bacteria, when it comes in contact with the air in the water, oxygen in the water, it will automatically die. It will automatically die anyway. So we don't have to treat this. We don't have to treat this. So we have to kill only aerobic bacteria. And students, do you realize how evil we are? Yes, we are very evil because we are using the bacteria to remove the organic matter. After the work is done, we kill the bacteria also. So what are we doing here is that we are using bacteria to remove the organic matter. Once the work is done, we kill them. Okay, just like Taj Mahal. So, okay. Now, students, what happens is that now here what happens is we also use them. We initially what happens in the anaerobic sludge digester, all the anaerobic bacteria will give you biogas also. Biogas. So what is happening, students, here? First, filtration, sequential filtration happens, physical, sedimentation, physical happens here, aeration tank, all the BOD comes down here, settling tank, some amount is sent back, remaining sent here. In anaerobic sludge digester, all the CO, all the oxygen is removed here, and remaining anaerobic bacteria is removed as biogas. We get as a biogas also. Remaining everything can be added to the water body also because anaerobic bacteria will die anyway, and that is your entire sewage treatment plant done and dusted, students. Done and dusted. Done and dusted. That's all. And students, remember the same concept applies in your biogas also. Same concept also applies in biogas because this cow dung here, this cow dung has anaerobic bacteria. When we take this cow dung tank, add into a slurry here. Okay. Now in the digester, what happens? All the anaerobic bacteria is giving the biogas. It is taken here. Remaining waste is removed as sludge. Okay. Students, that is the end of microbes. Simple, students. Simple, no? Simple, right, students? Done and dusted. In a very concise manner, I taught you the entire microbes STP better than what is given in textbook. Better than what is given in textbook, students. Then, students, first cut was made obviously by LAB. LAB was present somewhere, no? Then, students, so all of you need to know the entire steps: filtration, filtration tank starting, then settling tank, right? Then we have sedimentation, then we have aeration. Everything you should know. Okay, students, biotech I'm not taking. Now we start with ecology, students. For ecology, students, I'll give you a 5 minutes break and then we'll start ecology. Okay, students, ecology will be over in one hour. Then, students, can we take a snacks break? 5 minutes break. All of you. Why Hokkaido? Students, how many of you love ecology? How many of you love ecology? I love ecology. Ecology is beautiful. In ecology, I will tell you stories. In ecology, I will tell you stories, students. Okay. Start 2 p.m. will start. 2 p.m. will start, student. 2 p.m. will start. 2 a.m. not 2 p.m. Sorry. 2 a.m. I can't believe I'm telling you. We'll start by 2 a.m. ecology. Okay. Okay, students. Students, I love ecology. I'll tell you stories and I'll tell you a lot of stories now. I will tell you a lot of stories, students. Exactly, students. Protein goal is very important in your life. If any goal is not reaching, it's fine, but protein goal has to be reached every single day. 60 grams of protein every single day, students. 60 grams of protein every single day. Whatever happens. Okay. So class resume at 2 a.m. I'll come back. 3 chapters, 1.5 hours. I'll tell you what main important points. We'll finish it. Okay? Okay. Ecology right now, students. Hello, 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 hello. All of you, welcome back. Students, all of you, welcome back. Hello, everyone. Hello, everyone, students. Hello. Yeah, hola, hola. Students, the first chapter which we'll be dealing with organism and population, very easy chapter. I'll finish the chapter in 30 minutes. Let's go. Okay. The first thing which you need to know is what is ecology, students. Ecology is nothing but study of interaction among organisms. For example, bio biotic component interaction, biotic with abiotic competition interaction. Okay, interaction with each other and organisms and their physical environment. So there can be two types of interaction: biotic interaction, biotic and biotic interaction, or biotic and abiotic interaction, biotic and abiotic interaction. This is called as ecology. This is called as ecology. Interaction being between the biotic or biotic abiotic interaction. That is called as ecology, students. Now, in ecology, students, there are multiple levels of biological organization. There is, starting off with, we have something called as organism, a single level. Then we have population, community, ecosystem, biomes, and biosphere. So this is called as your population, where entire ecology can be divided into multiple different levels. Okay. Now, what is a habitat? Now, students, some of you might still get confused between what is a habitat and what is a niche. Tell me yes or no. Friends, tell me yes or no, chat. Some of you might confuse between what is a habitat, what is a niche. This confusion might be in your head. But let me make it very clear to all of you, students. Let me give a quick example. Am I audible right now? Students, am I audible right now, students? Am I audible right now? Okay. Now, what is a niche? Niche is nothing but the where you work. Niche is something where you work and your house becomes a habitat. Habitat. For example, you are staying right now in your house, that is a habitat. The way you go to school, you go to college, that becomes a niche. So niche is the work of an organism in an environment. For example, this is a frog here. The frog has a work here and its habitat is different. Niche and habitat can be the same place also sometimes. Okay. Okay. Now, students. Now, introduction to population. What is a population, students? Population is nothing but a group of organisms, right? Population thing, students, a group of organisms which are in a group and all of them belong to same species. Can you see? Same species, cow, cow, cow. Here we have goats, we have tigers here. This is a population. This is a population right here, students. Okay. Population is a total number of interbreeding individuals of a same species found in a particular geographical area, sharing and competing for the same resource. See, all of these chimpanzees belong to the same species. They can interbreed among each other and they are found in a one specific location. That is called as a population. This is a, students, this right here is a definition of a population. This is right here is a definition of a population. Organisms, same species, interbreeding in a same geographical area, that is called as population, students. Okay, living in a well-defined area, competing for the same resource, sharing the resources, potentially interbreeding. That is a population. That is a population. Even the students, even the asexual reproduction can also be included in the population, because for the sake of it, for the sake of it, for the sake of it. Okay, for the sake of it. Now, students, now understand. Next concept you understand, students. Here are the few examples. Lot of trees growing, lotus, right? Multiple cormorants. These are birds, type of birds. These are the examples of population. Examples of population, students. Now we understand something called as population attribute. Now there is something to understand. There is something called as birth rate, death rate, sex ratio, age distribution, and population density. All of them are called as population attributes. So one population has multiple attributes: birth rate, death rate, sex ratio, age distribution, and population density. Now first of all, you need to understand birth rate and death rate. Now here is a simple formula, student. Here is a simple formula for birth rate. Birth rate, the formula is, students, right, newly added divided by initial population. That is the birth rate. Now what is the death rate, students? What is the death rate? Death rate is nothing but number of death divided by initial population. This is called as your birth rate and death rate, students. Birth rate and death rate here. Simple. Now, students, here is the example you see here. See, if in a pond there were 20 lotus plants last year and through reproduction 8 new are added. Okay, what is the birth rate, students? What is the birth rate? You will tell me, sir. Newly added is how much? Newly added is 8. Newly added is 8. 8 divided by initial population, students. What is the initial population? Initial population is 20 last year. So 8 divided by 20. 8 divided by 20, students. Done, students. Now all of you need to understand next concepts here. I'll ask you one more thing. Let's take there are 100 tigers in 2021. By the time we come to students, 2025, this 100 tigers have become 200 tigers. 200 tigers. Okay. Find the birth rate. Go. What is going to be the birth rate? Who can tell me, students? Who can tell me? What is going to be the birth rate? Quick. So, what is newly added, students? What is the newly added? 200 minus 100 is how much? 200 minus 100 is 100 are newly added. 100 are newly added, students, here. And initial population is 100. 100 divided by 100 is the answer. 100 divided by 100 is the answer. Simple. Okay. So newly added is going to be 200 minus 100 is the newly added, right? That is the newly added here. 200 is the new population right now. But how much is added here? 100 has been added here. That's all. That's all, students. That's all. Understood, students? Understood? Okay. 200 minus 100 is going to be 100. 100 divided by 100. Now, what is the death rate? Okay. Let's take there are 8 Drosophila. 8 Drosophila. Okay. Out of which 4 are dead right now. 4 are dead right now. Out of 8 Drosophila, 4 are dead. What is the death rate, students? What is the death rate right now? Tell me. Tell me quickly in chat. So 8 are dead. Number of death is 4 here. Initial population is 8. 4 divided by 8 is the answer. 4 divided by 8 is the answer. That is the death rate. Done. Now, students. Next thing is called a sex ratio. Sex ratio is the ratio of males to the females in a population. For example, in your class also you might know. Can anyone tell me, students, in your class, how many males were there, how many females were there, students? See, in my MSc, in my master's, right, can any one of you guess how many males were there? We were around 30 students in my class. We were 30 students in my class in my masters. Okay, out of 30 students, only 3 boys. Only 3 boys out of 30. Okay, and I was one of them. Apart from me, there were 2 other boys, and one is in Europe right now, somewhere in Europe, and one is in Tamil Nadu itself. Tamil Nadu. One is in Tamil Nadu right now. Okay, so 3 boys out of 30 students. And the funny part was, many of them used to copy from me only. From these 3 boys. From these 3 boys only, all so many used to copy. I still remember. Like, show me, Baswa. I'm like, I don't want to show. Like, show the answer. Okay. Oh, God. Okay, students, that was the ratio here. Okay. So in India, also there is something called a sex ratio here again. In the case of India, what happens? In the case of the entire India, what happens is that females are more here, obviously. Females are less, obviously, here. Okay. And males are more. But this might change in future. You never know. This might change in future. Right. This might change in future. Who knows? Right. No. Next is called as age distribution. See, this is called as sex ratio done. What is age distribution? In age distribution, we have something called as your pre-reproductive, reproductive, post-reproductive. 3 types are there. 3 types of students. 3 types is there. Okay. Students, all of you remember I told you, right? Out of the 3 boys, one guy name was Amman in that. Amman was one more boy. Amman was one guy in that. Okay. And this was the same Amman we used to make fun of. Lemon guy. Lemon. Okay. Lemon guy. Okay. Exactly. Amman was one of them. Lemon guy. Okay. Now, there are 3 things here. Now, we can have 3 types of population based on age distribution. The first one is called as expanding here. In expanding, can all of you see, students, pre-reproductive is more than reproductive. Reproductive is more than post-reproductive. Such type of population can be seen in your developing countries. Developing countries. Example, students, in the chat, all of you. Example is our India, developing country. Right? Developing country, students. Next, stable population. Here, students, you can see a pyramid shape. Here you can see a pyramid shape right here, pyramid shape. Now, here in the case of stable, we can see a type of your bell shape, bell shape here. Now, here you can notice, students, the below part, pre-reproductive is almost equal to reproductive here. Pre-reproductive is almost equal to reproductive, but both of them are more than post-reproductive. Both are reproductive. And such is seen in the case of developed countries. Quickly, students, example in the chat. Example is USA, Canada, Europe, many of the European countries, students. Okay. Now, students, what is decline in declining population? It is said to be urn shape here. Okay. Now, here you can see, students, here what happens is that reproductive is always more here, and pre-reproductive as well as post-reproductive both are comparatively less. Such is seen in the case of your war countries or even in the case of Japan. In the case of Japan. Okay. In the case of Japan, students. Then, students, don't like that. Hopefully, someday India can become a developed country, students. Okay. That is your different types of your populations. Okay. Then, what is population density? Students, I'll give you a quick example. Understand, students. Okay. I'll give you a quick example. What is population density? Understand, students. Understand. Okay. Let's take, I have here one school A, school B. This is school A and this is school B. Now, both of them are, let's say, area is this much. They have very good area here. That is the area of these two, students. Area of these two. Okay. Now, students, all of you need to understand here is that in this school A, let's say there are 25 students. 25 students are here. In school B, we have 2,500 students. Now, students, tell me in the chat right now. Students, tell me in the chat right now. Which of the following school population density is higher? School B. Here, what happens here? Every student here, right? One student in per class. Per class, one student can be sitting here. Per class, one student can be sitting here. But in this case, congested. It's like when everyone sitting next to each other. No space only. No space only here. Okay. So population density is very high here. Very high. And population density is represented by, population density, students, is represented by N. It is represented by N right now. N, students. So your school B has very high population density, students. Okay. Now students, a population density can change. It can change based on something called as natality, mortality, immigration, emigration. Natality means what? Natality means birth. Mortality means death. Okay, means death. Death here. What is immigration? Coming into the population. What is emigration? E for emigration, E for exit. It is exiting the population. Okay. See here, students. See this. See here. Whenever there is birth rate, population density increases. Immigration, population density increases. Death rate, population density decrease. Emigration, population density decrease again. That is called as population dynamics. Done, students. See here. Done, students. Done. All of you understanding? All of you understanding, students? How the population density change? Done, students? Done. Any doubt here? Any doubt here, students? Any doubt here? Okay. One question to all of you, students. When will the population increase? Population will increase or mainly when, students? Okay. When natality is more than mortality, immigration is more than emigration. Basically, in these two conditions, population density will increase. Population density will increase, students. Okay. Now, under normal conditions, birth and death are the most important factors. Obviously, birth and death are more important factors, students. Birth and death are the most important factors. Okay. Now, students, important factors influencing population density. Under two factors assuming importance only in special condition. What is special condition? For instance, if a new habitat is just being colonized, colonized, immigration may contribute more significant to population density. For example, students, let's take, this is India right now. Okay. Now here, let's say we have a new country. New country here. New country name is Bot Army. Okay. New country name is Bot Army here, students. Now, how can this country population increase very, very high? Birth rate will not make a function there. Birth rate will not give that much of importance or that much of increase in population dynamics. What will happen, students, is that if there is more immigration, whenever there is more immigration, population density will increase more faster there. So when you have to colonize a new area, immigration plays a major role there. Immigration plays a major role there, students. Clear? Clear, students. Okay. Now, students, now that is called as your population dynamics. Entire thing is called as population. So we finished something called as your birth rate, death rate, sex ratio, age distribution, and then population density. All the following concepts is done right now. All the following concept is done right now, students. Done. Now, students, we come to one more concept called as students, the population growth curve. Now, students, I want one volunteer right now. I need one volunteer. Who can come? I will take Pramod. Let's take Pramod only. Okay. Let's take Pramod right now. Okay. Now, understand, students. Let's take Pramod's birthday is coming. Let's take Pramod's birthday is coming very close by. Okay. And he will go to his dad and ask, Dad, I want money. Dad will be like, take unlimited money and go enjoy. Okay. So in such a case, Pramod will call the entire NEET English. Entire NEET English he will call. Okay. And he'll give everyone party, full party. Now, is there a limit to how many members he can call? No, because he has unlimited money. Now, same scenario happens in nature. For example, in nature, there are 250 rabbits in one area. This 250 rabbits has unlimited food and unlimited space. Now, tell me, students, in the chat right now, will the rabbit population increase or decrease? Tell me, students, in the chat, will the population of the rabbits increase or decrease? You will tell me, sir, population of rabbits will keep on increasing. This is called as J-shaped curve. Population will keep on increasing and we get the J-shaped curve, and such a growth where there is no limits. no limits, that is called as exponential growth. Exponential growth. No limit is here. No limit. No limit is called as exponential growth. Here we have dm is equal to Rn. What is R here, students? R is nothing but intrinsic rate of natural increase. Now, I will take one more example. Let's take Abhinaya. Let's take Abhinaya, students. Abhinaya. Okay. Now, Abhinaya, she'll also go, she or he, I don't know, students. Okay. I don't know who it's he or John. Let's take John, students. John is very easy. Okay. Now, John is going to ask dad. John is like, dad, give me some money. Dad is like, first you clear NEET, then I'll give you money. But later on, if John will keep on asking, sir, dad, it's a little bit of money you give me. Dad is like, go take 20 rupees. Not 20 rupees too less. Dad is like, go take 100 rupees and do party. Now, friends, you tell me in the chat, with that 100 rupees, can the John give treat to everyone in the group? Not possible. Now, what does John has to do? John will do something called as selective treat. He will not give treat to everyone. He will give treat to only few people. He will go and buy them egg puffs. Egg puffs. Done. Okay. Now, same thing is happening here in the case here. Now, students, understand, students, there is a population here. Now, this population has limited resources. This population has, students, what? Limit. They have limited resources. Limited resources, students. Now, that is called as carrying capacity or K. K. So, whenever there is a limited resources, whenever there is a limited resource, students, the population cannot increase after a certain time. Such a type of growth is called as what, students? Logistic growth. Logistic growth. In the case of logistic growth, students, there is a simple pattern here, and the graph is called a sigmoid graph. Sigmoid graph here, students. Here we can see initial, we can see a lag phase, then we can see a exponential log phase or exponential phase, and then we can see a asymptote here. Then we can see a asymptote here. The population will not increase after this carrying capacity. So in the nature also, resources are generally limited. So you tell me, students, in the chat right now, which of these two growth models is more realistic in nature? Tell me in the chat, students. Which of these two growth models which is more realistic in nature? You will tell me, sir, in the chat right now. So the more realistic is always logistic. It is more realistic because in nature we cannot have unlimited resources. Not possible at all. Not possible. So realistic growth. Here we have that, students, remember this part also. dm is equal to Rn K minus N by K. K is called as carrying capacity here. And with that, concept is done. Students, all of you understood? Students, all of you understood the difference? John took it from pocket, Kalla John. Then, students, okay. Students, remember, the R value can change here. The R value can change depending upon the location also. Okay. That is called as intrinsic rate of natural increase. R is called as intrinsic rate of natural increase, students. Now, students, for the exponential growth, there is something called as logistic, right? There is something called as an integral equation. In this integral equation, you need to know what is NT, what is N0, what is R, what is E. This also is a PYQ, student. This also is a PYQ right here. PYQ right here, students. Okay. So any species growing exponentially under unlimited resources condition can reach enormous population in a short period of time. Darwin showed how even a slow growing animal like elephant could reach enormous number in absence of a check. Okay. The following is an anecdote population narrated. Okay. Next concept is called as life history variation. What is life history variation? Understand, very simple. Okay. Life history variation is very, very simple. Understand, students. Understand. Population evolved to maximum their reproductive fitness, also called as Darwin fitness. So every single population will obviously want to reproduce. They want to increase the number. Humans is a good example. Humans always want to make new members. I don't know why. Okay. Now, under a particular set of selection pressure, organisms have evolved towards the most effective reproductive strategy. So every single organism in nature also has some method. There's some method by which the reproduction can happen or progenies can be produced unlimited. Okay. Understand. Some organisms breed only once their lifetime, Pacific salmon fish, bamboo, while other breed multiple times during its lifetime. Birds, mammals, they keep on breeding throughout their lifetime. Throughout their lifetime, they keep on breeding. I don't know why again. One is more, they can't believe one is more, one is enough. They're like, minimum cricket team I want to make. Okay, that is the group here. Okay, so that is a strategy. That becomes a strategy. So if I have 10 kids, one will become successful. So they see a ratio there. They see a ratio. If 10 kids are there, even if one becomes successful out of 10, very happy. Okay, so that is called as life history variation. Now, some produce large number of small-sized offsprings, oysters, pelagic fishes, while other produces a small number of large-sized offspring, birds, mammals. Say in the case of humans, a single baby is born. A single baby has all the nutrition, all the development, all the resources for one baby itself. But in the case of your cat or dog, in the case of your cat and dog, what happens? Multiple kittens, multiple puppies. Okay, no, this thing only. Okay, so which is desirable? So tell me which is better. More offspring is better, obviously. Better. Okay, so ecologists suggest that life history traits of an organism have evolved in relation to the constraints imposed by abiotic and biotic components. So based on what is present on outside environment, the animals are evolving to increase their reproductive fitness by some or the other method. That is called as life history variation. Done, students? Done or not? Tell me in the chat. Done? All of you? Done, students? It's that simple. It is that simple. Ecology is that simple. Okay, ecology is that simple. Okay. No, students. Now, what is population interaction? Population interaction, students, what I am doing right now is population interaction. I am interacting with you. Two biotic components interacting with each other is called as population interaction. Done, students? Done. That is called as population interaction. Okay. Now, here we have multiple types: predation, parasitism, mutualism, competition, commensalism, amensalism. Now, students, here you should know what is good, what is bad. Okay, good, bad, bad. That's all. Okay, that's all you need to know, students. Okay. Yeah. That's what understand here. Predation means what? Plus minus, obviously. Competition, minus minus. No one is winning here. Okay. Parasitism, plus minus. Commensalism, plus zero. One is benefited, one doesn't care at all. A mutualism, both are benefited. Amensalism are the evil people. They will not let you grow also. They will also not grow. So, okay. So, minus zero, students, minus zero. Okay. Now, students, let's understand predation. What exactly happens, students, in the case of predation? In the case of predation, what happens is one organism is eating other organism. That is a predation. Students, tell me in the chat. This is also predation. Yes, this is also predation. One sparrow eating a seed is also predation. This lioness eating this deer is also predation. Both are examples of predation, students. Okay. Everything is predation. Okay. Now, students, here we need to understand. Here we need to understand something called as what do we get from, what do we learn from predators? Do we even learn something? Yes, we learn something. So what do we learn from predation? Understand right now. Ready, all of you? Ready? What do we understand from predation? Ready, all of you? What do we understand from predation? First of all, predators, first point right here. First point, predators act as a conducts of energy transfer. Conducts of energy. What do you mean by that? Let's say we have a plant. Plant is eaten by a grasshopper. Grasshopper is eaten by a frog. Frog is eaten by a snake. Now, what is happening, students? Because of predation, what is happening? Energy is being transferred to the next trophic level. Energy is being transferred to the next trophic level. That's all. That's all is called as they act as energy transfer. Second point, understand, students. Second point, you understand. They keep the prey population under control. They keep the prey population under control, students. What happens? Understand. Now, all of you tell me in the chat, students. what will happen if this grasshopper, if this frog completely disappears? Tell me what happens. If this frog population disappears completely, what might happen? If there is no frog, this grasshopper population is increasing. So this frog was keeping this grasshopper in check. You're like, bro, keep quiet. But since frog is missing now, grasshopper population will increase so much. If grasshopper is increasing, what happens? Plant will decrease because more grasshoppers, less plant. Okay. No frog, snake population will decrease. It will decrease, and that's how entire population is collapsing. Entire ecosystem will collapse. Gone case. Okay. Next point. Next point here. Now, when certain exotic species are introduced into geographical area, they become invasive and start spreading fast because of the invaders. Land does not have any natural predator, students. Again, it's a quick example. I'll give you a quick example. Let's say I'll give you an example. Let's say we have Mexico here, and let's say India here. Now, let's say take in Mexico, I have a frog. This frog is we are bringing to India. Now this frog is coming to India now. Now what happens, students, in Mexico is that this frog is eaten by a snake generally here. But this snake is missing here. Now what will happen, students? Tell me in the chat now. What will happen? Tell me, students, what will happen now? All of you. Obviously, students, in India, if the snake is not present here, the frog population will go high. Will go high. So what is the solution, students? What is the solution? The solution is very simple. When you're trying to bring the frog, bring the snake also. Bring the snake also. So this is what happens in nature also. When alien species is coming, their population goes very high because no one is able to keep a check on them. So what do you need to do? You bring the predator also. Such a case also happened in reality. Okay. Prickly pear cactus, PPC, introduced in Australia in the early 1920s, caused havoc, full destruction, okay, by spreading rapidly in millions of hectares of land. Finally, the invasive cactus was brought under control only after a cactus feeding predator, a moth from its natural habitat, was introduced into the country. So similarly, students, frog population increased a lot. So what did we do? We took the snake from here to here also. Same thing happened here. So PPC became very invasive. So we bought the moth also. Then concept, students. Concept done. Concept done, students. Then all of you, concept done. Done, concept. Okay. Now, last point is that, students, biological control method. No. This is not the question. This is the main point here. Predators, fourth point here. Predators also help in maintaining the species diversity in a community. How come? All of you understand, students. All of you watch movies. All of you watch movies. You watch movies. In a movie, what is happening? There is one main don here, one main ultra don here. This ultra don has what, students? He has one left and right hand. Left hand, one manja, one left right hand person is there. So this person has a left hand, one right hand person is there, and he also has a main body also, for example. So he has multiple people under him. Okay. Now, students, what happens? What will happen if this boss dies? What will happen if the boss dies, students? If the main boss dies suddenly, all of them will start to fight among each other, students. Tell me yes or no. All of will be start fighting among each other. Everyone wants to be the main boss now. Everyone wants to be the main boss right now. Okay. So this is what is happening. This is what is happening in the nature also. The main predator is keeping the other small organisms from fighting among each other. Okay. See this. Predators also help in maintaining the species diversity in a community by reducing the intensity of competition. So this predator will make sure there is no competition among them. He is the ultimate boss. Okay. Now there is one example. I'll show you the example here, students. See the example. Okay. In the rocky intertidal communities of American Pacific coast, the starfish, right, Pisaster, is an important predator. So he is the boss here, students. Pisaster is the boss here. He is the main boss here, students. He is the main boss. Okay. He is the main boss here. in a field experiment, when all the starfish were removed from the enclosed intertidal area, more than 10 species of invertebrates became extinct. That is, when the this is the starfish, this is the starfish now, and these are the invertebrates. Now what happens, students, when this starfish completely died? When you remove the starfish, when you completely remove the starfish, what happens? All of these invertebrates, they started fighting among each other and they became extinct. They become extinct. This is an NCERT example. More than 10 species of invertebrates became extinct within a year because of interspecific competition. Because of interspecific competition, they become extinct. Now, students, next concept. They say predators are prudent. What is the meaning of prudent? Understand. Now, let's take you go for shopping. You go for shopping and you buy 10 protein bars. You buy 10 chips packet. You buy 10 bottles of Coca-Cola. Now tell me in the chat, friend, tell me in the chat right now. Do you finish all the protein bars, all the Coca-Cola and all the biscuit packets in one day only? Tell me in the chat, students. Do you finish? Okay. Students, tell me in the chat right now. Do you finish all of them in one go only? Tell me in the chat right now. Do you finish the entire stock in one day? You don't do that. What do you do, students? What do? You make a plan. You make a plan that 1 week I will eat 1 biscuit or 10 biscuit packets. Next week I'll put 10 more biscuit packets. 1 week I will drink 2 bottles of Coca-Cola. Second week I will do next 3 bottles of Coca-Cola. You will plan. You will plan something. Your predators also plan. They also plan. They're like one lion is thinking. Lion is like, if I eat all the deer in 1 month only, I will go hungry throughout the year and I'll die. So what does lion will do? Lion will plan accordingly. Lion will eat only 1 deer per week, and lion will wait until other deers also reproduce and increase in number. So lion is also like you only. It is planning properly. Okay, that is called as, student, that is called as prudent. Means planning. Then students, then concept, done. Now that is your predation. Now students, in predation what happens is that some animals are fighting back. They are like, just because you're trying to eat me, I will not stay quiet. Just because you're trying to eat me, I will not stay quiet. I will fight back. This is the fighting back, students. Students, can all of you see the frog here? This is a frog here. This is the fighting back mechanism here. Okay. Some species of insects and frogs have cryptical colored, that is the camouflage here. Other is, some are poisonous in nature. Poisonous. Monarch butterflies, highly distasteful. Taste only is not nice. Taste only is not nice. Taste only is not nice. For example, how many of you like bitter gourd? Raise your hands. How many of you love bitter gourd? You like, sir, taste is not good, I have not eaten it. That is a mechanism. The reason bitter gourd is not tasty because it is a mechanism to escape from predators. Imagine, that is a predator. That is the mechanism by your bitter gourd. Okay. Interestingly, students, a butterfly acquires this. Monarch butterfly acquires this chemical during its caterpillar stage by feeding on poisonous weed. Okay. Mechanisms. Okay. So herbivores are predators. Okay. So plants have different mechanisms here. Okay. No. Plants therefore have evolved for astonishing you. They can produce thorns, they can produce spines and everything. Okay. See, thorns and acacia, spines in cactus. All of these are escaping mechanism. Okay. One more example is Calotropis also, students. Calotropis also does what? Poisonous cardiac glycoside also it produces to escape here. See here. No. They can be nicotine, alkaloids, opium. All of these are different mechanisms to stop the predation. Okay. That is predation, students. Now what is competition? Competition is when the two organisms are fighting among each other. Okay. It can be intraspecific, means within the species, or interspecific, different species fighting among each other. Okay. No. Then there is something called as survival of fittest. All of you know that. When Darwin spoke of struggle for existence on survival of fittest, he was convinced that interspecific competition is potent force for organic evolution. For example, students, whenever there is competition, what happens? Whenever there is competition, one organism wants to win. One wants to win. So whoever wants to win, right? They will put more effort. They will evolve themselves. So whenever there is a competition, it can lead to evolution. It can lead to evolution, students. It can lead to evolution. Okay. Now, it is generally believed that competition occurs when closely related species compete for the same resource. For example, I'll give you a quick example. Let's take a chips pack. Let's take I bought a Oreo biscuit packet in my house. This Oreo biscuit packet, students, my sister and I, both of us will fight for the same biscuit packet. My sister and I, both of us will fight for the same biscuit packet. Okay? Because same species compete for same resource. But it is not true. It is not true, students. Let's take my friend is coming to my house. Let's take my friend also is coming to my house now. Now my friend and I, we are not related by blood. Okay. But is there a competition between me and my friend also for the same biscuit packet? Yes, there is. Yes, there is a competition. He also wants it. I also want it. Even though it is in my house, he wants my biscuit packet here. So what happens is that in nature, unrelated species, two species which are not related also, they can also fight among each other. They can also fight among each other. Okay. Some shallow South American lakes visiting flamingo and resident fishes compete for the common food. See, flamingo and fishes, they are not related, but they also fight for the same resource. Same resource. Okay. Now, next concept, students. Resource need not be limiting for the competition to occur. For example, even if there is one biscuit, forget packet, students. Even if there is one biscuit, right? My sister and I will still fight with each other. Okay, we'll still fight. Okay, in interspecific competition, the feeding efficiency of one species might be reduced due to the interfering of inhibitory presence of other species. Okay. Now, students. Now, what is called as Gauss hypothesis principle? Gauss exclusion principle. Understand? When two species are competing for the same resource, me and my sister, both are competing for the same resource. Me and my sister, both of us are competing for the same resource. Whoever is faster, stronger, sharper will get the biscuit packet. Yes or no? So I will get the biscuit packet. She will not get anything. So what happens in the nature also, when the two species are competing with each other, one which is superior will all get all the nutrients, will get all the food, and will survive. One which is not getting anything, he will die eventually. Okay. Now see here, one example is given here. Albinon tortoise in Galapagos Island became extinct. This tortoise became extinct. Stupid tortoise became extinct here. Okay. Within a decade after, goats were introduced. Why? Because this goat was able to feed very well. It is eating very well. So it survived. This tortoise did not survive. Okay. Now, friends, what is competitive release? Understand what is competitive release. What is competitive release? You understand. Okay. Understand, friends, what is competitive release. Okay. Let's take one area here. In this area, I have one organism here. Let's say I have an area here, students. This is one area. Okay. In this area, let's say this much. Okay. Let's take here I have one organism A. Here we have one organism A is here. One organism B is growing in this much area. Now, students, tell me in the chat which organism has more area here. Tell me, students. Students, it's not a story, it's reality. That is not a story, and that's a reality, students. It's a reality, not story. Okay. Tell me, which organism has more area here? B has more area here. Why? Because, students, why? Because A organism is not able to grow. Why? Because whenever the B is here, A is not able to grow here. That is, a species whose distribution is restricted. A distribution is restricted to a small geographical area. Small geographical area. Why? Because of presence of competitively superior species. Here what happens is that his aura is more here. B is superior here. Just because B is present here, student, just because B is present here, right, it is not allowing A to grow here. Allowing not A to grow here. Okay. Now, is found to expand here, right? Is found to expand the distribution range dramatically when the competing species is experimentally removed. Now, students, understand what happens. What will happen if I remove B now? What will happen, students, if I completely remove the B? If I completely remove the B, what happens? If I remove the B, then this A will expand everywhere. This A will expand everywhere. That is called as competitive release. If you remove the one component, if you remove the one species, superior species, this will expand. That is called as competitive release, students. Competitive release. Here is an example here. Catalamus and Balanus species. Okay, Balanus is growing everywhere here. Catalamus is going on top here. This species is not able to grow here. Why? Because Balanus is superior here. Okay, Balanus is superior, dominates the internal region and excludes the small part. It is more superior. It is able to grow everywhere. Now, what is resource partitioning? Resource partitioning is very simple. Okay, resource partitioning is very simple, students. Let's take same biscuit packet here. Sister and I, we don't want to fight right now. What do? My mom will come. She will tell 3 biscuit for you, 3 biscuit for my sister. They are dividing the resource here. That is called as resource partitioning. Resource partitioning is Resource partitioning is a concept where we divide the resources to avoid competition. To avoid competition, students. Here's an example. Okay, here's an example here. MacArthur's wobbler example. All the birds are on the same tree, but they are feeding from different region. Now, what is parasitism, students? Parasitism, all of you know. I'll skip this, students. Parasitism, all of you know, right? Ectoparasite, endoparasite. Okay, ectoparasite on the outside, endoparasite on the inside. This is very important. This is also a PYQ right here. This also is a PYQ right here, students. Adaptation to parasite. When a parasite, what has to do for adaptation? Okay. Now, there is something called as your life cycle of parasite also sometimes. Example is liver fluke. Liver fluke actually has 2 hosts. Human liver fluke parasite depends on 2 intermediate hosts. One is going to be your snail, one is going to be a fish. 2 hosts it can depend. This also is a PYQ. Malaria, this I don't have to teach you again. This is called as ectoparasite on the outside. Here also copypods, ectoparasite. Cuscuta, ectoparasite. Endoparasite, the tapeworms, which is present on the inside. This is very important. Called as brood parasitism. Students. Understand what is that, students? Okay. Students, understand what is going to be brood parasitism. Here what happens is, students, I feel ecology is too much now. Ecology is not getting over only. Okay. In brood parasitism, what happens is, students, let's take this, all of these 1, 2, 3, 4 eggs. This belongs to crow. Here. Crow egg. Okay. Crow egg, students. Black crow eggs. Now, what exactly happens, students? What exactly happens here in the brood parasitism is that this one bird will silently go and lay the egg here in this particular nest here. Silently go. And this crow will not be able to understand where is the extra egg coming from, because this crow cannot tell which is his egg and which is the other egg, which is her egg and which is the other egg here. So, okay. So, he cannot tell which one is whose egg right now. Which one is whose egg we cannot tell at all. That is called the brood parasitism. Bird laying egg is in the rest of other birds. Host bird, owner of the nest, is then responsible for raising the feeding the parasitic bird chick also. So this bird has to now take care of this chick also, this bird's chick. Okay, that is brood parasitism. Now what is commensalism? In commensalism, what happens? In the case of commensalism, there are two species are there. One species is benefited, other species doesn't even care. One species which is benefiting, right, that is generally the important one here. For example, here orchid and mango. Orchid is benefited here, mango doesn't care. Barnacles on the whale. Barnacles is benefited, whale doesn't care. See the egret and on the cow. Egret is going to be benefited, cow doesn't care at all. Okay. Sea anemone and clownfish. Clownfish is benefited, the anemone doesn't care at all. Okay. So that is your entire. That is your entire. Okay. That is called as commensalism. Now what exactly happens in mutualism, students? Understand. In the case of mutualism, what is happening is, right, both species are benefited here. Both species are benefited here. Okay. Both are benefited here. One example is one example is lichen. In the case of lichen, what is happening, students? In the case of lichen, both are benefited. Algae and fungus. Algae is producing food. Fungus is giving a shelter. So they have a symbiotic association. Okay. Now, other example is mycorrhiza and the trees here. Mycorrhiza doing what? Mycorrhiza is helping in absorption. Okay. Mycorrhiza is getting a food here. Tree is providing the food here. Okay. Fungus helps in plant to absorb essential nutrients. That's the main work of fungus, right? Plant in turn provides fungus with energy yielding carbohydrates. So plant is giving the food, fungus is helping in absorption. Mutualism. Okay. No. Other example in the case of your butterfly. Other example is in the case of your butterfly as well as your butterfly and the flower. Flower is giving your reward mechanism. Flower is giving pollen, nectar, and butterfly is doing what? Butterfly is helping in pollination. Butterfly is helping in pollination, students. Okay, reward mechanism. Same thing happens in fig and wasp also. What is happening is, students? Wasp is getting a place to lay the eggs here. Wasp is laying the eggs in the fig, and fig is getting pollinated. Fig is getting pollinated, students. Fig is getting pollinated. Okay, that is the mechanism, students. Mutualism, one-to-one relationship. Sometimes it can be so specific also. So specific also. Now, this is called a sexual deceit round. This is called a sexual deceit. Here, what happens is that this honeybee thinks it is a female honeybee and it will start to pseudocopulate. Okay, when the same honeybee goes somewhere else also, copulates, what happens? Pollination takes place. Pollination takes place, students. That is called as pseudocopulation. Okay. That is called, students, pseudocopulation. Done, students? Done. That happens in the Mediterranean orchids. Mediterranean orchid ophrys. So this honeybee thinks that it is a female bee, but it is not a female bee. Full scam it is happening. So when this female goes somewhere else, pollination happens. So plant is basically being very smart here. Plant is being very smart here, students. Okay. And students, that is the end of chapter. That is the end of chapter, students. 3 o'clock already done, students. Oh my god, 3 o'clock is over. Now, students, I will tell you the most important points which you need to study in ecosystem. I will not go in detail right now. Okay, I'll tell you what you need to study here. I will teach you the entire ecology one shot later on, next week. Okay, next week something is coming fast. Next week something is coming. I will do one shot of your ecology, one shot of your plant physiology. Yeah, plant physiology, one shot. Okay, now I'll tell you, students, what you need to, because I know all of you, many of you are very sleepy right now. Okay, now if I go again, if I teach you the entire detail, it'll go two more hours, it'll take minimum. Okay, so now I'll teach you what is the most important points in ecology. Okay, so in ecosystem, here, students, in ecosystem, you need to know something called as this. All of you know, right? What is natural, what is man-made, all of you know. Learn what is stratification. Stratification is nothing but vertical distribution of plants. This all of you know. What is consumer, producer, decompose, all of you know. One ecosystem has 4 main pillars. In examination they can give you. In examination they can give you any one they can remove, and they will ask you which one is missing. Let's take, here I will remove this, here I will remove this, and I'll write pollution here, or population. Alright, population here. Then they will ask you which of the following is not a functional unit of ecosystem. They can give you like this, and they can ask you what is not a functional ecosystem. Students, here they can ask you the productivity definition. They can ask you. See, they can ask you this definition. They can ask you this definition. They can ask you, students. They can ask you definition of productivity. They can ask you what is GPP, NPP. They can ask you. GPP is the students. GPP is the gross primary productivity, which is produced by the plants. Produced by the plants. Now, when plant produce GPP, students, plant will use some of it, and GPP minus R is called as NPP, net primary productivity. Now, this NPP, students, this NPP is available for humans, for consumers in general. What is secondary productive, students? If this NPP is eaten by a rabbit, now rabbit is producing some biomass. If rabbit is producing a biomass, that is called as what? Secondary productivity. That is called as, students, secondary productivity. Students, here I have told you multiple times, I have told you, students, decomposition is very, very, very important. Every single step is very important here. Okay, every single step is very important. Okay, here they can ask, students, here they can also ask you this also. They can ask you this concept also. Here PYQs are multiple PYQs have come from here. Properties of humus. Now students, they can also ask you factors affecting decomposition. See, snow, it will become less, temperature, it will become faster, high temperature. If there is lack of oxygen, very slow, more oxygen, it will become fast, decomposition. If it is made up of chitin, very slow. If it is made up of lignin, also very slow. Okay, if it is made up of sugar, nitrogen, fast it happens. It happens fast. Students, energy flow, here they can ask you, students, what is PR? PR is called as photosynthetically active radiation. Now, students, out of the total sunlight, 50% is called as PAR. What do you mean by PAR? PAR means, students, it is in the range of 400 to 700 nanometer. This region is called as PAR region. It's called as 400 to 700 is called as PAR region, students. PAR region. Out of this entire PAR region, students, plants are using how much? Out of this 50%, plants are using only 10% to 10%. That's all. Okay. Only 2 to 10% is used. So out of this 100%, 50% is PAR. Out of this PAR, students, only 2 to 10% is used by plants. That's all. Photosynthetic organisms are producers, obviously. All organisms are consumers. Herbivores are primary consumer. All the veg people are consumers. Primary carnivores are called as secondary consumer. I'll give you a simple thing, students. Understand. Let's take one grass here. Students. Grass is here. Grass is eaten by grasshopper. Grasshopper is eaten by frog. Frog is eaten by snake right now. Okay. Now I want all of you to understand here is that grass is a producer. Energy is producing. This is eaten by grasshopper, right? Now grasshopper becomes primary consumer. Frog becomes what, students? Secondary consumer. Snake becomes tertiary consumer. This should be clear to all of you. Now, students, understand next. This is producer again, producer. Here primary consumer is actually herbivore. Yes or no? Because it is eating the grass, it's called as herbivore. Herbivore, students. Now this herbivore is eaten by frog. Frog becomes primary consumer. Primary carnivore. Primary carnivore. Snake becomes secondary carnivore. Secondary carnivore. Okay. Now this is first trophic level, second trophic level, third trophic level, and fourth trophic level. Okay. Now in examination, how they can ask you question? In examination, they can ask you, students, let's say at grass we have 10,000 kilojoules of energy. How much of energy is present? How much of energy is present, let's say, at this is the thing. How much of energy is present at secondary consumer level? Tell me the answer. Tell me the answer, students. Tell me the answer. Students, ask me, students, in the chat quickly. 10,000 kilojoules of energy is present at a grass. How much is present at a consumer level? How much of energy is present at secondary consumer level? Okay. Quick, students, quick. How much of energy is present at your secondary consumer level? Secondary carnivore level. Now, students, when you get such questions, I'll tell you a small trick here. Okay. I'll tell you a small trick here, students. Small trick here. Okay. You can draw something like this. Here, all of you should know, students. Secondary consumer is going to be who, students, here? Let's say this is a question we asked. Students, trick is not coming to my mind. Okay. Let's say, students, they have not given you any of this. Let's say they have not given you any of this. Okay. They have not given you any of it. Okay. Now I'll change the question. Okay. You know only this much. How much of energy is present at third tropic level? How much of energy is present at third tropic level? What is the answer, students? Now, here is a simple trick here. Okay. If you know the carnivore, which carnivore is it? Take it as n here. Take the carnivore as a n. So always remember, students, your consumer level is going to be n plus 1. N plus 1, students. N plus 1. Tropic level is going to be n plus 2. N plus 2. So right now they have given you, students. They have given you, okay, they're asking you on third tropic level what is present. Okay, third tropic level what is present, students. Okay, and we know they have given you an question. They have given you frog is a students. Frog is a primary carnivore. Frog is a primary carnivore. Okay, if frog is a primary carnivore, what happens? Understand. If let's say n is equal to now 1 right now. Okay, n is equal to be 1 right now. So tropic level, the question is asking you third tropic level. Tropic level is going to be what? 1 plus 2. That is third tropic level. Understood, students? Third tropic level. So if they are asking you such question, this you can be used. Sometimes it can be used. Right? If it is not there, this generally they will not ask you. This is a small trick which you usually use, but they generally such questions have not been observed right now. But now it's very easy right now. Okay. Now it's very easy. Now, first tropic level, second tropic level, third tropic level. Here we have, let's say, 1000 joules. What happens here? Here, how much do we have? Here we'll have 100. Here we'll have 10. That's all. 10 is the answer. 10 is the answer, students. 10 is the answer. Okay. Now I'll ask you one more question, students. I'll ask you one more question. Let's take at frog, we have 10 joules of energy. How much is present at grass? Who can tell me? 10 joules of energy present in the frog. How much is present in grass? If 10 joules are present in frog, now you have to go ulta now. Okay. When we go this side, we decrease. This side we go increase. So here what do we have? Here we have 100. Here we'll have 1000. Simple as that. Simple as that, students. Okay. What about snake? Snake will be 1 joule. So as we go this side, we decrease. As we go this side, we increase. Food chain, food web, food chain is linear always, students. Remember, food chain is linear always. Grazing food chain, land generally. This is a grazing food chain, land chain. Okay. One second, students, 1 second. This is also grading food chain. Okay. So whenever we have on land and water, we have grazing food chain. The other type of food chain is called as what? The other type of food chain is called as detritus food chain, which is happening because of decomposers. Grazing food chain and detritus food chain. Trophic level I already told you, students. 10% already done. DFC, detritus food chain, dead organisms. Okay, DFC. Here it starts from decomposers. Okay. What is food web, students? The food web is nothing but students, grazing food chain as well as the DFC. When GFC, DFC, they enter among each other. That is a food web. Okay. And food web is much more realistic in nature. Can you see? Here we have DFC also. So when you detritus food chain and grazing food chain, they intermix among each other, we get a food web. Students. What is standing crop, students? Standing crop is nothing but every single trophic level will have something called as some living matter or living biomass, that is called a standing crop. For example, grasshopper to snake to, let's say, grasshopper, frog and all, every single trophic level will have some nutrients, right? That is called as standing crop. Students, in ecological pyramids, we have three main ecological pyramids. Okay. The first one is called as, students, here. This is pyramid of number. First one is pyramid of biomass. Students, remember always, this is the main point here. Pyramid of biomass can be inverted also. Pyramid of biomass can be inverted in the case of when it can be inverted in the case of your aquatic ecosystem. Why? Because in the case of aquatic ecosystem, what happens? The biomass of fish is generally higher, and zooplankton's biomass is very less. And because zooplankton life cycle is also very less, and they die also very fast. Okay, so zooplankton's biomass is very less, fish's biomass is more here. Okay, pyramid of number. This is pyramid of energy. Pyramid of energy is always upright. Pyramid of number can also be inverted. Let me show you. See here, students. See here. First paragraph you see here, students. Here. Pyramid of biomass is generally inverted in the aquatic ecosystem. Okay. Pyramid of number here. Let's say we have one big tree. Here. If you count the number of insects, this is the insect here. Number of insects on one tree. Okay. On one tree we have many insects, so it becomes inverted. So pyramid of number can also become inverted here, because first trophic level, second trophic level, right? So first trophic level, what do we have? One tree where you have multiple insects on that one tree. And let's say we have some birds also. on it. So it becomes inverted also. So pyramid of number can be inverted, pyramid of biomass can also be inverted, but pyramid of energy is always upright. Okay. Now this is very important. Limitations of ecological pyramids. Does not account for same species belong to more than one eutropic level. Let's take one mouse. Mouse can be in your primary consumer and secondary consumer also sometimes. If the mouse is eating the grains, primary consumer. If the mouse is eating a cockroach, secondary consumer. Okay. Does not accommodate food web here. No place for saprophytes here. Not there. That is the entire chapter done and dusted, students. That is the entire chapter done and dusted. See, pyramid of number has drawbacks. Pyramid of number where big T example, it can be inverted. Pyramid of biomass can be inverted by pyramid of biomass can be inverted in the aquatic ecosystem. Only pyramid of energy is always upright. Remember that much, you are more than enough. Okay. Now students, biodiversity and conservation, again very important. Now students, you tell me in the chat right now. Let's say one alien is looking at Earth right now. One alien is looking at Earth right now. What do you think what do he think first of all? He will think first of all right now, why is that one teacher teaching at exactly 3 a.m. in the night? The alien will not be able to think comprehend only. And he'll be shocked that some students are even listening to him at 3 a.m. in the night. He'll be shocked. So apart from the students, apart from that, an alien will be shocked by looking at the diversity on Earth. There are so many different types of animals and birds and insects and microbes in our environment, students. Okay, students, look at this. Look at students. Golden tortoise beetle, cucumber beetle, striped beetle. So many different types of beetles are there. See this. There are more than 20,000 species of ants, 28,000 species of your fishes are there. There is something called as snake head fish, yellow box fish. Okay, there are so many different types of your flowers here. So many different types of flowers here. Okay, so students, there is a lot of variety or diversity of organisms on Earth. Now, all of this diversity can be classified into 3 categories. First is called as genetic, second is called as species level, third is called as ecological level. What is the difference you understand? In genetic level, we see the genetic variety. One quick example is going to be the number of different types of mangoes, different types of rice in our country, genetic variety. Now, what is species diversity? Understand. The diversity at species level, for example, Western Ghats have greater amphibian population compared to Eastern Ghats. See here. Western Ghats has more population compared to Eastern Ghats. That is your difference. Okay, that is a difference here. The one more example is given to students. The Raoult vomitaria, this species is different from the other one. Where is the one? One which is growing in Himalayan region might be in terms of potency and concentration of the active chemical aspirin that of the plant produced. Okay. So there is a difference in the plant also from location to location. From location to location, students. Okay. Now, what is ecological diversity? Ecological diversity is very simple. If you go to desert, if you go to Antarctica, if you go to Amazon rainforest, if you come to India, right, you can find every single ecosystem has such a variety of animals. If you go to if you find the type of animals which you find in your in the entire Northeast, West Bengal and everything, and the animals which you find in your Rajasthan, and animals which you find in South India, animals and birds which you found in your in the entire Kashmir is different. Because of the ecosystem, it varies. Okay. See here. These two are different species of your Raoult, where potency can change depending on the area also. Now students, all of this biodiversity has taken millions of years for formation, but all of this can be lost in a fraction of a second. Just like that, everything can be lost also. It can be lost. Okay, so it's very important to save all of them. Very important to save all of them. For example, how many species are there on Earth and how many are there in India? understand. According to IUCN, total number of plant and animal species are described so far are 1.5 million are there. Okay, some estimate say that 20 to 50 million are yet to be discovered also. Okay, so more than 70% of all species recorded on are animals here, while plants, algae, fungi comprise of 22%. So more animals are there compared to plants on earth. Okay, you can see a schematic representation here. You can see, students, generally what happens here, invertebrates, fishes are highest. In the case of invertebrates, insecta is highest. All of you know, right? The largest phylum is what? Arthropoda. Second is mollusca. Can you see second is mollusca here? Okay. Let's see, students. Now, what a challenge for ecologist. Why can't we save all of them? The reason is very simple, because it becomes very difficult to save even the microbes also, because we can't see them. And moreover, students, we have very few taxonomists who are working in this field right now. Okay. Now, for India, what about India? Although India has around 2.5% of world land, out of entire Earth, 2.4% is India. It shares global species diversity of India is around 81%. That what makes India a great country, because even though the land is very less, we have a lot of species diversity. Students. Okay. Nearly 45,000 species of plants and twice the amount of animals are recorded in India. Okay. Now, if you accept May, students, all of you know Robert May. Do all of you know Robert May, students? Robert May. He told 7 million. Okay. This is not important, students. Very important line. Nature's biological library is burning even before we can catalog the titles of all the books. That is, destruction is happening so fast that we can, before we even save some animal, it is already extinct. Before you can count them, it is extinct also. Many are extinct also. Okay. Now, there is something called as patterns of diversity. There is something called as latitudinal gradient and species area relationship. Understand. What is latitudinal gradient? You understand first of all. Let's take, here is our Earth here. Maximum population will be here near the equator. As we go down or as we go up, population will decrease. As we go up here to the equator, to the North Pole or the South Pole, the population will decrease. Population will decrease, students. Population will decrease. See here. As we go, see here, students. As we move away from the tropical region, biodiversity keeps decreasing. So if you go this way or this way also, population decreases. But students, except at one point here. See here, in this region right here, there is something called Tropic of Capricorn and Tropic of Cancer here. Now, in these two regions, Tropic of Cancer and Tropic of Capricorn, population might be high in those cases. Okay. Now, students, I'll teach you the most important point here right now. That is the species area relationship. This is called as Alexander Humboldt. This is called as species area relationship. Now, what do I mean by this? Species area relationship tells you that the more you explore, the more species you will find in an area, but only to a certain limit. That's all. Only up to a certain limit. The more you find, the more you get. For example, this is the area right now. If I start searching more and more, searching more and more, I will get more plants and trees. I'll get more trees here. I will get more trees here also. I will get more trees if I keep on searching, students. I'll get more and more trees. Okay. Increasing the area sampled increases the observed species richness, both because more individuals get included in the sample and because the large area are environmentally more heterogeneous. So more you search, more organisms you find. Okay, more you search, more organisms you find. And here, students, in examination they can ask you what is equation, they can ask you what is log S, they can ask you what is C, what is Z, what is A. So that is very important, students. Okay, I've given it right here, students. What is S, what is C, what is A? The most of the time, they have generally asked you what is Z here. That is y-intercept. Sorry, that is slope of the line. Slope of the line. Okay. Now, what is the important species diversity? Understand. Now, here, students, here they can ask you something called as David-Tillman experiment. This is called as David-Tillman, students. When David-Tillman observed that, students, David-Tillman observed that whenever in an area, if there is a variety of plants, and in one area, if you have only one type of plant, what happens there, students? Area with multiple different types of plant will show higher productivity comparatively. It will show, students, higher productivity. It will show very low productivity. Very low productivity. Okay, because genetic variability can bring out multiple competition, provide more resistance also. Provide more resistance. Okay. Now, what is Rivet-Popper hypothesis, student? What is Rivet-Popper hypothesis? Understand, student. Understand. Rivet-Popper hypothesis is very, very simple. Very simple, students. Here we understand is that here this nut and bolt is called as a rivet, and here our Paul Ehrlich, students. Paul Ehrlich is telling this rivet is like a species here. Rivet is like a species. This entire aeroplane is like a ecosystem here. Ecosystem here. Now, if you remove one nut, nothing will happen. A species will not, the ecosystem will not collapse. But one by one, students, if I remove one by one, if I remove all the nuts one by one, what will happen? Eventually, the entire aeroplane will go collapse. Same thing, students. Same thing happens in an ecosystem. If I remove one species, there might not be a problem. But if I remove one by one, if I make all the species go extinct, then the entire ecosystem will also collapse eventually. Now, again, students, similar to that, let's say if I have one rivet on the wing, if I remove this rivet, the entire wing will come off. Very dangerous. One rivet is, let's say, present near this door here. If I remove this rivet, entire door will come off. Now, such rivets are more important. Some species are more important. The more important species are called as what? Keystone species. They're called as keystone species. Those species are very, very important. Okay, they're very, very important. You cannot remove all of them. Okay. Now, biodiversity loss is happening, all of us know. Okay. Species loss is happening at very concentrated more than speciation. Speciation. Okay. Speciation can occur only after a few decades or few thousands of years, but it takes a few years to completely kill an organism. For example, dodo became extinct, right? Red data book will keep a track of all the different types of your species and everything. Okay. See, students, dodo became extinct. This quagga became extinct. Stellar seacow became extinct. Three subspecies of your tiger became extinct here. Bali, Javan, and Caspian, they became extinct here. They became extinct. Okay, all of them became extinct here, students. Now, students, such mass extinction has happened before also. Like all of you know, there were dinosaurs before dinosaurs. All dinosaurs died. Such mass extinction has happened before, but this time it is happening at a very faster rate. Okay, happening at a faster rate, students. See, the difference in rate of current species extinction rate is that it is 100 to 1000 times more faster. It is 100 to 1000 times more faster right now. Okay, see, students, who will become much more faster? Probably polar bear will become much more faster extent. Okay. This is the sixth one, students. This is the sixth one right now. Current one is sixth one. Now, students, there is something called as cause of biodiversity. What do you mean by causes? There are four main reasons for biodiversity loss. All four of them are called as evil quadrant. Now, students, every single NEET examination, one question will come from here for sure. For sure, one question will come from here. For sure, it will come. Okay, for sure, it will come. Now, here all of you need to understand here is that now first one is called as habitat loss and fragmentation. Now here this is a PYQ because it is the most important one. Now in habitat loss, what are we doing is we are removing We are removing the organism and we are completely destroying the habitat. Habitat is destroyed, gone. Here example is your Amazon rainforest. Okay. Now what is overexploitation? Overexploitation is that we are using one animal or one bird very too usage, and we are killing everything. Here example you have to remember, students, example is stellar sea curve and passenger pigeon here. Now what is alien species invasion, students? Alien species invasion is a condition where some organism from somewhere else is coming into the habitat and it is killing all the habitats there. Done. Same thing. Now here, students, examples are very important here. Nile perch for cichlid fishes in Lake Victoria, fishes. Then Lantana camera Parthenium water hyacinth. Then African catfish, that is Clarus. Example is very important. Co-extinction is very simple, students. Co-extinction is very simple again. In co-extinction, two organisms are interdependent on each other. If one becomes extinct, other also becomes extinct. Okay, co-extinction. Best example is, let's say, a fig and wasp. Fig and wasp are related too closely to each other. If the fig becomes extinct, wasp also becomes extinct. Now, why should we save environment? First is called as narrow utilitarian, broad and ethical. What is narrow, students? Economical benefits we get from nature. We get a lot of food, rice, we get timber, we get a lot of metabolites from your forest. So we should save forest. Second is called as broad utilitarian. From our nature, we obtain oxygen, yet, so we should save it. Other is called as ethical. What is ethical, students? Ethical means that this earth is not only ours, we share the earth with other organisms also. So we need to save our earth, not only for us, even for them also we need to save the earth. Okay, see here. Resins, dye, lubricants, everything we get from our earth. So we have to save. Okay, see, 20% total oxygen comes from the earth itself. Pollination happens for free of cost. Imagine if you had to do pollination, very difficult. Okay, intangible benefits. Ethical is that we share the earth with others. Okay. So students, here this bioprospecting is very important. They can ask you as a this question as PYQ. Now what is in situ ex situ? Understand, students. In situ ex situ. See here. Now here examination what they can ask, students. This can be given in situ. They will give you multiple options. In situ we are saving a organism in its own habitat. Here students, sometimes many students get confused between national park and zoological park. Zoological park is for ex situ, remember that. Here always remember, students, national park is for in situ. But don't get confused this much. This you don't have to get confused. Okay, in situ. Here students, what is endemism? Endemism is a concept where one organism is confined to one area. You cannot find this organism anywhere else. You cannot find kangaroo in your house tomorrow. You cannot find a penguin on the road tomorrow. Not possible. You cannot find a penguin. Okay, not possible at all. So endemism is that one organism is confined to one area. Confined to one area, students. Now students, here, this is a PYQ here. 3 hotspots: Western Ghats, Sri Lanka, and Indo-Burma and Himalayan cover. They can ask you this question. Now they have asked this question as a PYQ here. Examples of sacred groves. Examples of sacred groves here: Khasi and Jaintia in hills in Meghalaya, Aravalli hills of Rajasthan, Western Ghats regions of your Karnataka and Maharashtra, and Saguja, right, Chanda and Bastar areas of Madhya Pradesh. In Meghalaya, sacred groves are last refuge for large number of rare forest. Students, remember, sacred groves is an example of in situ. Example of in situ right here. In situ. Okay. This also is a PYQ, students. 14 biospheres, 90 national parks, 448 wildlife sanctuaries. Ex situ, students, all of you know the ex situ. Botanical gardens, zoological parks, cryopreservation, seed bank, all that is ex situ. Ex situ, students. Okay. Now here, students, one more thing I forgot to tell you here. This is very important here. Okay, very important here. Questions have come from here. First one is called as World Summit. Okay. World Summit, why was it done? Sustainable Development 2002, Johannesburg. Okay. That is a World Summit. Okay, 2002 one. Okay. Other one is called as Earth Summit. Earth Summit, which is happening Rio de Janeiro. Why was it done, students? The main aim is measured to conservation of biodiversity and sustainable development. That is the main aim here. Aim of World Summit is what, students? This is the aim here. Significant reduction in current state of biodiversity loss. That is the aim here. So these two aims you should know. Year you should know, students. Year you should know here. An aim, an Earth Summit, World Summit. Johannesburg 2002, Rio de Janeiro 1992. This if you remember, you're good to go, students. Remember, you're good to go, students. Okay. So I think that's it for today's class, students. I hope we can stop here. Right. I didn't think it will take so much of time, but ecology is okay. Ecology is very, very important. Ecology is very important. The whole point of ecology, students, is that question can come from any line. And there are few lines where question every year it comes. For example, evil quadrant, very important. NPP, GPV, very important. Okay. Rivet popper hypothesis, very important again. Species area relationship, very important. They can ask you population attributes, death rate, birth rate, population dynamics, sex ratio. They can ask you a question from there. Okay. Then, especially population interactions, every single year one question will come. Especially in the predation and competition. Many questions are there. Competitive release, resource partitioning, right? The advantages or the values which we learn from predation, all very important. Okay. Again, what are the defense mechanisms? We can learn from there also. So ecology is a set of multiple concepts are there here and there, multiple examples are there that you need to know. Okay, students. So that's it for today's class, students. Thank you so much. Right. I will see all of you tomorrow. Right. So bye bye, students. Take care. I hope all of you sleep well and take care, students. I think we started at 10:30, right? 10:30, 11:30, 12:30, 1:30, 2:30, 3:30. 5 hours, students. 5 hours done. Okay, students. Thank you so much. I hope all of you studied a lot. You enjoyed a lot. You learned a lot. And I hope all of you deserve a good rest right now. So go right now, get a good night's sleep, and thank you so much, students. Do not forget to leave a comment. Do not forget to in the comment section how was today's class. Until then, take care, students. Bye bye. Students, that message is actually sent by one of students.